Test.
It's called mute.
Test.
Okay, this is the speakers. This must be the camera.
Test. Test. Test, test, test.
Okay, stream is working.
This October marks a very special milestone.
Hello, folks. We're going to get started. Sorry we're a couple minutes late. Thank you to the SCaLE team for helping us out. So, quick round of applause for these guys because they've been fantastic. Thank you, guys. My name is Aaron Prisk. I'm with the Canonical community team. I'm joined here by Jason Nucciarone.
Yep, and I'm from the Ubuntu High Performance Computing team. You want to go to the next slide here? So why don't we, obviously, if you've never been to an UbuCon before, Aaron, why don't you give everyone a quick introduction to what it actually is?
Of course. So UbuCons, who've never attended one of these before, they are community-run gatherings where folks from around the Ubuntu and Linux world kind of come together, talk about their shared love and interest in Ubuntu. So it's a great place to learn, network, and just have some fun.
Yeah, and so one really interesting thing that's quite fun about UbuCons is that even though we're here today in Pasadena having this event, actually UbuCons take place all around the globe, all times of the year. So if you kind of look at the map that we have up here, you'll actually see that we've kind of seen a nice resurgence of UbuCons starting to happen. So for example, we have mainstays like UbuCon Asia, currently working to bring back UbuCon Europe, and then we also have some more smaller local events that different loco teams are actually starting to organize as kind of like part of training events to like teach people how to use open source software, kind of in an Ubuntu context, but it's quite cool to see a lot of these local communities actually starting to come back together and really start, starting to organize events that, some are quite big with hundreds of attendees, and some of them are, little small, gatherings of friends, 10, 20 people. So, yeah.
And Jason mentioned two of these. I have a photo on the left from UbuCon Asia and a photo from the right from this past year's UbuCon Latin America. So like Jason mentioned, some of these UbuCons are very small handful of friends meeting maybe at a pub, and some of these events are very large and organized. They have hundreds of attendees. UbuCon Asia was held at the Microsoft campus in Seoul, South Korea. It was an amazing event. It's a way to, I think, really showcase the incredible breadth and reach and the diversity of our community. And it helps really show our shared values that we have that stretch across cultures and boundaries and languages. And if you don't see an UbuCon in your area, consider hosting one of your own. Like I mentioned, it doesn't need to be this incredibly large organized event. It can be a couple guys gathering around, gals and girls gathering around a couple beers to talk about the thing that they love, which is Ubuntu. So you can learn more about how to host an event and find that global map over on ubucon.org. So I'll let you start this one.
Yeah, and so, one thing, maybe if you're not aware, I know recently OpenStack just celebrated its 15th birthday, which was quite fun. They had a celebration last night with birthday cake, but also last year was another really big celebration as well. It was Ubuntu's 20th birthday, so quite not old enough yet to get a drink in the United States, but almost there this year. And so it was quite big, very exciting. We had the Ubuntu Summit in The Hague back in October, which was quite fun. Brought a lot of people around. We had a video from Nirav Patel of the CEO Framework, quickly switching out the main board. It was very cool. Everybody was clapping and, went crazy on YouTube and all that, which was quite fun. But yeah, no, it's been really transformative. We've had a lot of change within the community in the last 2 years. I know big thing that we talked about last year when we brought UbuCon back to SCaLE was the matrix migration that we have been currently going through. So actually starting to kind of, maybe I say this as a kid born in the 2000s, but starting to move away from some of those old deprecated chat platforms, IRC, and actually start to use things that, Gen Z people like me like to use, like Matrix, because I like using emojis to be like, oh, thank you, Eric, for fixing my package, or, just sending a rocket emoji when I think something's cool. So, yeah, very nice stuff. But, yeah, no, so one thing that's actually really fun is that we have a very familiar voice who can go ahead and play a video here talking about 2 decades of the Ubuntu community. So hopefully the audio works here. There we go.
This October marks a very special milestone, 20 years of Ubuntu. Starting as a dream of a more human-friendly Linux desktop, a lot has changed in the past 2 decades. A lot of new releases, new platforms, and even a few new logos along the way. One thing that stayed the same was the heart of Ubuntu. You. A global community of users, enthusiasts, and contributors, all helping to spread the mission of changing the world through open source software. We couldn't have done it without you. So, where do we go from here? What do the next 20 years of Ubuntu hold? Perhaps powering the next generation of advanced robotics, helping us move more efficiently on the ground or up in space, aiding doctors and scientists in curing diseases and developing new forms of medicine, or maybe leading the effort to build a more equitable and sustainable world. But what do you think? What does Ubuntu mean to you, and where do we go from here? Let us know by visiting ubuntu.com/20 years.
Yeah, so, obviously you just saw that video there. Whoever did the voiceover, he sounds pretty cool. I hope I get to meet him one day and all that, Aaron. But yeah, no. So obviously, we know why you're here today. So obviously, in that video, we had mentioned last October, but obviously it's March now. So beware the Ides of March, as they say. Poor Caesar. But now we know why you're really here. Obviously today, we have a packed schedule full of fun and exciting talks and workshops, and we have a lot of excellent speakers. So we actually have folks from all over, the park. So for example, we have some Canonical employees who are here, from all different parts of the company. So whether you're working on like microcloud, HPC, have something there, Juju as well. And then we also have, some of our core community contributors here as well, like the lead for Ubuntu Studio and the technical lead for Ubuntu, and then also longtime Ubuntu California members, Richard. If you want to raise your hand here, say hi, Richard. Yeah, there he is. So, obviously, first of all, thank you, Richard. We wouldn't be able to be here if you and Nathan didn't do all the work that you did, to make such UbuCon at SCaLE a mainstay. But yeah, absolutely. Hey, everybody needs a hype man. So obviously, we're going to have a lot of really great speakers today. So definitely be sure to stick around. We have plenty of coffee, so why would you ever need to leave? And yeah, just bring your listening ears.
So Jason mentioned we have a lot of awesome talks today. If for some reason you haven't seen the schedule, take a look at the packet you got when you registered. Also, you can go to ubucon.org/scale where you'll find the full schedule in a description of all of our talks. And please note, if you happen to miss a talk, don't worry. All this is going to be live streamed and recorded, so you can watch it later on if for some reason you can't make it to one of the talks. And the Ubuntu Fun doesn't stop after all the talks. We've got an awesome double booth over in the exhibition wing. So please stop by. It's aggressively orange, so there's no way you're going to possibly miss it. And look for Jason's smiling face, and make sure you get yourself some really cool Ubuntu merch while you're there. I want to turn things over to two great guys that Jason already mentioned. This wouldn't be possible without these two amazing community members, Nathan Haynes and Richard Gaskin.
Oh, that's fun. Be smarter than the microphone. We can share.
No, I'm used to the hardware slider.
Oh, they have fancy microphones.
They've upgraded,
Nothing's but SCaLE.
Great, thank you.
Yeah,
okay, perfect.
I've worked with computers and IT professionally this year for 30 years, since high school. I got a job after school at high school, and as usual, when someone says, hey, this isn't working, can you take a look at it? I touch it, and immediately it starts working.
No, and that's, we do this every year, but it really is important. If you've ever tried to set up AV, if you've ever tried to organize an event like this, and this, SCaLE is a public education outreach nonprofit. So everything is recorded and then distributed for free. So this room, this conference, all the talks, all the weekend, and this is all possible because of a lot of technical expertise and discipline for the setup. And AV, the team, makes all this happen. Michael just took me outside for a minute to remind me that we have the mics, we have the full setup, and they've already synced everything this well.
Right.
So I know they get tired of hearing this every year, but I think it's worth it. Can you give AV a round of applause? Because they really earn it.
And what's important to remember, and very easy to forget, is that SCaLE is and always has been, and just like UbuCon today, run entirely by volunteers. And you would never, ever guess it. But that's why this conference remains so friendly and so fun. And so it was really nice when we started. I didn't start UbuCon. Amber Grainer came up with the idea originally. But anyway, she was the one who suggested to me, hey, you're at SCaLE. You think about doing an UbuCon? I said, okay, why not? And came together. And, we are all here. We know the Ubuntu community and how wonderful and friendly it is. And I'd been running the booth at SCaLE for a few years already, and we fit right in. SCaLE fits right in, Ubuntu fits right in. It's that spirit of community and companionship and friendship that we really love it here. We've been doing this for a decade at UbuCon.
It's been a little while, and we've had. It's been a long time. And it started with just, Amber Grainer, Nathan picked it up, I picked it up for a while, then it's been a whole lot of us, and an increasing amount of Canonical. And that's another acknowledgement that I think is important to have here. I've spent this last year refamiliarizing myself, going with a deep dive in a number of different open source communities, Nextcloud, Drupal, some WordPress, and there is a lot of variety for the governance of open source projects. Some are very healthy, amazingly so. Some are currently undergoing interesting Twitter drama. But I look at how Canonical has been going through all of the transitions over this 20-year period and their relationship with this and other community events around the world. And I look at that governance, how they are a strong company and fostering strong community contribution. Aaron, Jason, the others at Canonical have been doing a great job to bring the resources they have to bear for these community events. And I would say hats off to Canonical for being really good stewards and good examples of open source process.
Absolutely. So this is my 17th year at SCaLE and my 17th year running the Ubuntu booth. And Canonical's always been really great about sending CDs and some swag, and they've always been supporting it in the early days in small ways. And increasingly as Canonical grew and as SCaLE grew in importance, and they've always been very generous with their contributions and their time, and especially with the last UbuCons, they sent people to SCaLE and to give talks and to help out with the booth, and and UbuCon has grown. Mark Shuttleworth actually came here and was the keynote back in, I think, 2016 for SCaLE, and really liked it, and still loves us. He still asks every time I see him once a year or so, how's it going? How's SCaLE going? It's excellent. I'll disappear a little bit during the afternoon because I'm going to get the booth ready, and like I said, it's a big orange backdrop. The good news, I'm already prepared. We have, you can ask me anything at the booth, ask any booth attendee anything about Ubuntu. And the good news is that when no one hears, everyone's here is friendly and lovely, but when we get some people coming in wanting to rant about SCaLE, so that orange backdrop, I'm wearing the shirt, I can just kind of fade back and not move. So when they ask about snaps, just fade back and disappear. Don't move. They can't see you if you don't move. No, we can talk about snaps too. Now when Ubuntu first came out about 20 and almost a half years ago, I thought that sounds great, and I don't think it'll last. And so I didn't start using Ubuntu until the second release, 2 weeks after 5.04. So it'll be in the first weeks of May that I will have been using Ubuntu for 20 years. And I loved it so much, I started getting involved in the community. I said, well, SCaLE invited us, found the Ubuntu California team, and invited us to run a booth. And I've been doing this for 17 years. And thanks largely to my participation here and the warm reception we've had, I became the leader of the Ubuntu California team. I was just a volunteer, early member, and I became that, and I became on the Ubuntu Local Community Council. Now I'm on the Ubuntu Community Council, giving advice to everyone all the time, and even the Ubuntu Summits. It's really funny when people ask me, what's that like? And I'm like, it's a lot like SCaLE, a little more focused, but just really friendly. And so UbuCon here and SCaLE and so on is echoes as we all share one open source community that echoes out, and SCaLE echoes in the Ubuntu community as well. So we hope that we provide something great for you, software and everything, but SCaLE gives back, and so I'm very, very happy to be here.
We do have a lot to cover, and I don't want to eat up time.
Yeah.
But I do want to I want to go back. I don't think we need to go back to the physical slide because you remember it. It was a memorable map. We saw the world map. We saw Ubuntu-focused events around the world. We have one of our regulars here, I think, from Arizona. Is that right? We have a person here from Edinburgh. We have people from all over for the ones here in Pasadena. There are several events from around the world. I have a vision, and you can help make it happen. I would like to have a year of endless Ubuntu summer, where I can take the year and just visit UbuCons all over the planet and then just have a season of UbuCon that never ends for a whole year as we go around the planet. And now that UbuCons are becoming a global conspiracy, a global actuality, then we can make that happen. But as you return to your communities, if you want to create even small events in your place where just people come and gather at a cafe once a month and just hang out, do troubleshooting, talk about how computing affects their lives, what matters, what doesn't matter, privacy concerns, just all the things that open source can bring, and you're not sure how to get started, reach out to Nathan and I. We have contact information through the website, through SCaLE's stuff and through UbuCon, and we are happy to help you do whatever you want to do to make any organization of any size, any sort of gathering, because there's so much to be had. We had for many years an Ubuntu Hour here in Pasadena. I learned so much from that. And we would have people that would bring their laptop and say, what is up with this audio driver on this model? And then we'd have a couple of geniuses just flip their cap around backwards, dive in, and boom, that thing's working. So we had a lot of good times. If you have any interest in doing this sort of thing in your community, let us know, and if we can help.
Yep, I did an Ubuntu Hour in Lake Forest for just over a year, and just went up to Panera after work one day, I think a week. And there were about 4 people just came and hung out, chit-chatted, and I wanted to know, well, what's new, and I would just, maybe bring the laptop. It was just as little as that, and that's valuable. And this started small, one room, couple speakers, and we've been large rooms and breakout rooms and 2 tracks and several days. And, it goes big and little, but all those contributions all help. They're all fun. And the biggest thing is about spending time with each other and more community. Online community is vast and huge, and we have people to talk about that here today, but also the little ones count too. It's all, the important thing is have fun and help each other. So,
And I think we're ready to go, so we should probably shut up. I will just end with this last
It's that
invitation.
time?
If, for those of you who are staying beyond SCaLE and you have questions about things you might do in and around the Pasadena area, I'm very local and happy to help. I'll be sort of a Pasadena ambassador if I can help. So we'll just leave it at that and get on with the real stuff.
Thank you, guys. So here in about 3 minutes, we have a talk from Ken Van Dyne titled Simplify Your Data Science Workflow on Ubuntu with Canonical's Data Science Stack. So just give us a minute or two to get set up. We have coffee and stickers too. Help yourself to coffee and stickers in the back.
And we have the headsets. They were set us up with those and 2 of them.
Needs to be, okay. All right, let me mute. All right. Is that too loud? No? Okay. All right. Welcome, everybody. Sorry we're running a couple minutes late here. It took me a minute to get set up. So I want to talk a little bit about simplifying data science workflows on Ubuntu. Now, anybody who knows me would wonder, why the heck is Ken here talking about data science? I am not a data scientist. I will tell you that up front. I am not. Everybody would look at me and say, you're the desktop guy. What do we care about this on desktop? Well, a couple reasons. One, the primary use case here that we're looking for is simplifying it on your workstations. We have other solutions as well, but we're thinking about how do you do data science on your workstation. So that is definitely a desktop thing. But really, the problem we're solving is deployment. How do you install and get your data science environment set up on your system? And my expertise is actually building and deploying custom systems for over 30 years now. I've been doing software distribution for Linux for over 30 years now. So this is very much in my wheelhouse. When I do, you have a fancy NVIDIA GPU on your system. You want to make sure you can run those things that need CUDA, things like that. Having the right versions of the drivers installed, and you install these packages, repositories, or you find some online guide that has you run a shell script that you've used curl to fetch and pipe it through sudo, whatever, run the shell script that installs a bunch of junk on your machine. For one, you don't really know what that's doing, right? You don't know if you're going to get a working environment at the end of that process, and it's not reproducible, right? Like you can't set up your machine and then 6 months later say, I want to send the stuff I've been working on to my colleague sitting next to me and get their environment set up so it works correctly. You don't really know what you have. So what we've been doing is we've been working on solving these sorts of problems, simplifying that process of getting your system in a workable state in a reproducible fashion. So who cares about this? It's really anybody who wants to get started in AI. Like if you want to do some data science, machine learning kind of workflows on your machine and you don't really know where to get started, this is a great place to start. Or if you've already been doing it, but you're frustrated because things are fragile, this could also be a great solution. Our PC OEM partners care a lot. You know, they sell these very high-end, expensive workstations with big, beefy GPUs for this kind of use case. But they want a way for data scientists to get off the ground running when they buy these, expensive workstations. And enterprises with large numbers of workstations trying to do AI stuff, right? Because you want reproducible environments. You want to be able to build reproducible environments that can be used across your enterprise. There's a few parts to this I'll get into a little bit more later. But we have this concept, canonical ML ops. I'll talk more about that a little bit later. But part of what you get out of the data science, our data science stack, is ML Flow, which is a tool for kind of managing your experiments, your models. You can version your models. So as you're tuning things, you can have new versions of it. And then you can go back to old versions. You can compare results between them. You can manage your experiments that you're doing through ML Flow. And it also comes with Jupyter Labs built in. So whenever you set up any of these containers, you get a Jupyter notebook essentially as your vehicle into it. A little bit about the architecture here. So we have Ubuntu here, right? We're using microcloud as our Kubernetes distribution, but really our data science stack works with, theoretically should work with any Kubernetes distribution you want to use. But in our example here, we'll use deploy K8s on your workstation, particularly targeting, the work you do on your desktop. Then we have Jupyter Lab notebooks. You can bundle CUDA and the containers, piping up a new notebook to do work in a new project that you're working on. You create a new container, and you're off to the races. So it's really simple to install. It's kind of the point. That's what I was talking about, trying to make it easy to get up and running quickly in a reproducible kind of fashion. It's distributed as a snap. So I can definitely talk a lot more about that. but I'm in the community, but people are coming around. It's great because it's portable, right? It includes everything needed in runtime. Something could be tested on Ubuntu 24.04, but hey, you're still running 18.04. It's going to work. It's going to work exactly the same way it worked on 24.04 on 18.04. If you're It should work on OpenSUSE too. I know all of the snaps I maintain, I test on Fedora, Debian, Arch. I do not test it on OpenSUSE. Maintain or work on all those distributions. I will say I've never tested this or Data Science Stack on other distributions besides Ubuntu, but it really should work because, like I said, it gives that entire portable runtime there. Along with it. And there's some built-in confinement stuff, sandboxing, which is really nice, so applications can't access things it shouldn't access, things like that. But also, when you're done, if you don't need to do this anymore, do you really need to keep all these things laying around on your machine, maybe containers running, etc.? You can actually just snap remove Data Science Stack, and it will remove every trace that it was ever on your system, which is pretty nice since it's all very isolated in its own environment. Demo time, this will be fun. Since I actually can't see my screen here. Give me a second. All right. I'm going to start off by showing you the documentation here, because I'm actually not going to install this live on stage with flaky Wi-Fi. Okay? So I do have it all set up on my machine already, but as you can see here, oh wait, this is the wrong. All right. So there's just a few steps. It requires installing microcloud. Like I said, this is our Kate's distribution that's designed for your workstation, desktop, laptop, etc. It's designed to run just on a single machine, which is perfect for this kind of use case. You have to enable a couple of plugins in microcloud. So there's a few commands to run there. Then a simple snap install of the Data Science Stack snap, which is just one command, which is great. And then we have to initialize the Data Science Stack. So you've installed 2 snaps, enabled a couple plugins and microcloud, all very quick. Then we need to initialize the Data Science Stack. And the reason why we have to do this is I mentioned the Data Science Stack will work really with any Kubernetes distribution you have. So we need to run the DSS initialize command and pass it our kube config. So that's our configuration so it knows how to talk to your Kate's cluster. So in our case here, we'll run a microcloud command to output the config for it. So then our Data Science Stack will be configured to use your Kate's, the Kate's that is installed on your machine. All right, and then we're ready to create a notebook. Let me bring a terminal over. Hopefully that's not too big. All right, so there's a number of DSS commands. I think this will tell us all the commands possible. So you can create a new notebook. Initializes the command we already talked about. It initializes the Data Science Stack. List will list any existing notebooks that you've and not using one of these containers to have this thing running and using your GPU and things like that, right? So you can stop them when you're not using them and start them when you do need them. I'll show you what status looks like. So DSS status here will tell you the status of your instance, and it'll give you a URL, let's say private IP address to access MLflow. You'll notice here it says NVIDIA GPU is disabled, and so is the Intel GPU is disabled because I do not I don't actually have an NPU or GPU that's compatible for Intel, and I do not have an NVIDIA in my machine. If you did have an NVIDIA GPU, or a discrete Intel GPU that you want to use, there's another command in microcloud to enable the GPU operator, which is also documented on the documentation website. So it's a single command, enables the GPU operator for NVIDIA, for example, and then this line here will show the GPUs available, and then you can use CUDA stuff and things like that inside of your container. If the GPU is passed through, that should work, yes. Yep. So really what we want to do to get started here is if you do create -- help, this will give you some guidance on where to get started. There is, you can specify any image you want with the container registry reference, so you can fetch any image that's in a container registry that you would like, but we have some predefined ones. So if you just want a PyTorch one, you can create a notebook, name it whatever you want, -- image equals PyTorch. Or if you want a PyTorch with CUDA included, you can do PyTorch - CUDA. And again, these things get set up with all those tools installed inside of the container, so they're not kind of tainting your system, right? You're not installing arbitrary things from other repositories on your desktop system. You want your system to be reliable. You want to know what's running on your machine. You can just deploy these things inside of these containers. So I have, as I said, I preset up. It's not my first demo. I've got a couple notebooks here. I've got a PyTorch one and a TensorFlow one set up. Actually, the demo I'm going to do doesn't require PyTorch or TensorFlow, but I'm going to use the PyTorch one that I have. And you see there's a URL there that I can click on to go to it as well. I'm actually going to move this whole screen over here. All right, so this is, let me go to this other one actually first. So this is the TensorFlow notebook that I have. If you're not familiar, Jupyter Labs, this is a very, very common tool for data scientists to use. You essentially you can get like a Python shell in here where you can write some Python code and execute it. You can get a terminal inside the container where you can install packages, whatever you need to do, all through this kind of single interface. So this is inside of that TensorFlow container. And write a little bit of Python and hit run, and you see you can run that little line of Python, right? So this is a notebook. Another interesting feature here is you can actually drag this notebook into the shared folder there, and then go to another container that you have, and go to shared, and you can see the one that I shared from the other machine. So they're all automatically connected, and anything you drop in that shared, you can say, I've been running this other one, this other instance, I want to move it to this one. You can just drop it in the shared directory there, and it'll work. So the demo I have set up for today is a simple, it's a public model for comparing wine quality. Okay, it doesn't require a GPU. It's very quick. My little 6-year-old Intel laptop will not barf here when I try to run this. So essentially, I've got this notebook that I've prepared that has some markdown that explains what's happening, some Python code that will run, and you can just step through this in the Jupyter Notebook, and it will run each step. So you can see it just ran the two markdown ones, which do nothing, and this one here is, oh, well, I hope this doesn't blow up. That wasn't supposed to happen. It should be installing a bunch of Python. Oh, what happened? I do, but I have. I was connected on my hotspot, which seemed to be working before. Huh. Is there Ethernet here? I got one right here. I think I actually have a regular port here. Yeah, that's even better. Okay, thanks. That was great. I should have used that from the beginning here. All right, so let me make sure that I'm not. All right. Turn off Wi-Fi. All right, now let's. But this is actually running on my local machine. It should be fine. The demo, the live demo, always. Let me, I don't seem to actually have network. Yeah, I do actually. Okay. Maybe it will work now. I broke it. Yep, absolutely. All right, so let me, is that the upload icon? I can't see. Okay. Oops. All right, reopen this thing. All right. I can get back to where we were. Why isn't that actually outputting anything? Yeah, but I still think it would have spewed some output there. Well, let's see if this next one fails when I run it. Yeah, I think I need to restart the kernel thing here. Let's try that. Yeah, but I would think this would give me an error that it couldn't connect. It's like not even trying to run that. Oh, that's why. This is, the status got changed to code, to raw, not code. That's running. Here we go. Yes. Oh, sorry. So that first line of code in there was a pip install. Any line that starts with an exclamation point is like basically running a command. The other lines in here are mostly Python code, but this is installing all the Python packages necessary for this particular notebook. All right, so it's not quite done yet. But the way, if you're not familiar with Jupyter notebooks, each of these little blocks here are separate steps, and you can run them all, or you can run them one at a time if you want, or you can rerun them. It's basically just executing whatever code's inside. The container's already been created. When I did the DSS create command, which I did not do on stage, it fetches the container and provisions it, sets it all up. And it sets up like that shared directory and things that I talked about. It sets up a connection to MLflow, which I'll show you in a minute, because when I run these experiments, it'll actually register something in MLflow, so you can see the results and compare and things like that for your tuning. Like you're talking about CUDA versions? Yeah, like CUDA versions. So the CUDA versions are usually reliably backwards compatible.
I've definitely run into situations where we've had to go back to this. So my question is there pinning built into, like, is that sort of pairing logic?
Well, the NVIDIA drivers for your GPU is on your host system, so whatever version you have installed on your host system, and CUDA would be inside of the container. And whoever maintains that container controls what version of CUDA is in it. Yeah. Yeah, and you can create your own containers. You can point it to your own container registry, so like you could maintain the content yourself of what will be in these containers. So if you want to, kind of create one that you can use throughout your enterprise and have your own container registry, it's pretty trivial to do that.
Actually, I've got a good example. I ran a container that was designed specifically for Kepler NVIDIA graphics accelerators. So it used Kepler's antiquated CUDA. And the current, I think 12.8 CUDA doesn't necessarily always play nice with that code. Right. So yeah, I exactly. I've run into exactly.
Right. But there, I mean, you can go up to near bleeding edge oftentimes, but if you step over incompatibility,
Okay.
I'm just wondering if there's that logic that you're saying it's outside.
Yes, but if you craft your own containers, you can control what version's in that container. All right, so now we'll go to the next step. That one's done. So all the Python modules are installed, and this one really just is a few imports to get the environment set up. That should have just run. I don't think it outputs anything. What's going on here? All right, this next step here, we'll download a CSV file of our data that we're going to use for our experiment. And I'm not getting any output here. That should have given me some output too. What is going on? I think one of these didn't work. Let's try running that again. That one might not output anything. This one definitely should do something. Oh, the joys of demoing with conference Wi-Fi. but it's definitely better. Okay, that worked. Okay, good. It worked this time. It did have a network failure the first time. So in this step here, it downloaded the CSV file and read that in, and did what it needed to do to get our data. And then here, we will actually, this will set up our MLflow experiment, which I'll show you in a minute, which you can, well, actually, let me go to MLflow first and show you there's nothing there. All right, so this is MLflow. We have currently no experiments, and we should have no models. Okay, so it's empty. And we can go back to here and run this step, which will register it. All right, and we can keep going, do another. Here we'll run multiple training sessions. So this will output more stuff. There we go. All right, so this is where it's doing the training on our model. This one is, yes. It can, yeah. So the containers that I'm using are containers that are built by the Kubeflow project. But again, you can point to any container registry you want, pull anybody's containers, you can share containers. Well, so MLflow is a tool for kind of going back and viewing the data, the results. So you can look at your models, you can look at the experiments output, you can do multiple runs and compare the results. I am not an expert in that area. I do not honestly really know what I'm talking about there, but that's what MLflow is about. You can see the different runs you do, like we could run this a bunch of times, and it'll register each one of those in MLflow, and then you can go select 2 of them and compare the data results. So it's just kind of a way to manage your experiments and manage your models. Yeah, it's so, and Jupyter Notebooks doesn't directly integrate with it, but in here, the Python code we're running to do this work has some MLflow Python API calls that says go register with my MLflow. Register this experiment, here's my model, register this model with MLflow, version it. I want to version this as version 1 of my model, this is version 2 of my model, and then you can go back into MLflow and look at all that data anytime. And you can, 6 months later, go back to an old experiment you did and look at that result. All right, I think that is done, yes. Created version 1 of the model, I think it says version 1, all right. Now we can register that with MLflow. All right, that's done. This is actually uploads the model to MLflow. And then let's generate an extra artifact. So we'll use a matplot to generate a nice little graph of our results. And there's a little chart that was created, scatter plot. Now we can go to MLflow and let's refresh this. And now in MLflow we have the model that we produced there. And our experiments and the different runs. So that one run created all of these. And I can go drill down in here and look at various aspects of it, but I can't see the screen well enough to really do that. But you could select 2 different ones and do a comparison. Let's see what that looks like here. I'm not actually, there we go. And there is that the compare? I think it is. is. So there's not a lot of data there to compare, but you see you get a UI to look through your experiments and compare those results. Okay. Right. And where is my other window here? All right, so some of the benefits, I already mentioned some of this, is, it's really built with the developer in mind. It's 100% open source. It's native to Ubuntu, but it doesn't have to only work on Ubuntu. You could use it elsewhere. Run anywhere, desktop, cloud, the edge. Actually, a lot of these same tools. We have a charmed kubeflow, which gives you some of the same MLOps capabilities, but if you want to run it in the cloud, for example, as opposed to on your local workstation, the flow is very similar. One vendor for the whole ML lifecycle, so basically you don't have to go and download this from so-and-so and this from somebody else and try to make it all work together. We've done that integration for you. Getting started is easy. The data science stack is really kind of the first step to do your local development on your local workstation. And once you kind of prove things out or you get to the point where you want to collaborate with some other folks, you could actually scale that up and do, I guess we'll talk more about charms later with the Juju talk, but you could actually have something that runs on the cloud somewhere. Then you could share your models and have that same MO flow kind of experience, but not just on your desktop. And then ultimately deploy to the edge. Like maybe you're training your model because you want this thing to do some inference on an edge device somewhere, and you can ultimately deploy that to the edge. But that's done outside of data science stack. So as you can see here, the data science stack is really built for that first two steps, the build and optimize. You could use charm kubeflow to do the entire thing. You can do everything, even the deployment, which you can't do with the data science stack, for deploying stuff to run like in production. But it's a great developer environment. So some of the value adds here for our ML ops, like I said probably 15 times already, reproducible and predictable. Like you want to be able to set up your environment and set up another workstation exactly the same way. This is really your best bet. This is the best way to do that. And again, the same technologies can be used in the cloud, so you can roll out this sort of thing once you're comfortable using this and just deploy it somewhere else and then do that shared sort of development kind of model. And these are some of the enterprise kind of use cases here. Obviously workstations, we have smack dab in the middle there. Imagine you go buy your Dell workstation with 4 GPUs in it, and you really want to be able to do some great development. These partners want you to be able to get up and running and utilize that hardware and get the most value out of that hardware. So they really care about this. This also works in WSL. So if you're on a Windows system and you want to deploy the same sort of stack, the process to getting it up and running is exactly the same in WSL. So you could be on a Windows machine and still use the data science stack in WSL. Please install and provide feedback. So it's, like I said, it's available in the Snap Store. I will provide links to the demo that I use. So if you want to play around with it yourself, the notebook, I will provide links to that. I will provide links to our Matrix channel where you can talk to the data science stack and kubeflow developers that work on these things. And I will, and I'll share a link to the documentation as well. I'll share all that on Mastodon and I'll tag UbuCon later. So take a look there if you're looking for it, and feel free to hit me up afterwards if you guys have questions. We have some time for questions now, and I think I have Stefano on Google Meet here. Is he here? Oh, I think I lost him. When I disconnected the network, it hung up on him. Okay, great. Well, while this thing thinks about joining, so Stefano is our product manager for the data science stack. He couldn't be here today, but he is supposed to be available for questions if I can get Google Meet to connect. Do we have any questions? Why don't you get started asking?
Yeah, I'll run the mic to you. I'll run the. I got. Okay. All right. There we go. Sorry. Hardware is hard. I'm a software guy, but yeah. So I'll run the mic to anyone if you have a question. That way, people on the live stream and also the recording can also hear your question as well. So that way, everyone can participate.
I'm just curious. I never tried, but I saw you using the TensorFlow and PyTorch in the container registries. I was just curious, like, can we also use LLM models, which are going on right now a lot, to be deployed on these container registries, and maybe it can run on this entire notebook itself?
If I understand your question correctly, that's probably a better question for Stefano, our data science guy. But I think the answer is probably yes. I mean, you should, anything that you can get into the container, you can use. Like you can fetch a model that's already been pre-trained and then do additional work on that. You should even be able to upload that model into MLflow and then access that from inside the notebook. Does that answer your question? Yeah, yeah, okay.
Any more questions? Hey, here you go.
Hi. So it seems to me that, and I'm not familiar with Jupyter Notebooks, I guess, but it seems to me that running pip install, especially if you're sharing work with other people, gives you a chance to, I don't know, lose access to a version of a package and blah, blah, blah. Are there any ways or functions you can talk about of building and sharing containers as it's related to this, or that's something that's sort of outside the scope of your project?
I would say it's related. So yes, I used pip to install some Python modules from the Jupyter Notebook, but also inside that Jupyter Notebook, there you can get a terminal, and in that you can use like apt to install packages, for example, things like that inside of that container. But also, as I was talking, you could create your own containers that can then be shared, so your colleagues can use the same container. So maybe that container has all the Python modules versioned the way you expect, so you don't have to use pip. So it's reproducible. Back there?
All right, I got that.
Yeah, you could specify versions in that too. But I get the point though, as far as reproducibility, right? Like what happens if that version is no longer available a year later and somebody tries to run this thing? I mean, I have seen it happen. But again, you can craft your own, and I would definitely encourage like enterprises that want to have reproducibility to craft their own containers and use their own container registry. So then you can point to this container and then you're grabbing the same container that your colleague used for the same experiment.
Marshall, wait. Talking to the mic so everyone can hear you.
Sorry. I'll also let you know that it is also possible to create a virtual environment inside the Jupyter Notebook, so you can technically build data outside of the container, right? As long as you have a mount, you can basically store every package that you would need, and you can share that with other users as well. If you're curious, I maintain one of those machine learning containers myself. It's called CTPO, CUDA, TensorFlow, PyTorch, OpenCV. And I actually have a description in the GitHub on the entire process for exactly that. I like to run those things within Podman, so I can basically drop down to being myself, right? Not root within the container. Happy to talk more about that later if you're comfortable.
Any more questions? All right. Well, thank you, everybody. I appreciate it. If you have other questions later on, I'll be here all day. Feel free to hit me up. If you want to talk about other things Ubuntu or snaps or whatever, also hit me up. I'm always happy to talk about those topics. So thank you, everybody.
Alexic.
All right, folks. So our next talk here will start on the hour at 11. So it'll be about microcloud with our good friend Miona here. In the meantime, while she gets set up here, we do have some coffee and drinks in the back, so feel free to help yourself. We also have some stickers as well if you want to pick up some Ubuntu swag before you potentially head out to the next talk or take a bit of a break. So yeah, see you back here at 11 for talk about microcloud.
Check, check.
Testing, testing. Works fine.
Check, check.
Test 1, 2, 3. Test 1, 2, 3.
Testing, testing.
Hello. Oh, shit. All right. Sorry. All right, everyone, we're about to get started in a few minutes here. When I mean a few, I mean a couple. So if you could start finding your way to your seats, please, before we get started with the next talk here. Would really appreciate that. Thank you.
Can you define the difference between several, few, many, and a couple?
Yeah. So several is 5 or more. You know, a few is 3. Couple is 2. Many, I don't know. I just give up after that point. Maybe.
That's a lot.
Well, you know, there's a quarter till 2. Never quite figured out if that's like 1:45 or 2:15.
Literally 1:45. Yeah, literally. Quarter after 2 is 2:15. A quarter to 2 is 2:45. But what if you just say a quarter to?
What if I say when the sun's like high in the sky, you know?
It depends on where on the earth you are. Sad that he doesn't know how. You are.
Hey, I know how to read an analog clock, thank you. All right, folks, feel free to sit in the open middle seats here. Pretty cozy. Don't be afraid of sitting in the front. All right, so why don't we go ahead and get started here. Last few folks, you know, come on, filter in. But yeah, all right, so we're going to start with our next talk here. So why don't you introduce yourself?
Hi, everyone. Do you hear me well? Okay, so my name is Miona Aleksic. I'm a product manager at Canonical. And together with 2 of my colleagues that are sitting over there, Kaden and Simon, we will be talking about all things microcloud today. As you can see, the title of this talk is how you can build your own cloud and basically explore microclouds, specifically for home lab use cases, because we thought that might be interesting for the audience that comes to this conference. But microcloud is a production-grade product. We have customers using it for their production workload, so home labs is not the only things you can use it for. So the agenda for today is basically we'll talk very briefly about why should you have a home lab? Again, I imagine many of you already have it, but for those that don't and are thinking about having one, I'll just briefly cover what are some of the things you should consider when building your home lab. We will talk, of course, about what is microcloud and how can you use it in your home lab environment. We'll do a couple of demos and show some practical things you can do with microcloud, and then, of course, we'll leave some time for questions as well. So feel free to think about things you would want to know that we might not cover in the presentation. So I do imagine many of you do already have a home lab, but for those that don't and are maybe thinking about having one, in addition to, of course, your laptop or your workstation, home labs can be super useful for development, learning, experimentation, simply because you can create something that has more resources, more flexibility, but you can also think about things like security and so on and create something that is really fun and that can really help you be more productive and do better work. You can use it also for cost-effective testing, simply because sometimes your laptop might not be enough for all the things you want to do. I know mine is not, so when I do things on a microcloud, I can do a lot of other cool things. And it simply gives you a lot of flexibility and control, so you can really tailor it to your own needs and do the things that you need to do. What are some of the things that you should consider before setting up a home lab? Well, obviously, hardware and equipment is probably the most important thing. And that goes kind of hand in hand with space that you have, because obviously you should pick hardware that can do the things that you want it to do. But depending on what kind of space you have, what kind of power you have, whether you need cooling or not, you might want to consider different things. And we'll give an example of something that we have done. Once you've selected your hardware, you need to think about software and virtualization that you would run so that you can access your infrastructure in an easy way. And that's really where microcloud comes in. You need to think about your network setup, especially if you're going to be running some risky things. You might want to isolate your lab from the other things you have running in your home network. And then you should think about security, data integrity, and probably having backups for some of the important things you might be running there. So enter microcloud. Why is microcloud really useful for this? We will be showcasing some of the practicalities a bit later, but I wanted to talk about some of the main benefits on why microcloud is really useful, particularly for a home lab use case. First and foremost, it's resource efficiency, because microcloud itself doesn't really consume much, which means that even if you run it on hardware that is not that beefy, you would have more resources left for your actual workloads, as opposed to what microcloud control plane needs to run itself. Deployment and operations are very simple, which is also something that is super nifty, because you would probably want to spend more time developing things as opposed to, maintaining the underlying infrastructure, which can be, sometimes very annoying. And then also microcloud itself has fairly low hardware requirements, which means that if right now you don't have resources to buy super beefy, super expensive hardware, but you have some older hardware that is lying around, you can still deploy microcloud on top, and it can still give you quite a lot for very little. So what exactly is microcloud? It's a lightweight open source cloud platform that is comprised of 3 main elements. It uses LXD as the virtualization layer, and then it combines it with software-defined storage and software-defined networking, so you can have highly available cloud that uses distributed storage and networking and can give you a lot of benefits because of that. What is different with microcloud than some of the other things is just the way that it's designed and the way that we are distributing these components. And Ken before was mentioning snaps. I'm going to mention snaps as well. I know it can be a controversial thing, but as Ken was also mentioning, like when we talk about infrastructure use cases, snaps can be super, super useful because they allow us to install things in a much easier way, but also to maintain things in a much easier way. Because with infrastructure stuff, you have a lot of dependencies, you have a lot of packages that you would need, a lot of things that your stuff might depend on. And by packaging each of these infrastructure components inside a snap, all of the dependencies are already there. So you don't need to think about it. You install the snap and it's ready to go. And that's really the reason why we call it microcloud and microceph and microVN. It's not because it's small, although it is, but it's because it has a low footprint, which means that you can really run it on a variety of devices without it being too problematic. So I want to take a moment just to talk about LXD. And out of curiosity, how many people here in the room have tried LXD before? Yeah, that's nice. So, well, I hope that those that haven't will try it after this. But it's basically an open source virtualization platform that has been developed by Canonical since 2015. It all started with system containers that were based on LXC or Linux containers, and that was our main focus for quite a while. And then over the years, we have also added support for KVM-based virtual machines, and then added a lot of different functionalities. We'll showcase some of them, but basically nowadays, LXD has quite a lot of built-in management features that allow you to configure it in many different ways. And that's really the component that governs the interaction with storage and networking. So while the microcloud snap kind of brings all of these components together, your main interface is really LXD, and that's what you would use to launch your workloads, to configure your networks, etc. We have been, since the beginning, following the Ubuntu release cadence, which means that we have LTS releases every 2 years that are released at the same time. So the previous one was released last year along with 2404. Next one is planned next year. And then we also do periodic feature releases, which would basically have the latest and greatest things that we have added. And those are probably the ones that are good to use for development use cases because they would have the newest things. In terms of the way you can interact with it, it has a web UI, which we will showcase a bit later. Of course, you can use the CLI, which we will also be showcasing during our demos. And of course, everything is REST API based, so you can integrate it with any tools you might be using. We have a Terraform provider, for example, so if you want to use infrastructure as code, you can do that too. I do want to spend just 1 minute also talking about system containers, because this is not something that everyone is aware of. Because we know containers, but usually when we say containers, we think about OCI containers. We don't think about system containers, and they're a little bit different. So the 2 main type of workloads we see nowadays are either, as I said, OCI containers, which kind of give you an application or a process in terms of the isolation of the thing you get to work with. And they're a very light footprint because they utilize the kernel of the host, so you don't have the overhead of virtualization and so on. And then, of course, we have virtual machines on the other side that give you a full system, but they have a heavy footprint because they virtualize another kernel. System containers actually kind of have the best of both worlds because they have the light footprint, they utilize the kernel of the host, there's no virtualization involved, but they give you a full operating system, which means that you can use it in the same way you would use a virtual machine. You can install things, launch things, but you can do that in a much more lightweight way, which, well, for a home lab use case, it's particularly useful. Important thing to mention when it comes to specifically system containers and the way LXD provides them is that we are providing unprivileged containers by default, which means that you don't have access to certain parts of your system that OCI's containers do. You can allow privileges if you need to, but that's something that you opt in if you want to. So by default, it's more secure and it doesn't allow you to access some of the more privileged things. So what are some of the practical use cases that you could use microcloud in a home lab setting? Well, you can use it for software development. Of course, you can use system containers as reproducible development environments where you can test different versions of your software or run locally hosted software in an isolated and a secure manner. You can use it for your personal cloud, simply to have a cloud environment where you can do things like host media servers or Minecraft servers or file shares or things like that. You can use it for more complex things like simulating a distributed system or using containers for databases, web servers, things like that, so you can kind of use it to play around or to run and learn cloud native things as well. And then probably some of the things that most users usually struggle with is networking. So if you're on microcloud, you can actually practice networking. So you can test different network configurations, you can simulate multi-cloud environments, you can implement firewalls, and do that all in kind of a secure and controlled and isolated environment without messing up the rest of your things that you might be running. So let's talk about an example microcloud setup. And here we have this box that unfortunately is not working because it came all the way from Sweden and something moved inside of it while it was on these long flights from Europe all the way here. But it did work just before I left for US. So I do promise it does usually work. But this is basically a small demo box that we designed about 1.5 years ago when we were launching microcloud. We wanted to have something that is small but powerful, that is portable, that we can kind of put in a sports bag and take around on the conferences and so on, and have it work usually. But either way, so what's inside this specific microcloud box? So we have been using these Odroid motherboards. For those that are not familiar, Odroid is a Korean manufacturer that does this pretty powerful boards that you can customize in a lot of different ways. Each of these motherboards has 16 gigabits of RAM. It has 2 external disks, an SSD and an NVMe SATA disk. One is used for local storage, one is used for distributed storage. Of course, we have some cables. We have a router so that we can figure out the networking. And then for the enclosure, we are using a Pico cluster enclosure. This was just an easy thing for us to get because it's kind of designed to support these boards. It includes a switch, a power, and a fan, so all of it kind of comes together. And we did a little bit of do-it-yourself type of thing because this enclosure is actually designed for 6 boards, but we have 3, and then we're using the other half to host the extra disks and stuff because otherwise there would be no space. So it worked pretty well for us until today when we tried to turn it on here. Also, I mean, we built this, as I said, about 1.5 years ago. Back then, everything together costed about $2,000 US. You can, of course, go cheaper, you can go more expensive. There are many different things. This is just something that we chose at that point. And then, what does setting up a microcloud actually looks like? So, once we got all this hardware, we built the box. We actually burned the switch when we were building the box because we used the wrong cable, but we were able to work around it a bit later. We installed Ubuntu server on all of these boards, but you could also install Ubuntu Core if you really want to run it in a even more lightweight way. And then everything you need to do is basically install all the relevant snaps on each of the systems, and then you need to run microcloud init on one of them. and microcloud join on others. What will happen later is that microcloud will kind of reach out to all of these systems. It will recognize what's there. It will recognize all the various devices that are there. And then it will ask you a series of questions. We'll be demoing that in a second. But basically, it will ask you if you want to set up local storage, if you want to set up distributed storage, if you want to encrypt your disks, if you want to set up dedicated networks for a variety of things. But it's really just an interactive CLI where you answer some questions. And then once you answer the questions, it just configures everything on its own, so you don't really need to do any of it. So you can have a fully functional cloud up and running in a matter of minutes. Once it's deployed, this is more or less what is running there. So each of these nodes, it's having local storage. It has, as I said, a disk for distributed storage, and then Microsoft is spread across the entire cluster, which means that it gives you data redundancy, and if one of the machines goes down, all of the data is still there and you can move workloads around. LXD is also deployed across the whole cluster, and same with networking. So I've been talking a lot, so maybe it's better if we actually see these things in action. So I will hand it over to my colleagues and they will explain some of the things. We were lucky enough that we did pre-recorded demos. Hopefully you can see them enough on the screen. In case you don't, come talk to us later and we can show you more directly, and then you can see some of the details you might not be able to notice right now. So Simon, take it away.
Thank you, Miona.
So they are uploaded on YouTube. They are currently unlisted, but I suppose we can just write the description in the box and then I also list them. So they're around, and we can also share the slides for those that are interested.
So it should be loading eventually.
So I plugged in the Ethernet cable, so it should work a bit better, but maybe it doesn't, so
No,
let's see. Yeah.
it's coming. All right, so let's first start with what we have. So in this demo, we're going to initialize a microcloud made up of 3 virtual machines. We've been using virtual machine just for the sake of the demo because it's the exact same process if you were to do it on physical machines. Wow, that's okay. So here we have 4 terminals. Top left is some network information that will be used to provision oven, and the other 3 terminals are root shells on the 3 machines that we will be clustering together. We see that all 3 machines have the same set of snaps already installed, so that microcloud is able to do its job. So. Is that, well, the resolution is still crappy, right? It doesn't get any better, though.
We'll have this at the booth later, so you can also pass by and we can just rerun these videos. They're pretty short, but yeah, hopefully you can at least understand what's going on. Cannot switch off, turn off the light.
Well, problem is...
I'm trying to find out. I'm a software guy. Hey!
Thank you. All right, so we've picked Micro 1 to be the initialization node. So we run microcloud in it, and the first question it asks is if we want to create a single node microcluster, which is a viable option. But in that demo, we decided to not go with that option and instead go with multiple nodes. So it asks which network to use for discovering all of those other nodes. And after that, it provides you with a passphrase that is randomly generated for that joining session. And that passphrase is meant to be easily typable and memorable. So if you have to run around in your data center and type it on multiple machines, it should be easy for you to do so. So once you've provided that shared passphrase, there you go, text is crisp now. So once you've typed that passphrase onto your joining nodes, they will show up as available candidates to onboard onto your cloud. And once you've selected them, you will be provided with a list of all of the disk that they come with, and you select which you'd like to use for local storage through ZFS, and if you have any left, you can use them for remote storage through Ceph, and you will then gain highly available storage. The highly available storage is entirely optional. You're free to not use it, and you will still have a microcloud functional, just minus the HA storage. So here we see that we were also asked if we wanted to add a dedicated network for Oven, which we did, and we're feeding configuration option so that Oven can provide internet connectivity to our workloads. So once microcloud has all of those answers, it's able to go around and configure all of the individual components like microceph, microoven, and LexD, and cluster them together. And in the LexD case, it also makes sure to create a profile that by default will have your instance backed by the remote storage, which is highly available thanks to Ceph, and the distributed network thanks to Oven. And yeah, once it's done setting up those daemons in a clustered fashion, you are able to interrogate each of those and run their status command and report of their individual member health. And you can also run the microcloud status and get a meta overview of all of those daemons and the cluster itself. And once the microcluster reports as all healthy nodes, you're able to interact with your cloud through the lexc commands and then launch instances however you like. So we see the microcloud status is all green.
Before you move on to the next demo, I just wanted to mention, because we've done quite a lot of testing on this. So deploying a 3-node microcloud takes about, well, you saw maybe 2-3 minutes. If you want to run a bigger cluster of, let's say, 20-ish nodes, it takes about maybe 5 to 7 minutes. So again, like, you can very, very easily, as long as you have your machines ready, provisioned with an operating system, you can simply provision your cloud in a matter of minutes and have it up and running. And you can do it in a repeatable way. So every time you do it, it will look the same, it will behave the same. And also we do support doing this via pre-seed files. So if you don't want to do the interactive mode, you can just basically create a YAML file with all of these answers and then just feed it to each of the machines, and then microcloud will be ready to go.
Thank you, indeed. So now that you have your microcloud up and running, let's see how you can benefit from the highly available feature that you gain from it. So in that demo, what we have is the same microcloud made out of micro 1, 2, and 3, and it's powering 4 instances. So 3 LLM nodes, one running off of each of the micro 1, 2, and 3, and we also have a virtual machine, which is called V1, running out of micro 3. The virtual machine is configured in a way that whenever the host powering it undergoes maintenance, it's going to be live migrated to another machine, while the LLM nodes, since they're working all together to provide a highly available service, they will go down along with their powering host. So they're not configured to be migrated away. So we also have the terminal in the middle, where we have a repeated query to the LLM service, responding to the same question, but we see who responds to the question, which LLM node provided the answer. And here we're going to simulate some maintenance that we need to do on the micro 3 machine. So we start by listing all of the cluster members, 1, 2, and 3. They're all operational. And since we want to evacuate micro 3 so that we move the VM away, and we cleanly shut down LLM node 3, so it will be removed from the rotation of the LLM answers, but the service will still remain available because the other nodes are picking up the slack. And once we've evacuated, we can do the whatever maintenance we needed to do on it, whether powering it off, add some memory, or change the disk, or whatever, bring it back on. And when it's powering back on, all of the daemons that are part of the cloud, like Ceph, Oven, and LXD, will reestablish connection with their counterparts on other cluster members. And once they will all be functional again, we will be able to restore the node into the cluster, at which point the instance it was powering that was stopped cleanly will be powered back again, and the VM that was live migrated away from that node will be brought back onto that physical machine. So it takes a few minutes, so let's fast forward because there's no point in waiting for it. So it's currently being restored. So we see that LLM node 3 is powered back again, and it will join back the prompt rotation. And the V1 virtual machine is moved again, and we will see that its uptime is over 2 hours, so it was never powered down, despite having the initial powering host undergo power maintenance. And that's it.
Thank you, Simone. So now that we have a deployed microcloud, we're going to kind of continue with that deployment. And one of my favorite ways to use microcloud is for reproducible developer environments. So we're going to use the LXD CLI and LXD profiles to define a pretty simple Go developer environment. So just opening up this YAML file. So LXD profiles allow you to declaratively define what you want your instances to look like. So you can use cloud init by passing in cloud init YAML into the user data config key. So here I'm just adding some basic packages, installing the Golang snap, setting up some users, and setting up my Go path. And further down in the file, we have our device configuration. So here I'm just passing through a network device, which is using the LXD bridge network. And I'm also mounting a path for my home directory into the instance and setting up the root directory with just our default storage pool. Okay, so I'm just going to create a LXD profile by passing in that YAML file. And then we can launch an instance. I'm going to use the Ubuntu Noble image, call it DevBox, set some limits. We're going to give it 1 virtual CPU and 1 GB of memory, and pass in that profile. And because system containers are pretty lightweight, it's going to launch very fast. And I had already previously downloaded the Noble Ubuntu image. While we wait for cloud init, I just want to talk a bit more about LXD profiles. So we can declaratively define what we want instances to look like, not just using cloud init, but also specifying devices. So we have the ability to pass through GPU devices, storage devices, set up network configurations, and these profiles can be applied to system containers and virtual machines. Yes, you can. Okay, once cloud init is done, we can execute commands using LXD, or we could also drop a shell. In this case, I'm just grabbing the Go version. Another popular use case for microcloud is, let's say you have a production cloud on one of the public cloud providers, AWS, Azure, or Google Cloud. You can also use microcloud to simulate cloud environments. So you can simulate launching cloud type instances and run your workloads there before moving them into production. So this demo just briefly demonstrates that. Apologies for the smaller font here, but I'm just again using the LXD CLI to initialize a noble Ubuntu instance, and we can specify the type by using the type flag prefixed with the cloud provider, so AWS, and then after the colon I have the type, which is the T2 micro, and I also launched a T2 nano, and these basically just define some hardware specifications. So we have the ability to deploy as many of these instances as we want, matching our cloud provider specifications, and we can launch system containers or virtual machines. So far we've been interacting with our microcloud using the LXD CLI, but we do also have a web user interface, so I'll now pass it over to Miona to show you guys that.
And I think now you can turn on the light. We won't be showing any more terminals. So if I was showing microcloud on this box, it would say microcloud, it would have 3 systems and so on, but given that the box is not working, I'm just going to be showing you my local XD, but it looks very similar. It's just right now, this is just a single instance, it's not a cluster, so I cannot do some of the things, I cannot do live migration and so on. But I just wanted to briefly show it because maybe some of the people here are more like to click and point as opposed to use the CLI. I doubt that's the case, but still this can be useful for some. So this is really what LXD looks like. So in terms of the way work is organized, we have projects. So here on the side you can see I only have 2. I have the default one and a testing one, and I can create as many projects as I like. So if you're using microcloud in like a team environment, you can really use projects for multi-tenancy coupled with fine-grained access control so that you can define this project for this team or this person and then really specify the kind of things that they are allowed to do. So you can set up a resource limit, you can designate specific networks, etc. So you can really kind of slice and dice your microcloud as you see fit. I won't be doing too many of these things because as you can see, network is horrible and this VM has been loading for like an hour. So either way, if you go to create an instance, you have several different options. You can browse images that we provide, and I'll show those in a second. But you can also upload custom ISOs. So for example, if you wanted to launch a Windows VM, this is what you would use. Or you can also upload an instance file. So for example, if you want to upload a VMDK from elsewhere, you can use this and just upload your VM, convert it, and have it ready to go. But we do provide a library of Linux images for your convenience. Of course, we have the Ubuntu images, but we also have others. We have OpenSUSE images. Where is our OpenSUSE friend? Here they are, somewhere on the bottom. Here they are. And we have a variety of images. So we actually have cloud, desktop, and the default images. So for example, for desktop images, this is actually what I was trying to launch before that is stuck on loading on 50%. But we have desktop images so that you can launch and basically almost use it as a VDI because it can give you access to a desktop machine. Again, we do have those also for Arch and for SUSE, so you can test those out. Anyhow, once you choose your image, and I will just choose this one because it's cached already and it won't need to download things over the network. You can apply a variety of configurations here, so you can specify disk, network, and so on. I won't be doing that at this point. But if you do have a profile like Kaden was showing before, which I don't here, I did on this box, you could just apply that profile. So all the configuration that he had specified and all the cloud init stuff, it would be automatically applied. But you can also do that directly here. So if you go to cloud init, you can kind of add the things you want to do. And then once you're ready, you just do create and start. And then it should take a few seconds for it to be up and running. Once your instance is ready, you can see a bunch of things here. You can change the configuration, apply a bunch of things, access the terminal from the UI. You see a migrate button here, but in this case, this migrate button won't be a live migration button because it's, again, only one single node. But it will show you that you can move this instance to a different storage pool or to a different project. And again, if I had additional cluster members, if this were to be clustered, you would have another option there that will tell you move this instance to another cluster member. Here you have a variety of options. Again, I won't go through all of them, but basically you can, all of the things that you can do in the CLI that we have shown in the previous demos, you can do them in the UI in a very, very easy way. So let me move back to the slides. There are some questions. Who has the mic, Jason, so that we can, so everybody can hear what you're asking? So yeah, I cannot I cannot demo this here because again we don't have the full setup up and running, unfortunately. But you can do snapshots of an instance. Let me see if maybe I can do that, and you can export also things as a backup. So it's backing up, but it won't really work that well. And as we speak, we're actually working on an option to basically copy instances, or rather copy snapshots from one cluster to another, so that you can kind of set that at a certain rate and then have it done incrementally when needed.
Yeah, one more question. So for like S3
Yes.
storage?
So Ceph, why Ceph is cool is because it has block, file, and object storage all in one. So it's for backups, not yet, but it's on the roadmap. Yes.
Do you have an enterprise version?
Well, everything we do in Canonical is open source, so there is one version that is limitless. So we don't have an open source version and an enterprise version. This is the enterprise version. I think I mentioned at the beginning, we have several customers running it in production. We have a couple of government institutions. So the only thing that you need to do, so you can deploy it yourself if you want to. We do have services to deploy it for you. And then the only thing that you would need to do is just get Ubuntu Pro so that you can get access to our support and then call us if something goes wrong. But yeah, there's no licensing involved. It's all open source and available. There is no gatekeeping of any features. Yes, so that's Ubuntu Pro. So with Ubuntu Pro, you basically pay per machine per year, and then you get 24/7 support. We support not just the infrastructure, but any open source packages you might be consuming from our repositories. So it's pretty nifty because you could have microcloud, you could have the data science stack that Ken was showing before running on top, you could have some databases, and all of that would be covered under one Ubuntu Pro support, which you can see pricing online, but it's transparent. And as I said, it's per machine per year, so it doesn't matter how many cores you have, how many sockets, it's always the same. Yes, so yes, it gives you a kernel live patch. It gives you access to landscape, for example, that allows you to manage your machines. It gives you access to hardening tools. So we have sys hardening and disastig and FIPS and all of those things. So you can really use it to secure your whole stack, and then also, again, have someone to call if something goes wrong. We have managed services as well. So if you're interested in anything, just let us know. We can give you more details.
Sorry, for loading images, can you also load Ubuntu Core images?
Yes, we do. Let me see if I can show it here, because I don't know if I added that particular remote here. No, I didn't. We do have also Ubuntu Core remote. I think in the 6 for VMs, yeah. We do, and you can run them.
All right, we have another question. So I'll get you over here, and then I'll come to you.
Let me do. I can skip the summary and just leave this.
What operating systems can you run microcloud with?
Sorry, can you repeat?
What distros of Linux can you run microcloud with?
So, I mean, we run it on Ubuntu, and we support it on Ubuntu, but technically you should be able to run it on any Linux version that supports snaps, because these components are distributed as snaps. So as long as it supports snaps, you should be able to run it. But as I said, we develop, test, and support it only on Ubuntu, so if you want extra assurance from us, run it on Ubuntu.
All right.
Maybe one thing that I actually didn't mention, I think, when I was talking, is that microcloud works on both Ubuntu Server and Ubuntu Core. So that's also pretty nifty.
Coming from the world of Proxmox, when you mentioned 3-node cluster in your demo here, when you're in Proxmox and you do multi-node cluster, there's a mechanism to avoid split brain called quorum. I'm curious, is there a similar mechanism here? Because if I had a 2-node cluster, I can't achieve quorum, and then you have some things happen.
Yes, so that's the thing. So microcloud does start from a single node. However, if you run it with 1 or 2 nodes, then we don't consider it highly available exactly for these reasons. So HA starts at 3 nodes. We use Raft algorithm to kind of achieve quorum and to have voters and then the database leaders. So you need a minimum of 3 to have this kind of redundancy and high availability and to make it reliable.
Hi, apologies if you answered this earlier. I was a little
No,
late, but
just
how
shoot.
could this differ from like just an enterprise hyperconverged infrastructure where you're using a traditional KVM hypervisor?
It doesn't really. This is exactly what it is. So it's an open source hyperconverged cloud platform. What is cool about it is simply that it's a bit more efficient, a bit more optimized, because oftentimes, I mean, you know, we've been dealing with cloud over decades and we've been kind of adding things and you have a lot of moving pieces. What we wanted to do with microcloud is kind of optimize it a bit, remove some of the unnecessary pieces, and then make it operationally easier, which is why you technically have only 3 components, but they still give you quite a lot of things. But it's exactly what it is. It's a hyperconverged virtualized platform, and you can use it for anything you would, any kind of enterprise-grade platform that has been around for a while.
And then does it support Kubernetes as well?
So we would run Kubernetes inside virtual machines on top. So we are currently adding some of the foundational things that will allow us to eventually do have also Kubernetes as a service, but we won't run them on bare metal. They would always be kind of loaded in a cluster of VMs, and then you can kind of manage it how you usually would. Other questions?
Any more questions?
So feel free, like there is one more here.
Get my steps.
The UI that it showed, that only runs on the main plane instance?
So no, you can access it from any cluster member. You do need to set it up. I mean, what I have done here locally, there are 2 ways that you can set up the UI. You can authenticate it using a browser certificate, or you can do so if you have an OIDC provider. So mine is just run locally via this browser certificate. But if you have an OIDC provider, then you can set up a proper like single sign-on. You can access it from any cluster member. You can assign permissions as well. I cannot show that because I don't run it with OIDC, but you can do quite a lot of things.
All right, good questions.
One thing that I do want to mention, because I think we might have some community members from like our other versions. So we do provide quite a lot of images. We don't have every single option of the ones that are there. So if you're working with any of the other sister distributions and you would like to help us get your images here, we would gladly do that so that users that run LXD can run any of the versions, and we can provide them with images so they can do that in an easy way. So we can have a chat later if you're working on one of the other distributions. Cool. Then if we don't have any more questions, I just want to thank you for your attention. We will be around for the whole conference. We will be later at the booth, so just come and have a chat with us. If you have any specific, super tricky questions, we can try and answer those as well. So thank you very much.
All right, folks. So pretty much at this point, we have our lunch break now. So, go enjoy some grub. Tank needs fuel and all that. Just a few notes before you head out. If you are looking for some sweet Ubuntu swag, you could just go in the corner over there. I said swag, I feel so like 2007. But yeah, you can go back there, pick some stuff up. And then we'll be starting again at 1 o'clock for a community podcast hour. So if you have any questions about the Ubuntu community, feel free to stop by. And yeah, if you want to talk more with the microcloud team, get a good explanation of their little box that they have up here, be sure to come by the Ubuntu booth once the exhibit hall is open. It's very orange, so you cannot miss it. Thanks, guys, and have a good time. Enjoy lunch.
Sure. Test. Test. Gotta say something into this mic and see if it comes out the laptop. And if it does, that means that we're good.
And the guy in blue just kind of separating everything, making the transition to whoever.
You have a place you
And I'll get lost,
Wherever you
know?
want.
Yeah, you're always. That's just how your brain works, though.
I think I'll stand if that's okay. Well, then I can bounce between you or between the people there. All right. I can kneel. Okay. Yes. Correct. Yeah. I tell you what. I think I can introduce myself.
Shouldn't be. I made this. But now it's crooked.
Yep, you're good.
I mean, it was crooked all. Yeah. It's a degree off.
Easy. So you're all situated here, everything?
I think so. I think we're good. All right. You ready? Ready to go live?
I was born live, so
Okay.
I think we all were.
You were.
Have the projector stare me in the eyes? Yeah.
All right. Ready to roll? Here we go. Live from the Southern California Linux Expo, the Ask Noah show starts right now. This is the show where we came to do all the things on Linux that you said couldn't be done and take your questions on how to do the same. It's a special edition today, and we've got a panel from Canonical community members. We're going to learn a little bit about UbuCon and the wider SCaLE conference. So welcome in. I'll introduce our panel. We've got Aaron Prisk. He is the part of the Canonical community team. Jason Nucciaroni. He is with the Canonical high performance computing team. Nathan Haynes, the Ubuntu community team. Richard Gaskin, Ubuntu California. We've got Eric Eichmeicher, who is the Ubuntu studio lead, Ken Van Dyne, who is an Ubuntu developer, and Larry Tavern, the Ubuntu Forums transition and Ubuntu board member. So I want to start with this. Maybe, Aaron, this would be a good question for you. Can you talk a little bit about UbuCon specifically, and in specific, what are the roots of UbuCon? Is it always co-located with a large event like SCaLE?
Thank you. All good. So UbuCons are first and foremost a community-run event. You're good. Thank you. UbuCons are a community-run event. So this event is largely a product of the great work of volunteers like Richard, who's in the stands over here, and Nathan here beside me, and some of the other folks beside me here. They've been going on since basically the inception of Ubuntu some 20 odd years ago, happening all over the world. So we have UbuCons happening in Asia, in Latin America. Recently we had one in Africa. And they can be as small as 10 to 20 people just hanging out in a bar talking about how much they love Ubuntu, or it can be large-scale, very organized events with hundreds, if not thousands of people. But again, these are community-oriented events, and it's the one shared trait they have is they have a mutual love and respect for Linux and Ubuntu.
Can you talk a little bit about the requisite size of the conference? Is it always is it always large, or can it be microscopic?
It can be very small. So I think there's this perception, especially from folks that want to have an UbuCon, is they need to have a large-scale event, no pun intended, like this with thousands of people. But it doesn't need to be that way. It can be a very small event. In Nigeria this past year, they had their first UbuCon, and this is the Ubuntu Nigeria. It started off with, I think, about 30 folks. And that's it. That's all you need for an UbuCon. And that's what we want. We want to show folks that you don't need to have this huge organizing team and tens of thousands of dollars. No, just, again, you need that mutual love and adoration for Linux and Ubuntu.
So I want to talk, I want to recognize for just a moment a pillar of the open source community that passed away, and that is, of course, Steve, or probably maybe better known in the community as Vorlin. And he passed away earlier this year. Steve was an absolute pillar of the open source community, and we'd be remiss if we didn't acknowledge him. He was one of the first employees of Canonical, extraordinarily community-oriented man. The thing that stood out to many of us was that he was focused on quality, because when you're building software for 40 million people to use, you have to get it right, and it has to work. You can't just throw it out there. And Steve did that. And so trying to connect Steve with a larger goal of people and relationships. And I had an opportunity a few different times to meet with Steve and engage with them, and what stood out to me above everything else was the conversations we would have. They weren't necessarily always technical in nature. They were people-focused. And even if somebody asked him a technical question, or even if there was something technical for him to comment on, he would be quick to draw it back to the community, back to the relationships, back to the people who he knew made those software projects possible. And so, you know, I think there were some people that would say that they butted heads with Steve, but I think if you asked them, they would tell you that that was a good thing. And that he was, anytime that he pushed back on something or offered resistance, it was towards a good cause. And so even if you were on the receiving end of that, you understood where Steve's heart was coming from. Steve was part of the Foundations team. Can one of you guys tell me or speak a little bit about what the Foundations team is and what they do? Two microphones. There you go.
Well, the Foundations team is basically the people who basically lay the foundation of Ubuntu. Now, you have the kernel team, which handles the kernel, but then above that, you have things that are like systemd and the installer process, you know, Subiquity installer in this case. A lot of people that just kind of handle the lower inner workings of Ubuntu, set the standard seed, set the minimal seed, and make sure that all of that is going to work with whatever you stack on top of it. And they are the Foundations team. They are all working at Canonical, and they all do a fantastic job.
Can you tell me a little bit about what sort of things the Foundation team, what kind of issues they deal with and how they address those things? Specifically, protocol for when there's maybe a disagreement or maybe there's an understanding of the best way to resolve an issue.
Speak to that too, because I've been there. So if there's a problem with how to resolve an issue, really those types of things go not really so much in the Foundations team. That gets directed to the technical board or whatever team is handling the situation, whether that's release, SRU, archive admins. And usually all of those are Foundations team members. There are some exceptions. However, when you get to a issue that needs to be resolved, it needs to go to those teams. If you can't resolve it there, you get the technical board that gets involved, and above that, if still things cannot get resolved, then it's the community council that gets involved.
I want to touch base on the HPC space. I think some people would be surprised to learn there's a very healthy and thriving community around high-performance computing. And I think there are some of us that have the impression that, hey, high-performance computing isn't something that we're doing inside of our mom's basement. It is likely something that is happening at this huge enterprise level with a lot of money. That's not necessarily accurate. Jason, could you speak to that?
So a little interesting holding two mics here at the same time. You know, I got big hands, but I also don't want to like clank the heads here. I do think one thing that's always interesting is like, you know, I think I came to the community, you know, about 2 years ago, and I said, hey, you know, I want to start a high-performance computing team. And it's like, wait, you want to like start something that's kind of outside the purview of, say, like the desktop, you know, traditional interactions with the distribution, you know, through PCs and all that. And kind of the case that I made is like, you know, a lot of these industries, you know, are very built around collaboration and working together on open source software. So for, you know, example, you'll have like open infrastructure projects like OpenStack just for building clouds, you know, you have Kubernetes and all that stuff. And so basically we said, why can't we do the same thing for HPC where, you know, we can kind of be the rallying point for professionals and, you know, developers and system administrators who want to use Ubuntu in, you know, their high performance computing workloads without necessarily looking at it through the commercial perspective where it's like, hey, you know, we're courting you so we can take your money, but more rather looking at it as like an opportunity where it's like, hey, we all kind of have a common itch that we want to scratch. Why don't we kind of put our heads together and, you know, use the, you know, solid foundation that Ubuntu is to actually work together to develop a common platform.
What would you say to somebody who says, I want to get involved in the HPC space, I want to get started, but again, I don't have a connection to a university, maybe I don't have a connection to a large organization. How would somebody get started in that space or get connected to that community?
Yeah, so I think that's a really good point that you bring up because I know that's a challenge that the HPC industry has currently where it's like, you know, obviously we see lots of people throwing money at AI data centers and being like, oh, you know, we got all this hardware, this is great, but we got nobody who knows how to use it. And so kind of what we're starting to see is a lot more people are interested in kind of pursuing careers in HPC type roles where it's like, you know, they're managing these large clusters for processing large amounts of data. And I find one thing that's really interesting, one thing that Ubuntu, you know, has kind of paved the way in is where its accessibility, where, you know, I was like 4 years old when Ubuntu came out, so I can't maybe comment on how things were then, but, you know, obviously you kind of see where Linux was a huge challenge for a lot of people. You know, a lot of folks wanted to use it, they were interested in it, but, you know, obviously when you get a bunch of floppy disks in the mail saying, hey, just like plug this in and hope everything goes right, you know, obviously there's that challenge of like, oh, it becomes very daunting, and Ubuntu kind of lowered that barrier where it's like shipping CDs, now it's like all you need is a USB drive. And so we're kind of trying to do the same thing in HPC where it's like, okay, you know, obviously if you want to really do serious work, you know, you want to make lots of money, you know, you're going to need these like top of the line hardware with like NVIDIA GPUs, high-speed interconnects and all that. But we take special care to actually make our software in such a way where a lot of it can be virtualized on a single desktop. So for example, with like LXD or multipass or something like that, we're able to actually spin up like these tiny little virtual clusters. So while you're not training these gigantic AI workloads, you know, you're still able to kind of get that exposure of, you know, deploying, managing, and actually running workloads on a supercomputer.
Kind of at the other opposite end of the HPC space is maybe the desktop space. And Canonical recently appointed Jean-Baptiste as the Director of Engineering for Ubuntu Desktop. Now, there's two things that stand out to me there. The first thing that stands out to me is that, in fact, there's a position called the Director of Engineering for Ubuntu Desktop, which implies that Canonical has a vested interest in the Ubuntu Desktop. Jean-Baptiste says, quote, I'm eager to push the Ubuntu Desktop even further by bringing innovation, building a powerful and stable, polished environment, and making it accessible to everybody. So a question for anybody on the panel, can you tell me why is Canonical appointing an engineering for the Ubuntu Desktop? What is the focus on the Ubuntu Desktop?
Usually if you see me double fisting, it's at the bar at game night, so this is new. So Ubuntu started as a desktop project as a way to make Linux and really software, especially free software, just available and accessible to anyone in the world, regardless of the resources, regardless of the internet speed, regardless if they have the fastest computer or a slow one. That's why Canonical shipped so many CDs for free. They gave me 50,000. Click, click, and you know. So that's always been very important. Now, this Ubuntu server nonsense is that people were misappropriating the desktop and uninstalling the GUI, and well, there might have been Ubuntu server first, but it just got so popular that they had to say, oh, okay, we need to, it was like release number 4, they delayed 2 months, that's why it's 606 LTS and not 604, because they changed the name, to polish it because, and support it for 3 years, nowadays 5, actually 10 for free with the subscription, or 12 if you pay a little extra, because Ubuntu was so powerful that and stable that they're like, we want this on our servers too, except every 6 months is a little, a little much. So that's always been a core value of Ubuntu's accessibility and information software freedom. And so with the desktop, if it's a server, there's not too much to polish if things are going well, but on the desktop, things are always moving. There's no better hardware, better graphics, sound cards, graphical interfaces, a desktop experience that Ubuntu has always paved the way, I think, pioneered a really nice, accessible default install packages and UI and just interacting with your computer to make it, and translations to make it easy. And so that's why there needs to be someone dedicated at Canonical. There's so many volunteers. Canonical couldn't do it without all the volunteers in the Ubuntu community. But there still needs to be someone who's being paid to make sure that everything works. And it's a task that's Herculean, but is and important, but also possible with that collaboration between Canonical and Ubuntu, because Canonical, as Mark said at the summit, is Ubuntu. It is all one big community.
Talk to me a little bit, if you would, specifically about the business value to the Ubuntu desktop. So I think there's sometimes a knee-jerk reaction to say, well, there's lots of money to be made on servers and on containers and all of these things, but the reality is, to a degree, is there not an entrance barrier if you're, let's say, a Windows system admin, and you come into the Linux or Ubuntu space, and you say to yourself, how do I get started? If there's a graphical desktop and it's pleasant to use, and you can start by just opening my web browser, checking my email, those sorts of things, and then I can easily drift and or begin to explore the wide range of open source and Linux software. Is there a business case to be made for supporting Linux on the desktop?
I think there really is. Not only can it be used for things like with the Ubuntu core, you can create digital signage, and the Ubuntu core automatically updates everything, and then you update your snap you build on top of that, and it automatically updates in the field everywhere. You can build kiosks and displays, and you can have your all your administrative staff running Ubuntu LTS computers, and they get updates, and it's just solid, stable, nothing changes, it's predictable, because the last thing you need all your receptionists doing is fighting bugs and crashes. You want them to just work and not even know that it's there. So that's really why it's important. And I think if you need more proof that there's a business case for it, Microsoft officially supports Ubuntu in Windows 11 through the Windows subsystem for Linux. And they started with Ubuntu, they think it's super important, even for developers. In fact, you can say run it, say snap install Firefox, and it will pop up in your start menu with a little penguin on the icon in the corner, and you can run both. You can run everything. So Linux is so stable and reliable. I think it's just a really good value for businesses. And nice thing is they get that for free because of the community. So.
Yeah.
So, 2 things come to mind. I was speaking with Ken, who's in the crowd here last. You can correct me if I'm wrong, Ken. We were talking last night about how Ubuntu is being used by some big Hollywood studios right down the road from here who see the value in having a stable, secure, robust desktop that they can trust, and how they made the switch from another rather popular Linux distro because they saw the value that Ubuntu provides. I was just speaking with a university this past week in Madrid, Spain. They switched all of their data science labs over to Ubuntu, and they're looking at the data science stack that Ken demoed earlier. There is an enormous number of Ubuntu desktops out there. Sometimes we don't know that they're there, but there's a lot of them. Ken, feel free to jump at any point if you'd like. Please. The man with all the secret numbers.
I can't share the numbers.
The panel, like Ubuntu, is a collaborative experience.
Yeah, absolutely. Ken Van Dyne, former engineering director of the desktop team. I now work in our alliances organization. I work directly with our PC OEM partners and companies like that. silicon vendors and things like that. I will say there is a tremendous demand for Ubuntu on the desktop out there, and it is growing, and it is growing fast, which is amazing to see. 1990s Ken would have been very excited to see what we're seeing today, which is great. And I think things like data science and AI movement, there's really nobody else in town doing it as far as an OS goes. You can't really do these sorts of workloads on Windows natively. Typically, if you install data science tools on a Windows machine, you're installing it in Ubuntu on WSL. You're not actually doing it on Windows. You're doing it on Ubuntu and WSL. But there's demand for enterprise type use cases where it's both like task-oriented type workers as well as developers. More and more companies are either buying preloads or they're buying Windows preloads and then reinstalling Ubuntu on it because they're Ubuntu certified. So the Ubuntu certified program is a very powerful program for us and our partners, obviously.
So Ken, while I have you here, I didn't have a chance to ask you this earlier, but would you be able to speak a little bit about the Foundations team, Steve or Roland and his passing, and what the role of community, the Foundations team, I know that you worked with him. Can you speak to that a little bit?
Well, yeah, losing Steve, I mean, it hurts. I've worked with Steve for many years. He was an amazing individual. And he was really a force to be reckoned with on our Foundations team. But not just for the Foundations team, for Ubuntu in particular. Like, he was always kind of our voice of sanity in the back of our head. Like, if somebody had some crazy idea, he was like very quick to reel you back in to say, that's not really following the Ubuntu culture. This is not what we're about. He was really great about being that voice in the back of our head. But I think there's a lot of people that have spent time working with people like Steve, and there's other people like him already that is like-minded within the company that will continue to speak up and kind of fill that role. As mentioned, the Foundations team is incredible. There's amazing people there, very, very motivated. It's actually a huge team, but all the distro teams are actually quite big. Ubuntu is, of course, a big thing for Canonical, so our desktop team is significant in size. The server team's pretty big as well. We have cloud engineering. They're all part of our Ubuntu org.
If you guys have questions for these guys, you let me know, and your questions will go to the front of the line. I want to talk a little bit about the community involvement via the forums. I think I'm going to tag Larry for this one. So the forums started back with, it was a vBulletin version 3, and it got horrifically hacked in 2013. Took the entire bulletin offline for about a month, and in that time, there was a tremendous loss of user base. So Larry, could you talk a little bit about what the community looked like back when we were on vBulletin 3 and how that hack back in 2013 affected it?
Yes. Back before the hack in 2013, it was July to be exact, the forums was much busy. We were so busy all the time. But after the hack, people, I think, were afraid that their information would get stolen. They had moved on to different avenues for support, like Ask Ubuntu and Reddit. Then we were hacked again in 2016, and that further diminished our posters. While we have 2.2 million members, the activity just kept dwindling. The other factor was that the security measures put in place when every night they would run, there was about 30 to 45 minutes that you couldn't post, you couldn't read nothing. The forums were down pretty much during that time, and we lost a lot of people over that. But I think, too, we lost user base just because Ubuntu became a lot more stable and doesn't need as much support as it used to.
Arguably a good thing. Let me ask you about the transition to Discourse. Maybe I'll touch base with Aaron here for just a second. So early on, Discourse was for non-technical people, right? And so the problem is, again, you'll sense a theme here, coming back to the relationships and the people, right? So you go to the Discourse and you ask a technical question. And you're told, go to Ask Ubuntu, effectively, get out of here, right? And so the perception, even if it wasn't intended this way, not very pleasant. Can you talk, and so that was the first time that we were on Discourse. Can you talk a little bit about that period and what the lessons were learned from Canonical?
So when I started working at Canonical about 3 years ago, that was one of the first things I noticed was we have this Ubuntu Community Hub, which is our discourse, and it felt more like a place for Canonical just to dump their release notes and not talk about much else. And to me, that felt kind of counterintuitive to the community we wanted to foster. If it's a community hub, it should be a true community hub. And just for context, I think we were seeing about, on average, about 500,000 page views per month on our discourse around that time. We wanted to push to make it a true hub by allowing technical support questions, reorganizing things, and encouraging our teams to just be more active there. If you're working on a cool project in Canonical, people want to know. Jason, I use Jason as an example, doing an amazing job of being more open with his work, because HPC, like you said, it's not something the average person does in their garage, but it's amazing work, and people want to hear about it. So we encourage Jason to just be more active on there and kind of serve as an example for our teams. And around a few months ago, we were planning to open up tech support questions and start to really fully utilize our discourse. And around that time, the forums folks reached out to us and said they were looking to sunset the forums. And we thought this is the perfect opportunity to kind of blend these two efforts. So we basically onboarded a number of Ubuntu forums moderators to become part of our transition team, and they've been fantastic. I think there's this perception that the Ubuntu community is just this monolith. It really much is a community of communities. They all have their own little sub-microculture that have formed over these platforms over the last 20 years. So trying to just say, oh, we'll just change platforms, how hard could it be, is much more difficult than you might think. And Larry can certainly testify to this. So we really wanted to make a really diligent effort to make sure that they felt empowered in this process. They were actual stakeholders and not just passerbyers that things happen to. And I can tell you that as of this week, after bringing over the forums folks and some of the changes we made, we're averaging about 3 to 3.5 million page views on the discourse. So that's a pretty dramatic change over just a few months. And it goes to show that the community is there. We just have to make sure we provide them with the right tools and platforms to be successful.
So the approach was, we want to put tools in your toolbox. We're not trying to take things away. Now, that's a challenging thing to sell to the community, right? Because you're going to a bunch of people. They don't like their cheese moved. If there's anything we know about people on the internet, they don't like their cheese moved. If they're used to doing something some way, we've done it that way for 10 years or 15 years, we should just keep doing it that way, right? So, Larry, could you talk a little bit about what the response was from many people when you asked them to move?
Most people were reluctant. They didn't want to come over. Some of them I sent messages to that provided support, and eventually most of those did come over. There were still a couple that didn't. But it's strange. These same people that didn't want to come are also our biggest supporters, saying how much they love it now. And we have this success in part due to Ian Weiser. He set up classes, he set up workshops to help us learn things like how to create categories and how the tag system worked and things along that lines. It wouldn't have been possible without his effort. And Aaron, Prisk, and Mauro have been excellent at getting us the things on the technical side that we need. So it's all been a team effort. I can tell you it's much better having the community whole, because being there with developers, the Canonical employees, you're just, you're dialed in so much more. And we got developers answering support questions, and there's just a whole lot more activity, and everybody's feeling good about it.
So a huge thank you to both you and Jane. Jane couldn't be here because New Zealand's kind of a far stretch, but maybe next year. A huge thanks to you guys for doing that. When you're taking the approach of so we're not going to just flip the switch, what I'm hearing from you is we're not just going to flip the switch and say, this is off, this is on, now go here. Can you talk a little bit about, from your perspective, what was the difference in culture as you moved to discourse?
Well, there was a whole lot of different perceptions because of the fact that it was all developers and Canonical. they didn't offer support at all. So our moderation techniques as far as the moderation team was different because we tend to be strict on some things, but we also understand they come there for support. They're already frustrated. We need to make it easy for them to get support in the support category. And figuring out how to do that was challenging. Aaron Prisk helped along that line greatly, and we worked out most of that, but our user base finds it a culture shock that they can't just come in and post right away. They need to read like 15 minutes. And they don't even read that when they come in usually, that they need to read. So that does create issues. But really, it's going really smooth. And it's due to the acceptance and the teachings and the moderation that was already on Discourse.
I want to touch, so Discourse is the form. The other migration that happened recently is the move to Matrix. And this, I think, it's multifaceted. I think the first part I want to address is how challenging was it to move to Matrix? You've given us kind of an idea what it was like on the forums. Can you compare and contrast that to me for moving the chat?
It wasn't hard at all. I mean, all I had to do was download the software, hit single sign-on with my username, and it just logs me in. It's simple. IRC, not so simple. It's just not. Not if you're setting up rooms and things like that, and if it's a private room, there's a lot of extra things to go through, and it's just not that difficult on Matrix. It's a whole lot better.
So, no emoji support. So yeah.
I think some important context for those who don't know is Ubuntu has a governing body. Things don't just happen because Canonical dictates. There's a community-run governing body that these are elected folks. There's an IRC council. There's a council that was built around the management and the policies around using the IRC protocol. So a lot of these changes, you say, oh, it's easy, flip a switch. But it's not that simple, right? This has to be a consensus. So there's a technical element, obviously, creating a platform that millions of people can use daily to get their work done, to collaborate, and then the more, I'd say, like political piece that is just as important. So we've discussed about creating like a communications council, a more unified, I use this example. We don't have like an HTML council, so maybe we shouldn't bind certain protocols to councils, make them more generalized for the purpose as opposed to the protocol. I want to kind of get Nathan's opinion here as a community council member and how he has seen these things transpire in his time as a leader.
So the neat thing is that the free software community and especially volunteer communities tend to form out of practicality and convenience. As well, not just this is really fun and hard to do and we did it, but also that's easy and fun, but then, we need something we can support, and that's hard. So, we've seen as, I think IRC is super easy, barely an inconvenience, and I think Matrix is sort of weird because it's federated, although I would have to say that it's actually not that hard to use. It's one more client to have open on my desktop. But when people started using Matrix, some of the younger people, Jason, really wanted to push for this, and so he got a bunch of people on Matrix. At the same time, we had been pushing between Discourse and other things to get a Canonical employees who are on different teams and community members on different teams to talk more about what they do on Discourse and other places in one single place. And Canonical used, was it Mattermost? Yeah, so privately to communicate, and the number one question I got at Ubuntu Summit are things like, why can't I find you on Mattermost, Nathan? And I said, I don't work for Canonical. I'm like, oh, but you used to. I'm like, no, I never have. So Matrix was a place. I just do a lot of things for free because I'm not paying for Windows. I said, I'll just do a little tiny expo, run a booth, and now here I am. So we got So Matrix was a way to get Canonical in a place and talking where they could also talk with the community, still be private and secure, but also interact. You know, I talked at the Ubuntu Summit in Riga a lot about how we are one big community. Everyone here, the people watching live stream, all the employees, and you know, the forums were getting harder and harder to. IRC is getting harder and harder to administrate. There's less people there. It's a very large barrier to entry. The forums, you know, are older technology. Forums used to be everywhere. They're waning. It's harder to support. Discourse is more modern. And so out of practicalities, people said, you know, instead of splitting up these different audiences, real-time communication, online you know, asynchronous stuff, how can we combine them and how do we get together? And since I'm not really a big web messaging person myself, I stayed way out of it, but because I'm on the community council, I was privy to all the conversations and the approaches and who did what and all the plans. And I have to say that in both cases, both the IRC council and the forum council and moderators were like, okay, let's do this, let's work together. How is this, you know, let's make this smoothly. How do we do this? And all the plans and all the work and everything, you know, I know that with Ian, with Larry and the other moderators, Jane, I've only heard good things, how easy this was, how cooperative everyone was, how excited people were to work together from all parties involved independently. The vibe I get is how everyone's working together and how happy they are that, you know, you move a forum to discourse, there'll be some clashes, be tumultuous, it's just hard to change. And it went super, super smoothly, and everyone was all happy. That's the nice thing about Ubuntu and working together, and the code of conduct is that smooth things a bit, smooth things out a bit, you know. But there's not really, like, it's not a struggle. Like, people work together.
Okay, I want to point something out. I don't even have to say anything. I can just exemplify this by asking a question. Jason, how old are you?
24.
24. Nathan, how old are you?
Almost 45.
Okay, there's the difference between the IRC folks and the Matrix folks, okay? The people that are above a certain age will tell you, IRC is very simple, it's very easy, it's worked for 20 years, it continues to work, what's the problem? The problem is, respectfully, that we have an entire new generation that are addicted to glowing smart things in front of their faces, and it doesn't necessarily translate well to IRC. Not that you can't do it, but they want emojis and texts and reactions and all of the various things. I'm going to kind of put you on the spot. Do you mind sharing or recapping a brief portion of the conversation you had with your daughter when you attempted to introduce her to IRC?
For context, my daughter's 16, so I figure any platform that we set up, if she can't use it, it's probably not a good platform for the future. I think I showed her IRC, and I think she asked, what era is this from? I think we have a real, I guess from our perspective is, I've been a beneficiary of this community from a work of some people that have been here and have done enormous work for a number of years, and I want to make sure the next generation can also benefit from that. There's a real concern about the graying of our community. We have a lot of bus factor. We have some amazing people that are like Atlas, that hold an enormous amount of work on their shoulders, and we just assume they're going to be around forever, but they're not going to be. So if we're not properly mentoring that next generation of users, there will not be an UbuCon 2035, and that concerns me. I want to make sure that we leave the community stronger than we all found it. If that's anything I think we can all agree on, that's the most important thing. And that's not me just dogging on IRC. I think we shouldn't have sacred cows of any platform or thing, right? We should be flexible and build a community that people want to be a part of. And that comes with challenges. But that's what makes Ubuntu and open source so fun, is that it's reaching the consensus and working together to find what that next thing is.
Can you talk to me a little bit about how you landed on Matrix specifically? It seems like there's a number of different platforms that we could have gone to, right? Could have gone to Signal, could have gone to Telegram, could have gone to, I mean, even the WhatsApp and Facebooks and you name it, there's a never-ending list of communication platforms. By nature of being a communication platform, it has to be online, so there's less of a concern there. But why Matrix of all the different places or all different things that we could have chose to centralize on?
Thank thankfully, we've let others be the guinea pig for us. Now, looking around what other open source communities, especially ones that we partner, we work with, they went to Matrix. We thought, okay, we work really well with these folks. They chose it. It works well for their community. We want a place we can talk with them on. So it just kind of made sense to go that route. Like I said, there are others, and we looked at a few others, but that one just kind of made the most sense. So the GNOME community and the KDE community, there's a lot of other communities we work with every single day, and if they're there, we should be too.
Can you talk a little bit about the cohesion between Canonical employees and the community side? So even in this panel, you will see people here that officially receive a paycheck from Canonical, and those that are oftentimes here on their own time and often on their own dime. The idea previously, we kind of touched on this, is that there were different platforms. If you were on the community side, you're over here, and if you are an employee, you're over there. Can you talk a little bit about the cohesion that's occurred post-migration to Matrix?
So first thing I'll say is I think it's pretty easy to identify who the Canonical employees are up here. You know, I'm saying we might be wearing a very intense color right now, but can't miss us, you know, if you're walking around. But I think, you know, the meshing between community and Canonical has been very interesting on Matrix in the fact that it's a lot less of like a walled garden or kind of screaming into the void and hoping you hear an answer back. I think, you know, you're starting to see a lot more collaboration between, you know, Canonical teams and, you know, community members. You know, I think a perfect example is Snap, where, you know, we have a lot of contributors who are coming in who are very passionate about, you know, seeing the packaging format succeed, and they're actually now starting to make, you know, contributions to upstream tooling that we have, like Snapcraft. You know, they're finding issues in the store that they're reporting, you know, working with the desktop team to actually make it work quite nice. And actually provide that feedback and do that advocacy work of going to other open source communities and kind of saying like, hey, you know, here's a really valid way of, you know, consuming your software. So it's quite interesting to see. I think another thing that's been really cool to see too is like, you know, Canonical teams like wanting to work with people and mentor them as well. So for example, within Canonical, we have a very strong technical author practice. They use a framework called Diataxis. And they actually, you know, just kind of one day said like, oh yeah, you know, we want to start an open documentation academy because, you know, open source is not just code, you know, it's a whole bunch of different stuff as well. And one important thing is really documentation. You know, you figure, look at a lot of like proprietary projects and, you know, obviously they have a vested interest in people knowing how to use it and use it well because then they get more contracts. But sometimes open source, you know, it's like, oh, the code is a documentation, or, you know, just think about it, man, it's so easy. And so actually, you know, it becomes important there to also teach people how to contribute documentation as well, where it's like, hey, you're going through and you find a bug, you know, what's the whole process for actually fixing it? You know, how can you actually make sure you're writing good documentation that people can understand and actually learn something? So I think that's been interesting as well. And then the last thing that's also been really cool to see is like a lot of teams are starting to do like public office hours, so they're starting to be a lot more transparent about roadmaps. You know, there's been a huge interest. I know, obviously, Jira, I think it's the bane of all software developers in existence, but, you know, it is a pretty useful way of actually, you know, doing capacity planning and allocating tasks. And, you know, there's been a lot of actual interest in kind of being more transparent about what teams are doing, what the roadmaps are, what the requirements are. And so a lot of teams start doing like public office hours where, you know, folks can just kind of show up, you know, either A, just have a conversation or ask questions, and then also, you know, they can kind of provide input on kind of the direction certain projects are taking. So, yeah.
Yeah.
So, in the also on the theme of, well, first of all, if Jason's going to disagree with me and rebut me on IRC, then in the realm of the code is the documentation, Python is executable pseudocode, so it sort of is halfway there. But on the topic of converging things and working together, Aaron and Prisk here and Mara Gaspari, who could make it, worked really hard to set up every other month an Ubuntu governance meeting, which is just open-ended. And so all the people on there's a forum council and an IRC council, and I shouldn't start naming them. Everyone's going to feel left out. There's a community council. There's the Ubuntu membership board. There's all these different groups, and they can all come together and sort of talk about, hey, what's going on? So we know my job on the community council is to kind of know what's going on, and thanks for making the job easier. I can go just jump in. But we want to work together because there's so many things that if you know what's going on, you can sort of anticipate things, and if you can help each other out, You might never ask someone who's like, oh, I've done that before, even though I'm doing it here, or we face this problem. And so just like we're trying, Canonical made a effort to get Canonical employees not to think of themselves as walled off, indifferent from the Ubuntu community. They're part of the Ubuntu community. We're getting all the leadership together to work together, because you never know when you start bouncing, talking, discussing things, what ideas might come up.
So I want to touch a little bit more on a proper mentorship program. So there is kind of this, I don't want to say entitled attitude, but this idea that the Kens and the Larrys and the Steves are going to be around forever, and it's just not accurate. So to a degree, there is a need for a proper mentorship program, and it is incumbent upon us, the previous generation, to make it appealing for the next generation. It is not on them to adopt to our way of doing things. And perhaps I'll start with Aaron. Can you talk to me a little bit about what a proper mentorship program looks like, and how we frame that so that there isn't an expectation that they're just going to pick it up?
I will shout out our friend Till at Canonical, who is a superstar. Till has been going to a number of universities recently in India to reach out to potential students to basically start a proper mentorship program, and has found some of the most hardcore, amazing, passionate developers there. So you need to go to where those people are, as opposed to just yelling into the void, hey, come learn how to do this thing. And going and finding out what skills that these universities have, and then also working with these universities and showing, okay, what skills do their students need to be successful in the open source space? So I think it's got to be twofold. Like we have to give them some value. Like we need to share our knowledge with them, and in turn find out what they know and how they can benefit us. Right? I think we should also be humble to know that we don't know everything. So if you lead with that mentality, I think Till is doing it the right way. I'd love to hear anyone else here what they think. Till! Go Till.
Sorry. So one thing I think for when it comes to mentorship programs, and obviously it might be a little weird, me, the 24-year-old, saying, oh yeah, mentor, one of the graybeards, but I find that one thing that really helps too is just kind of being cognizant of the fact that there is kind of a wider community of folks out there who do want to actually get involved in open source software, whether maybe it's for self-servicing purposes of like job training, or whether they're actually just kind of feeling a little altruistic. But the idea is that, all of us up here, were once folks who started out and didn't know what the ls command did. They just were trying to figure out what the files printed and all that. And so, you just kind of find that, we all kind of started as beginners who didn't know what we were doing. And so I think one thing that helps is always being like, man, I really wish that, this thing existed when I was getting started. For me, as like a software developer, oh, I like it when like open source projects have, neatly contained, good first issues where it's like, kind of low impact changes, or maybe changes that a novice can kind of pick up and actually get a good introduction to the project. I think also like maintaining, robust contributing guidelines as well that actually are up to date and kind of reflective of what the developer expectations are. And then I also think the other time, having strong code of conduct is also important, actually enforcing it, because, at the end of the day, if people just get bullied off and they're like told like, you suck, go away, they won't come back. And so I think it's important to kind of always know that, have a COC that kind of outlines being respectful, always assuming best intentions, and, while still appreciating merit, also kind of knowing that everybody kind of started from square one or square zero, and that, they need to be given a fair chance too.
We're trying to target the next generation of developers, you've really got to have the correct platform. And we were talking about the desktop being a huge thing for Canonical earlier. And it's amazing how, somebody wrote an article in the Ubuntu blog a while back about Ubuntu for education being a thing. And, it's one of those things where I'm going to go ahead and plug this for my wife. She's the lead for Ubuntu, and she's a preschool teacher, or actually a preschool director now. And she wanted to bring this back so that the next generation would have the ability to experience open source software, experience what's actually out there. There's a couple of games in there. And there's also the ability to get, the ability to learn how to program and how to write code on there. You know, we got Basic 256 that I think of right off the top of my head. I learned how to program in Basic at the age of 10. And I know that there are children out there who are just as capable. And we also target that towards university as well, because there's plenty of tools for note-taking, for science, for just general reference. And then, like Ken was alluding to earlier, with data scientists, you can always run those systems just as easily as you could on Ubuntu Desktop as you can on Ubuntu, because it's the exact same thing, just tailored to education.
You guys all seem very positive, so I'm going to pee on the parade a little bit. Can you guys tell me where you see some opportunity for growth by way of getting younger people involved in open source, in Ubuntu, in the next generations? Where are some areas for us to grow as a community where we're a little weak right now and maybe an opportunity to make things a little better? Maybe I'll lean on you, Aaron, for that?
So my background is in education. I spent 12 years as an IT director in public schools, so it's very much close to my heart. And Chromebooks basically took over at least American education, and these are very closed ecosystems. I think gone are the days where I remember being in school where you could tinker. That incentive to tinker is kind of gone, which is concerning to me. So I think we need to, this is where like those STEM programs, like you put a computer in front of a kid, eventually they're going to mess with it, right? It's just the way they're wired. I would like to see that take place of more like STEM programs, more like trade schools, where kids have the opportunity to experiment and to learn, like you mentioned basic, learn Python, learn programming languages. I think that has to happen at a very young age, because I think that will follow with them for years to come. I think it's a great opportunity. And also I mentioned this like in regards to like the forums, the discourses, we need to provide the platforms to facilitate this type of collaboration. We need to make it easy for someone who has like a passing interest or skill to find out how they can contribute their unique skills to our community. Because sometimes I hear this sentiment a lot when I go to these conferences. They go, I really want to help, but I don't know how. Or they go, I don't really know C++, how could I possibly help? So what do you do? Well, I like to do pixel art. Cool, come make a nice wallpaper for us, that would be great. So we need to do a better job on our side of showing people that you don't need to be a C programmer to be a respected member of the community. And yeah, I'll pass it over to these guys.
One thing that I also think would help when it kind of comes to, I guess you could say, peeing on the parade and what we should actually be doing better. I think it's like also just, where practice meets theory. I think it's kind of easy for us to sit up here in this chair and be like, oh yeah, all things are great. But I think at the end of the day, obviously you get the conference high of being like, oh yeah, it was great to talk to everybody and we had all these new ideas. But then, you think like a week or two afterwards, everybody just kind of forgets what they talked about or don't actually follow up, or you send off an email and maybe it ended up in the spam bin, I don't know. But there's some folks I'm still waiting to hear back from. I think it's, important to realize that you really need to, like, if you're going to talk about, like, hey, we want to bring new people in, you need to actually do it, and you need to actually spend time doing it. It can't just be kind of a 15% best effort kind of deal. It's like, it's like, oh, I want to, like, create good issues. You need to create good issues. You can't just, grab problems that you think are beneath you and slap a good first issue on it, but then you very clearly have a way you want it to be solved and all that. And I think when it comes to, like, oh, documentation, like, I want to have good documentation. You need to actually write it. You need to put a lot of effort into actually doing it. And I think that's always something that's, just kind of comes over time, continual growth. But I think, being able to actually put in the work, I think, is what's really important. And so, yeah.
Thank you. I was going to bring up documentation. It does still need a lot of work, but we need to centralize it all in one place where users can find it, especially new users. And it needs to be a place where the platform is maintained and well kept, and if you got to edit, that you can actually edit easily. Because right now we don't have that so much.
I want to dovetail off of that if I can to a degree. Can you guys, somebody touch on the concept of documentation from the perspective of a new user? So I'm going to put a statement out there. You guys either correct me or confirm what I'm saying. If you have somebody that doesn't have a lot of technical expertise, who's maybe slightly new on the scene, in some ways, that person is the most ideal person to write documentation because they're going to understand where the holes in the road are, where some of us with maybe a little bit more experience, we're taking such large steps. We step right over the hole and don't even notice it's there.
So I wrote a book called Beginning Ubuntu for Windows and Mac Users. That's in 3rd edition, and maybe they'll think about a 4th edition, which would be nice. But so I wrote it, when I was young, and I have a great guide to standard Unix, a structured introduction in German from like 1987, and it starts this is input and output, keyboard, monitor, printer, tape drive, because it's that old. And that's how I learned computers. We had a big chart with a Mac, Apple II or something like that in 3rd grade on the wall, and it was this and that, and we don't really get that anymore. Everyone uses smartphones. But when I wrote the book, I said, well, okay, so let's start with someone who's used to Windows, and they don't need to know what a mouse is and a right click is and how to use a word processor. Oh, Ubuntu is cool. I'll put it on my old computer. Now what? Well, how do I use it? It's so different. So I actually wrote it in the style of almost like a little introduction, but and then a bunch of topics. But I wrote it like a travel guide. You know, if you go to, one of those, go to AAA and get a travel guide about, take a trip to Europe or Germany or something like that. And it tells you, these are what the streets are called, this is the side of the road you drive on, this is how if you walk into a bar in Germany, I wrote this, they said we like it and said please take it out, it's not relevant in the introduction. If you go to Germany and you go to a pub, and all the tables are taken, right? There's seats. You walk up to a seat and you say, "Ist hier noch frei?" Germans, is this seat taken? Up to a stranger, and they'll say no, and you just sit down and either usually chit chat with them a little. They don't do a lot of chit chatting in Germany, or you just do your own thing. But you just walk up to a table and sit down. Or if you go to a cafe, you just sit down at an outdoor table, and they'll come find you. You don't go find. I went to an ice cream parlor. I wasn't sure if the outside was open. They were like, just sit down. Well, they said in German. And even though I knew that, right? So I think it's really important to have language and even a structure that is approachable to someone so they can ease themselves in sometimes.
If I can add just one interesting observation is the Ubuntu Wiki, which has also been around since the start of the project, I did an analysis not too long ago. I think it's 96,000 pages on it. Of those, a lot of them probably aren't of a lot of value, but there is still an enormous amount of value on that. When I did to look at the most top visited pages, a lot of it is technical documentation, how-tos, guides. I think one was using KVM in Ubuntu. And I took this list to our documentation team. I said, why are people still going to these pages? There's something to be learned from this. And that is, for some reason, they find that what is on the wiki was either more valuable or it was easier for them to follow than our official documentation, which is concerning, or in some cases the wiki was just being pushed above good official documentation. So that's concerning either way. So we were discussing we have this very, again, formalized documentation structure that Canonical follows, but sometimes Jason might just want to share a quick little, hey, here's how I made my desktop look cool. That's not really formal documentation. It's not really an official how-to. Where do those things live? So it lends some credibility to why these type of wikis are still relevant in 2024. Just something I thought was fairly interesting. It shows there's still a value in that user-generated content.
100%. To your point, what is the most frustrating to the orange people, I'm sure, but what is the most popular place when you don't know how to solve a problem on Linux or you Google it? What comes up 9 out of 10 times? The Arch Wiki, right? It is, I know, the orange people are upset, I'm sorry. But recognizing that problem and recognizing that reality is the first step to saying, hey, we are going to embrace user-generated content. We're going to, you notice that Aaron didn't say, so he wants to save his content, we're just going to not put it on the internet. It's where do those people live? Where does that content live? Hey, the music in my ears means we're out of time. I thank you for joining us. If you like this content, we record this show every Tuesday at 6 p.m. Central. It's streamed online at AskNoahShow.com and available on the radio in the Grand Forks area at 88.3. We're back next Tuesday, 6 p.m. Central, AskNoahShow.com.
Thanks, folks.
Yeah. Thanks, guys. Thanks. Thank you.
All right, we're going to take just a couple minutes break. Thank you for that, and thanks to all the panelists, and especially for those of you who worked on the forum movement, because that's a huge project, and that means a lot to me. I use those forums. Thank you. We have coffee in the back. Get some coffee, mix around for a few minutes. We're going to set up for our next talk. Alistair will be talking about Juju.
It's time for the orange polo. Looking like a hot.
So if anyone doubts that light is energy, they should try sitting directly in the face of a 5 billion lumen projector. I wasn't sure if I wasn't sure halfway through when I stopped sweating if I had gotten used to it or if the sweat was simply evaporating as soon as I was sweating. So.
You know what I liked about it? It gave you a raccoon look.
That's right.
You got a band of light, and then the rest of your face is silhouetted from behind.
Yeah, I was really glad I brushed my teeth after lunch.
Hello, hello, folks. We're about to get started with our next talk here, unlocking the full potential of open source with Alistair Flynn. So if you could please make your way to your seats, that would be great. We do have coffee in the back if you would like any bean juice to help keep you awake in the afternoon. You know, it is a tech conference and all that, so you know, have plenty of coffee. So yeah, we're just getting a little set up here because booth exhibit hall is opening up, and you know, get started in about 2 minutes here. All right, all right. We're gonna go ahead and get started here. Introducing our next talk, as I said it earlier, we are going to be unlocking the full potential of open source by automatically orchestrating our applications with Juju, given by none other than Alistair Flynn, one of the members of the Juju team. So, you know, whenever you're ready, go ahead and take it away.
Awesome. Thank you very much. So as Jason said, I am Alistair, and I am a software engineer at Canonical, and I work on the Juju team. So today, I'm going to be showing you how of open source with Juju. So for the agenda, I'm going to start with what is hard about open source today, then what is Juju, and how does it solve these problems, and then how can you use Juju to power your applications? So, what is hard about using open source software today? And by the way, I'm talking specifically in the environment of cloud deployments and running things in production. So, software is more open source than ever. 20 years ago, if you wanted to get some open source software to use with your application as like a backing service, or like if you needed, you know, a database or a cache or something, then the default solution would be proprietary software. You would generally go to a company that provided that service. Open source was seen as a kind of like fringe and hobby project kind of thing. But now, it is everywhere. There is a lot of open source out there. More than we can imagine, right? If you want some particular service, like a database or whatever, you have tens of really high quality options. So things that are well crafted, well maintained, well documented, and available for free. But I'm going to ask a different question. Is software more open than ever? Open source is not just a thing where you put your code on the internet. Open source is a philosophy. It's not just about making your software available for everyone. It's about making your software accessible for everybody. So if I publish a load of source code that's obfuscated and confusing and takes months of training to even operate, is that really embodying what it means to be open source? In my opinion, not really. And today, production environments are more complex than ever. You're not just running on a machine, you're running You've got your machine, which is in a cloud, which maybe has some VMs on it, which maybe has Kubernetes on top of that. You've got all these layers going on. So there's not just the actual physical infrastructure, but the virtual infrastructure as well on top of it. And deployment environments end up so complex because of it. So when you're deploying your software on your cloud and operating it, you have lots of different sort of phases to consider. You have like the deployment, which often requires the specialist knowledge of the application and of the cloud. So not just your application, but all the applications that you need to back that application, like the cache and the database and so on. There's also the integrations, so integrating your application with other applications that it needs, updates when there are updates for any, any of the different services that you're using, your application as well, and then scaling, high availability, all of these things that require specialist knowledge of the application. Then portability as well, right? So if you're running on a particular cloud and they hike their prices or they stop supporting like a feature that you really need, then it'd be really useful if you can move your deployment over to a different cloud, but that often requires almost rewriting your entire deployment script and all of this, whatever, Helm charts, Ansible playbooks you've got. So on that point, isn't this problem already solved? Kind of, but not really. So the deployment part of it is really well solved. Things like, Helm plus Kubernetes and Ansible and Terraform make it really easy to specify your deployment really well. But the maintenance phase, the phase that comes after that in operations, where you're trying to keep your software going, keeping it up to date, scaling it, doing all these integrations, and doing these things dynamically as well, is not quite so easy. So what if you have your big deployment, you've got your database and you've got your observability or whatever, but you want to not just observe your own app, but also have your Prometheus scrape from your database, from your Postgres. You can do that, but you have to figure out yourself how those two components interact. You've got to go into the config files, you've got to have a lot of knowledge of those two pieces. Same if you want to scale your database, right? That's a different thing for every database. You've got to know how to do it for that database. If you want to make backups across all your apps, you've also got to figure out how each individual app does backups, and they can all be different, right? And then even if you do figure all this stuff out, you've got the whole new set of configuration files that you've created to do this, and scripts or whatever, which now need maintaining if you want to keep that going as you change your deployment. So you have this extra layer of complexity. So the issue here, right? The software itself is open source, but the operations, not so much. And this is the issue that the software I work on, Juju, endeavors to solve. So yeah, what is Juju and how does it solve these problems? So the idea behind Juju is codifying operational knowledge. Yes? Juju, well, the meaning of the name is black magic, right? And that is why Juju is called Juju, because this is black magic for the cloud, right? You're getting a lot of really cool things without necessarily knowing the details of it all, right? So yeah, I'll continue there. So Juju codifies operational knowledge. So the idea is that all that figuring out of things that you had to do to, to deploy, to scale, to whatever, that knowledge can be codified. It can be turned into Python code in the case of Juju, and that is something we call a charm. So charms are Python code that operate applications. So the charms themselves are things written by people who are experts in the application, and the charms define how you do these common operations. So things like scaling, things like deploying, things like integrating with other applications. So the authors of the charm have got this opinionated way of doing these things. All you need to do is tell Juju to deploy the application or integrate Postgres with Prometheus, and it will do it. It will talk to the charms. The charms will implement the operations on the application, change the config files, whatever, and make that happen for you. This actually ends up making a lot of these cloud operations I was talking about earlier really simple, right? You can actually do it in one command, which kind of seems like something that is almost impossible today. But it exists, right? So, yeah, and just to clarify, so charms are not something that's just like run once, like a sort of script. They live alongside the application in the cloud. So they're sitting next to it for its whole life cycle and managing it. And Juju is managing the charms. So where can you get these charms? There's a website called charmhub.io, and it has a huge range of charms that already exist. These are maintained by Canonical and others, and they are all open source and free. And so is everything that I'm talking about today. So you can deploy these charms with Juju and integrate them with each other, and you can deploy them on a huge range of substrates, right? So Juju integrates with public clouds, with private clouds as well, like OpenStack. It also works on Kubernetes. So, yeah, question? It used to work on Windows. Nobody used it, so we scrapped that. Yeah, no, that was too much pain to maintain and not enough gain. Yeah, you can use, I believe, I haven't done it myself, but I believe you can use it with microcloud. Yes, so just to visualize that setup, so you have the Juju CLI, which is on your laptop or whatever. You have your cloud, and in that cloud is a Juju controller. And that controller is operating the charms, which are sitting next to your software. And these dotted lines around them are models. So this is a sort of concept specific to Juju that, well, I say specific to Juju, it's similar to Kubernetes namespaces, but Juju had the idea first. These are, yeah, models which contain a collection of applications. Question, yeah. In a way, they're... Oh yeah, sorry, I'll repeat the question, yeah. So the question was, can the charms be considered an extension of the application? In a way, yes, right? So in the ideal world where Juju is everywhere and everyone is using it, then it would probably be the people who write the application who also write the charm, because the charm is effectively how to operate the application, right? Obviously, we're not in that world today, and so the charms are, they exist on CharmHub, and they're not written, some are written by the people who make the applications, but most of them are generally not. But yeah, they are effectively a continuation of the code of the application, right? They operate the application. Yeah, so the next section is how can you use Juju to power your application, right? So there's all these pieces of charm software that exist, but you have your specific, I don't know, Go application or whatever, and it would be really cool if you could deploy that with a charm and put that on the cloud. So that is what I'm going to show you today. There's a cool new initiative that has come out of Canonical recently that is called the 12-factor charming process, and is effectively an on-rails way to turn your Go app or Django app or Flask app or Fast API app, along with a few other, well, I think they're working on a few other platforms, into a charm. Well, I say into a charm, in creating a charm to run that app, right? So hands up here, who knows what a 12-factor app is? Okay, cool, a few, but I will explain it, so don't worry. A 12-factor app is an application that fulfills all of these, but we are only concerned with the ones that matter for operations. So these in particular are having all the dependencies explicitly declared and isolated. So that is to say, we don't want a dependency that's just sort of built into your application in a way that is really, just part of the application. You want to do it sort of on this separately. You want to explicitly declare them so that they can be easily installed and easily managed. Next is config. So config should be declared through the environment, meaning environmental variables, as opposed to a YAML file or whatever. This is just a standard way to do config, right? Next one, backing services should be treated as attached resources. That is, you shouldn't care if your backing service is swapped out. Your app should be resilient to that, and it should be treated as a separate thing, not just part of your single blob. For the next one is processes. So your app should execute as a stateless process. That doesn't mean you can't have state. That means that if you need state, you should have it in something that runs state, like a cache or a database. You shouldn't be relying on the memory or the file system, because those things can fail and you can be redeployed. And the final one is exporting your services via port bindings. So that means not just writing your output to a random file, but exposing your service via a port. It could be, this is just an opinionated way that makes it really easy to communicate with the app and for other apps to communicate with it. So what are we going to build today? I'm going to demonstrate today building a Go app and charming that, and then running it, and then deploying it. So we're going to start with a Go app. We're then going to put it in a container. Then we're going to create a charm for it. And then once we've done that, we're going to bootstrap Juju, which is bootstrapping Juju, creating a controller for Juju on a microcloud cloud. So if you haven't heard of microcloud, it's a really simple, well, not simple, but a basic Kubernetes distribution that you can get running on your laptop. It's really useful for testing and just having something that you can locally deploy on. And that is what we're going to use today. As I said earlier, Juju works with any Kubernetes distribution that's CNCF compliant, and microcloud is one of those. So we have microcloud. We're going to deploy bootstrap our Juju controller on microcloud, and then we are going to deploy our app on that. We are then going to deploy Postgres and integrate that with our app, and then an observability stack and integrate that with our app as well. Meaning that we've gone from a Go app standing alone to a fully production-ready Go app in the cloud with a backing database, with an observability stack as well there that can be scaled, can be, is resilient, is usable in production, which, in my opinion, is a really cool thing, right? So, first, we're going to start by creating the Go application and the OCI image. So, hopefully these videos work. I've been informed the Wi-Fi is okay, but not great. Okay, so we have our Go application here. It's really basic. So this is literally just a hello world handler that you send a GET request to it, and it will return hello world. And I'll just unpause, and we will build that app and then test it out. So split the screen and curl. So hello world, as you might expect. And the next step is to pack this app into an OCI container. So to do that, we're going to use a tool called Rockcraft, which is similar to Docker, in that Docker also creates OCI containers, but Rockcraft uses a static YAML file to do that, rather than having a sort of procedural language like Docker does. And it also happens to have a very convenient extension, which makes it really easy to create a OCI image for a Go application, which is what we're using there with the Profile Go framework. So this is the rockcraft.yaml, so the YAML file that shows you what's in the rock. And as you can see, the extension Go framework is there. So we're then going to do rockcraft pack, which will create the actual OCI image. And I've sped this up because it takes a while, as you can see. Sorry? The base image is Ubuntu. I think it was, in the rockcraft YAML, Ubuntu 2404. So we've got our rock packed, and you can see it's there in the directory. We're now going to upload that rock to our microcloud image repository. So microcloud is running on my laptop here in the background, and there is a image repository at port 32,000. So this kind of obscure looking command is, so rockcraft is a snap, and it comes with Scopio, and that dot syntax is just saying use Scopio in rockcraft. And the insecure policy stuff there at the top is because it's not TLS certificate, not TLS encrypted even. So we're just uploading the rock, because it's all local that is, uploading the rock to this local microcloud image repository, which will allow us to use it later on. So we do that, and that's it. So we have now created our OCI image for our Go application. The next step is to create our charm. So to do that, when the video loads, we will make a new directory for the charm, and then do charmcraft in it. So charmcraft is another tool similar to rockcraft, but for charms, right? So you create charms with this, and again, charmcraft has a really convenient framework called profile called Go framework that is used. Hang on, I'll go back a sec. Yeah, a really convenient profile called Go framework, which will automatically create a charm for a Go application. And that's what we'll use here. We'll initialize the charm, have a look at the charmcraft.yaml. So this has the information about the charm. This is a new charm that we're creating. So the rock is the OCI image, and we're now creating a separate to that, a charm. So the charm is the thing that's going to manage our rock, well, our OCI image, i.e. our Go application at the end of the day. And this framework that it's initialized with comes with a load of code to automatically integrate any Go application with other services. For example, as you can see commented out here, Postgres, MongoDB, Redis, that kind of thing. And so basically this charm makes it really easy to attach these things to your application. So we will pack that charm. Oh, sorry, first we'll download all the libraries that it needs, and then we will pack the charm. And again, this can be a bit slow, but it's its own snap, yeah. Yeah, I have kind of skipped all the install snaps phase of all of this. But at the end, I'm going to share the link, by the way, to a tutorial that does have all of that. So it's, yeah, don't worry about taking, notes from the slides or whatever. Cool. So that was surprisingly simple, right? But we have now got a charm for our application. So the next thing we're going to do is bootstrap Juju on the microcloud cloud. Bootstrapping meaning just creating that initial controller and then setting up the models that we need, or the model that we need to deploy our application in. So we will start once the video loads. I was warned the Wi-Fi wasn't great here. I've plugged in an Ethernet cable, but I don't know if it's doing anything. That's too far. Let's try again. Exactly. Yeah, there we go, yay. So, Juju Bootstrap microcloud dev. Oh, dear, pressed the wrong button. Now I've got to hope it loads again. All that progress for nothing. Okay, there we go. So this command will find the microgates snap that is installed on our system already, and contact it behind the scenes and create the necessary pods that are needed to put the controller on there. This will just happen fully automatically, so we bootstraps, and now I'm just going to run microcates get pods to see the pods that have been deployed. So as you can see, we have a controller and model operator, which is part of the Juju deployment. We're now going to add our model called Go Hello World. And there, as you can see, we've done Juju status to see what's in the model, and it's currently empty, as you might expect. We haven't deployed anything to that model yet. Cool, so we have our Juju controller in the cloud. The next step is to deploy our application. So let's give that a go. So we have the model, right, that we just added, so we're going to deploy our application into that. And as you may have noticed, our application currently doesn't use a database or observability stuff at all. So we're going to, later on in the next slide, after this one, rewrite the application to add those things so that we can actually demonstrate that. But for the moment, I'm just showing how you can get a charm deployed onto your cloud with Juju. Admittedly, with this particular application, that's entirely pointless, but we're doing it just for demonstration purposes. Any questions whilst we're waiting? With load balancing as in, well, I mean, I've only got one instance of the application, right? So I'm, yeah. Yeah, I believe so, because we're using Kubernetes, right? So what you can do, you can tell Juju to scale up your application, and it will do that. It will load balance it automatically. Okay, so what we've got here, I've split my terminal, and on the top half, we're watching Juju status, so that is just showing the contents of the model and keeping it updated. And then on the bottom, we are going to deploy the application. So we specify the charm, and then we specify the image as a resource for the charm. So we're pointing it to that microcates repo. Oh, yeah. That's true. Yeah, I've admittedly called everything Hello World, which is quite confusing. But so what we've got there is a model called Hello World model, which is currently empty because we haven't run this deploy command yet. We've got a charm, so that's also again called Hello World, but that is the charm which doesn't actually contain the OCI image, but that charm is the software that is managing that OCI image. We haven't actually had to write any Python code, right? Because the extension happens to take care of it all for us. You can obviously write Python code to extend that extension and to make your charm do more stuff than it does by default. But yeah, that is the charm. And then we have in the image registry, that is the Rockcraft image that we uploaded. So that local host with... Exactly, yeah, yeah. So we're gonna see when I... Yeah. Hopefully it'll be clearer from the status at the top once it starts actually deploying. But yeah, we have the application there. And then, so we've got two rows there that might be confusing, right? App and unit. So the application is the whole sort of, the charm, right? That is what we specified here. Units are instances of it. So if you did scale it up, as you were saying, you would have 3 units, but you still have one application. So right now, and for this whole demo, we're only going to have 1 unit for everything we're doing, everything we're deploying, because we're not going to, I'm not included any scaling up in this demo. But yeah, that is a sort of difference there, right? Cool, so we've deployed it, and we're just going to ping it to prove that it works. Cool. So the next step is to rewrite the application to use Postgres and also observability stuff at the same time, and then I'm going to show you deploying it with Postgres. So to rewrite the application, we're going to have to wait for the video to load again. Perfect. So we're going to go into the main.go, delete what was there, and then, okay, so at the top you can see we have defined a new Prometheus metric called db queries total. We're going to use that to count the number of db queries just as an example metric to use. And then we have rewritten our hello world handler. So this starts by grabbing from the environment the variable Postgres db connect string, which is a variable filled by the charm when it integrates with Postgres. So this will happen automatically in the background, and as the app, we can assume that we have that available to us, and the charm takes care of that, right? So we grab that, then we connect to the database, and we insert into a table called visitors the details about the person who has just called that endpoint. And then we increment the db total, the db query total metric. And that's the first handler. We've also added a second handler called visitors, and this will return the number of people who have so far visited called the first handler, basically, by counting the number of rows in the visitors table. So at the bottom, we just register those handlers, and as you can see, we also register the /metrics endpoint, and that is the endpoint that Prometheus will automatically look for on your application to get metrics about it. And that's all taken care of by the Prometheus Golang library. Cool, so we can build that, and then we can try running it. Though, as you may have guessed, it won't actually work because we don't have a database currently connected. We're just running the pure Go application. It's going to look for that environmental variable, and it's not there. So we get an error. So what we need to do is pack that as a rock, go through all the same processes as we did before, and, oh, okay, hang on. There's a step I forgot here. So, right, we've just opened a file called migrate.sh. And in this file, we are putting a statement to create a table in a database if there is not already one. So this is a little shell script that is included with the charm and will be run on the integration between Postgres and the charm. So every time the charm connects to a our application's charm connects to a Postgres charm, it will run this script to create the table on the Postgres instance. So that means that if the Postgres drops and comes back, whatever, then it'll be reset because we haven't set up any state for that Postgres, but we will at least have our table. And the name of this migrate.sh is in the charm. It looks out for that for a script with that particular name, and it will do exactly that. It will run it when the integration happens. And I've just pressed the wrong button, so I'm going to have to replay the video, or try to. Okay, let's skip through. Sweet. Okay, where are we now? So, right, we've got that migrate.sh script. We've made it executable here. And now we're going to go into the rockcraft.yaml, and we're going to bump the version so that we can differentiate it from the first one. And then we are also going to add some parts to it, which, so here, when it formats it correctly, we have the Postgres client, which is the program we were calling from that bash script, the migrate.sh, and then also the bash service itself, because it is not automatically included in this OCI image, so we have to add it because this is a really minimal image, by the way. I think, yeah, I don't know if I think I said earlier it runs on Ubuntu, right? But this, I believe I might have been incorrect because I think this particular one doesn't even include an OS. It's super basic. It literally is just the Go application running with a systemd equivalent called Pebble. Yeah, so we will now pack that rock. Yeah, so this is one of these things that Canonical has been trying to do is to create these unified, like, they're as similar as they can reasonably be. They're not similar to the point of, like, meaning it stops working, or you've got features that shouldn't be there. But the idea is these things are, like, you can easily, if you know how to create a snap already, which, by the way, snaps as well use a very similar, language and syntax. So if you know how to create a snap, it should be fairly easy to transfer to creating a charm and also to a rock. So let's continue. So we have our rock we've just packed. We're going to do the same thing where we upload that rock to the local microcloud image repository. And then clear the terminal. And then we're going to go in and update our charm. So we only need to do a very simple update here, which is to add that our charm requires a connection from a Postgres charm, or requires an integration specifically from Postgres charm. So when we put this in, the charm will know, because it says optional false, that until it gets that Postgres connection, integration, then it's not actually ready to go, and it will mark itself as blocked because of that. So we'll do charmcraft pack and get the charm. Okay, so now we should have everything we need. So we're going to watch Juju status on the top, and then on the bottom, we're going to do Juju refresh. And Juju refresh is similar to Juju deploy, except that we've already got an app, so we're refreshing it instead of deploying it. So we specify the path to the new charm, and we specify the new resource that we're using with it. So that's version 2 of the image. I haven't bothered versioning the charms in this, which hopefully is not too confusing. But yeah, so we're now using the new charm, and we are now going to deploy Postgres. And in a second, we should see that come up on the top. And as you can see, the Go Hello World charm there is marked as blocked because it is currently waiting for the Postgres integration. So it's going to take a while for Postgres to actually come up, but once it does, those two should settle down and they'll be both happy and active. And so these charms will automatically retry all the failed, they're called sort of hooks, which are like events. So if it tries to, connect to the Postgres client, even if it's integrated and the Postgres is not actually up yet, it'll, come back with an error, but it'll just keep retrying every, minute or however long is specified. Say again? Yeah, so the question is, are those tunable, the retry parameters? I'm not 100% sure now I think about it. I think you can in some cases, but it's not, it's mostly managed by Juju itself rather than the charm. You can, get like Juju debug logs and things like that. If you can also get sort of proper observability on the controller itself. So, after this, I'm going to show you deploying the observability stack. One of the things which you can do with that is integrate it with your Juju controller and then get a load of cool observability statistics on, your controller, which is also deployed in the cloud. Cool, so we have our app and we have Postgres and they're integrated. So Hello World works again. Sweet. Okay, so before I skip it, so we've got Postgres, we've got our app in the cloud, we've got everything else except for the observability stack. So that is what we are going to deploy next. So when that loads. Yes, nice. Okay, so same setup. As you might have noticed, I've zoomed out a bit because the observability stack that we're deploying has a lot of charms in it. So it's called COS Lite, and COS Lite stands for Canonical Observability Stack Lite. And it includes a load of useful things, so Grafana, Prometheus, Loki, Alert Manager, and a few other sort of backing applications for those. And it is, rather than just being an individual charm that we're deploying there, it's a bundle, which means it's a collection of charms. And so we've deployed them, and then here we're integrating them. And again, the charm that we created has those integrations automatically set up. So again, we've had to do no extra effort to have this free integration with Grafana, Prometheus, and Loki, which is really cool. So now we're going to wait for all of that to deploy and settle down, which again takes a while. And all of these applications are, retrying failed hooks, things that have that are failing because they're just waiting for something else to come up, right? Cool. So we have deployed everything. We're now just going to send some requests, generate some metrics, so that our app is actually doing something. And yeah, as you can see there, our visitors endpoint is working. We've had 9 visitors to our app. Right, we've done that, and now one of the charms here called catalog makes it easy to find the endpoints that we're running our actual observability software on. So here I've just opened up Prometheus, and as you can see, that DB queries total, so that was the metric that we defined in our Go application, has been automatically scraped by Prometheus. So the charms, when they integrated, Prometheus was told about the IP of the Go application, and it has gone there, looked for the metrics endpoint, found it, and then put this in the database. And yeah, so we've got our statistics there. And as you can see, there's 2 labels, one for the visitors endpoint and one for the normal endpoint. And yeah, they have a load of extra labels that include information about the model and the charm and things like that. So yeah, that's pretty cool. So we've also got Grafana is there. So we can have a look at that. What we're doing here is running a action on the Grafana charm. So an action is something that the charm itself defines as something we can basically ask it. So here we're doing get admin password. So we run that action on the charm, and the charm returns to us the admin password that we need to access the Grafana dashboard. I'm not entirely sure how the actual charm has implemented that, magic, right? Yeah, so there's, people who have, the charms are very, heavily developed, right? And they're a lot of code, so there's a huge amount of complexity. I don't know how complex getting the admin password is, probably not very, but yeah, the charm will be doing whatever it needs to do to get the admin password, and we've got it abstracted to the level that all we have to do is ask the charm what the admin password is. Cool, so open up Grafana, copy in that admin password, and log in. And then let's go to the dashboards. We will be able to, from this Grafana, get access to all the metrics from Prometheus that, are in the database. But it so happens that the Go charm that we developed, the one that we've just created that we didn't have to add much to, that automatically scrapes a load of really useful information about the Go application, like the garbage collection times and things like that, that could be very useful. You can also add extra dashboards on here and add extra metrics if you want. But yeah, this literally comes by default, right? So we have, without very minimal effort, we have got full observability on that Go application. You can also do things like tracing and a lot more. Yeah, question? So the integration automatically, so our charm was, which we created with that Go profile, automatically does that collection of data. And when we integrate it, Prometheus is then also told about that, and it can get that information as well. So there's a lot of stuff kind of happening behind the scenes here, right? There's a lot of magic, a lot of Juju happening. But yeah, it makes it really smooth getting all this information. And yeah, so that is all I have to show today. There is a lot more I could show, but I only have so much time. So this is a link to a tutorial that covers some of what I talked about today, not all of it. This is all quite new work, this Go application charming, and also, yeah, the Flask and Fast API and Django charming. And so there's going to be more about it in the future. Right now, this is a tutorial that just gets you sort of started. And yeah, as I said earlier, it includes all the stuff I've had in the background, like the installing the snaps and setting up the environment and all of that. Yeah, so does anyone have any further questions? Yes, Mike.
That way everyone can hear. Oh, wow, that's so loud. That way everyone can hear questions at the end. Here you go.
Thank you. So you showed 3 commands to integrate the observability stack, but you didn't do the same for Postgres.
I did. It was probably just, I think I didn't mention it. I forgot to mention it at the time. I did do that. So yeah, you sort of separately deploy and then run a command to integrate. And something I probably should have done when I recorded all these demos is in the Juju status, you can add a -- relations flag, which will show you all the integrations that you've got. So there I was just running the command and it just disappeared off into the ether, right? But you can also just see which integrations you currently have for visibility, right? Another question?
I just want to make sure I understand the value prop of Juju here. So I want to say a couple of things, and if anything here isn't right, correct me.
Sure.
So it seems like when it comes to Docker versus Juju, let's put those two together. Both of them are going to be working on OCI containers, so there's not really an advantage there. It's the same thing. Both of them also seem to be managing network configurations, like Docker has Docker networks, and it seems like we're doing some assumed connections here and some configuration that's happening through charms and other things that pre-exist. So we both have containers, we both have networks. You were also managing relationships between things, so you had your application and then Postgres. But Docker with Docker Compose also has stacks, right? So at that point, we have similar functionality. As I see it, what Juju is giving us seems to be 2 things based on the presentation, and this is where I want you to correct me. One of which is a control plane for us to interact with the application without having to have custom scripts made. Something like when a charm is made, we can then interact with it using the Juju CLI without having to then worry about what machine is that going to, how do we communicate with the individual nodes, how does that information get to and from. And then the other bit seems to be that some of the sysadmin side of it with charms gets taken care of for us, or at least we have placeholders to put in our own action without then having to do the IPC, the inter-process communication between the nodes, or by building our applications to be aware of it. We can abstract the awareness of where they're running by charms. Are those 2 statements correct?
I would say generally yes, in that the charms are that further level of abstraction over what you have in things like Docker Compose. And the idea is that you can do away with things like configuration files and having to worry manually about all these scripts, and that is taken care of you by the people who write the charms. And the charms have a lot of scope to, the charm authors, they can write the charm to do a huge amount of stuff, right? You can have a really basic charm or you can have a really complicated, powerful charm. And that is sort of capturing that like complexity, right, that was previously in your scripts on your deployment, whatever. Yeah, I think that what you said, to my knowledge, sort of does capture, the spirit of Juju.
Sweet. So the follow-up and then the end of the question line would be then, going back to the beginning of your presentation, you were talking about open source being a difference between having code versus the documentation and the infrastructure and ability to run it. It seems like the value prop of Juju is, in addition to having the code, you're abstracting the layer of interoperability such that while AWS can do scaling and Postgres stuff, or some other cloud provider in their own implementation of whatever technology like DigitalOcean or Linode, whatever they're doing, they can do what Juju's doing, it seems. But because Juju is genuinely a platform independent thing, you are avoiding platform lock-in while still having some of the niceties across these platforms.
Right, so to that point, like AWS or whatever has its own implementation of scaling. Juju will generally be using that implementation of scaling, right? It's, or at least, I mean, it can depend how the charm's written or whatever. Well, maybe that's not quite true. But yeah, the charms themselves, the operations code, are independent of the clouds. So Juju, the Juju controller is what sort of has that layer in between the two that will implement these operations on the different clouds. And currently we have, you know, integration with a load of different clouds, and we're sort of keeping those integrations up to date so that we can get as many of the good things that are coming out of the clouds as we can to work with the charms. But yeah, the idea is the charms themselves shouldn't depend on the cloud implementations. I don't know if I've really sort of addressed the question there, but yeah.
It sounds like what you're saying is that the Juju is in itself an abstraction that allows whoever the user is to implement whatever logic they need in a programmatic way, regardless of the platform underneath it.
Yeah. Juju is like a further level of abstraction, right, above what we generally currently have. I guess that is, yeah, a way to put it.
Gotcha. Thank you.
Nice. Any further questions?
Each charm has its own revision. Can we pin certain charms to certain revisions?
Yeah, you absolutely can. Yeah. Yes. Yeah, if there's no more questions, then yeah, thank you very much.
Round of applause. Oh,
sorry. Another question.
Yeah, so just the follow-up for here, you have the tutorial, your LinkedIn, and the Juju homepage. If someone wanted to become involved with the open work around Juju, where would you direct them for their, not just like the page that describes it, but
yes,
your Juju Hello World?
There is on Charm Hub, which I mentioned earlier, there's a discourse forum where you can ask questions and get involved. We also have a matrix chat. I should probably have linked to them here, to be honest, but yeah, there is a whole community out there. Yeah, and you're very welcome to get involved.
Sweet, thanks.
Nice.
All right, thank you, folks. So we're going to go ahead here and take a bit of a short break. So as a reminder, as always, we do have coffee in the back, so please help yourself. We also have some stickers as well if you want to like pick up some stuff. I think the exhibit hall is opening soon, so if you are interested in going to check that out, you definitely should. You know, our microcloud folks are there and all that. And then if you're potentially interested, you know, in the next talk, I'll be giving one about HPC on OpenStack. So feel free to stick around. If not, yeah, we'll go ahead and get set up and enjoy a quick break. So it's going to be about basically yeah.
Glad I ran into you in the backpack yesterday, but I wanted to ask, we didn't exchange contact, but what do you
Thank you very much. Yeah.
I'm not sure. I think I have my.
Does that mean you head out tomorrow?
I'm actually heading out.
Coffee or a beer or whatever is an appropriate drink. So if you come back on LinkedIn, I'd love to take a break tomorrow.
Have you already sent me a
Send me the picture. So I'll see you around maybe. Yeah. Later.
Well, this is great. Everybody's like, ah, shit, I don't want to learn about HPC. Yeah.
I'll stick around. I'll be
Hey, thank you for the talk. It's great.
glad you enjoyed it. Nice. Yeah, thanks for coming.
I just have on the side question. I see that you guys have it.
Yeah.
What composition is that and what's the market?
Oh, sorry. Could you repeat that for me?
What what positions that you have open?
Oh, yeah, so we're hiring all across the company. So, for example, we're hiring within our cloud org, we're hiring desktop, documentation, all that stuff. So really, it's like at this point, kind of have the ball rolling, we got the wheel turning and all that. But, the fact is that it's a pretty small company, so, making a lot of money, we're starting to kind of find that, oh, wow, it's kind of hard to do a lot of things for 3 people. So we've been basically hiring for every possible position. So we do take a card. They'll basically just like, I haven't checked in a while, but I know it's like you can kind of go through some different questions that'll introduce you to different things, kind of what your skill set is, what positions you might be interested in. And then you can go ahead and apply. So yeah, if you just take a card, that's fine. But yeah, we're hiring all over the company. So, whatever you're interested in, you probably have a position in it.
All right, give it a try. So what's in your prior experience before you get into
So I was actually a university student. So it was, what is it? I was working in HPC, basically like Canonical graduate position. Kind of intended for people very early in their careers and all that, just finished school. And so, I applied for it because, I was just interested. Like, oh, let's see where this goes. And then, very interesting process. Basically, I interviewed like all across the company, kind of see like what my interests were, where my technical skill set would be best. And at the end, I was kind of given the choice of being able to choose which team I wanted to be on. So I chose to be on the HPC team. But yeah, it's kind of interesting. We do have this concept of fast track where it's like you're just like really good at Python programming, and you can just kind of apply to Python engineer, and then basically I just kind of interview and kind of pick you and be like, oh wow, they might be really good for like the MLOps team, they might be really good for like the network team, networking and all that. So yeah, no, it's interesting.
Would you say that you guys also got a strong background?
Yeah, so that's definitely one thing we're always looking for, because I know right now, like one of Canonical's big pushes is performance and correctness. 40 million, installs of Ubuntu and all that. So we definitely want to make sure that code system is always going to work, because people don't like bugs. Definitely if you have a lot of software engineering experience, especially with profiling, like actually making sure your code is performant, it'll definitely set up some green flags, that's for sure.
But how come, because since you got to work right after school, how the experience that you get in order to get that qualification?
Yeah, so I think basically what I did was I really focused on, I did a lot of jobs like when I was in university, so I definitely did kind of pick up a lot of technical skills there. And then kind of with graduate, when it's like your early career, the way we look at it is like, high potential. So it's like, okay, this person has demonstrated ability to think on their feet, they're passionate about what they do, they have a desire to learn. That's kind of what we look for in like early career people. That way it's like, all right, it's kind of unreasonable to expect that you're going to be like, 25 and master in like, virtualized networking, or, for example, like, oh, you're an expert in distributed storage. So instead you'll kind of be brought up and then mentored, but for like the more senior positions, that's kind of how they start to look at it. Like, okay, what's your technical definitely not for the faint of heart, but I think, you know, kind of like, there's a lot of work to it, because like, one thing that Canonical does is like, every 6 months we kind of have like a big company meetup, which is really fun, because you get to see a lot of cool places and all that, so I think, you know, being able to travel the world, like, you know, for me, it's like, I've been to, I don't know, like 50 countries in the last 2 years, so I think being able to, yeah, work at Canonical, it's like, it opens a lot of doors for travel and all that.
So you do like a lot of demonstrations, you know?
Yeah, yeah. So I do a lot of demonstrations. Maybe the crowd's a bit smaller here, but yeah, usually, you know, I'll go to conferences, meet with people, kind of talk about what their challenges are and all that. Yeah, go ahead.
Awesome.
Yeah, absolutely. Nice to meet you too.
Yeah,
Yeah.
thanks. I'm from a local school.
Yeah, we'll take your name. But at least if you are interested, you know, I can potentially give you a referral. I know some, yeah, some folks just like.
I was about to ask, you guys do referrals also?
Yeah, is that your LinkedIn or?
Yeah, it's LinkedIn.
Okay. I always like that, because like sometimes I just get random people who are like, hey, can you give me a referral? But it's like, let's talk to me first. Okay, hopefully the Wi-Fi.
I think that, yeah, there's only Wi-Fi, there's no signal.
Yeah.
That has, but can I check you out too? Maybe I
Yeah,
can check it
yeah,
out
you
later
can
on.
find me afterwards. Okay.
Yeah.
All right, I'll try it.
Thanks, man.
Yeah, absolutely. No, yeah, no, great. So, hopefully see you around. I gotta get set up here before.
Yeah, I will check out exhibit
Yeah.
all later on today.
Yeah, yeah.
You guys will be around too?
Yeah, yeah. So I'll be around like our booth, so you won't miss us. But
So you're the guy gonna do the HPC?
yeah, yeah,
Okay.
yeah.
I'll do that.
Thank you.
Alright, I'm gonna go take some break.
All right, yeah, no problem.
Mind if I touch the thermostat?
Yeah, maybe. Yeah, yeah. Sorry, just giving people a chance to filter in. Yeah. Yeah, I don't know why the AC is so high here.
The thing that looks like a thermostat is not a thermostat.
Yeah, I know. I might put my my jacket on here.
Yeah.
It's a little chilly.
Hey, these things are really cool.
Yeah, they're pretty nice. All right. Hello, hello, everyone. So a little bit behind schedule. I figure I let people enjoy the conversations as well as filter in. So thank you, Richard, for closing the door. Hopefully you're closing the door. Thank you, Richard. I find it's very easy to get distracted when you hear all that stuff out there. So I gotta figure out how to do this here. Okay. Start from the beginning. All right. Sorry. Presenter view. All right. So go ahead. I find it's always like the fun first 15 minutes of just like trying to figure out how to set things up. Okay, there we go. All right. That is not what I wanted. Oh, okay. I hit the wrong key combo. That's what happened. Okay, presenter view. Hopefully the Wi-Fi is on my side here. That would be quite nice, wouldn't it? There we go. And F11 ought to do it. All right, here we are. So, obviously, first of all, I want to say thank you to everyone coming here. I know, I think the exhibit hall just opened, so everybody's kind of probably moshing there to go ahead and get their free merchandise and all that. Definitely have some nice stuff in our house, but you got to do a quiz to win it. So some Canonical employees might even struggle with it. So they're gonna have to try because Ken is really pulling out the old lore there from like 2009, which I was in elementary school then. So just to age you just a little bit. But yeah. So here today, what I've kind of come to talk to you all about is charmed HPC on OpenStack Sunbeam, and so. Obviously, a bit of the title here, you can see that I dropped into, technical concepts, but, all right, let's see here. I'm trying to figure out how to move the page. Okay, there we go. So I'll just go ahead and give a bit of a short introduction here about who exactly I am. So first, a little bit about my background. I'm currently a high-performance computing engineer at Canonical. So my primary responsibilities are focused on actually leading the team now. So have a couple of engineers, and we're currently working on building an HPC product for Canonical. So a lot of my responsibility is focusing on the development work, but also kind of making sure that managing team resources correctly, and also kind of being able to coordinate everyone to actually contribute their part of the project. Outside of that, I'm also an Ubuntu member, so officially a part of the community. I like to organize events, obviously, given to why I'm here. So I've been pretty active in the Ubuntu Summit for the last 2 years. I'm one of the core organizers. I actually organized with Aaron and the rest of the community folks this UbuCon here. Outside of other community engagements, I also like to volunteer around various teams. So I am both a snap crafter, so kind of working with the open source community there, developing snaps. And then also, we have an HPC community that I kind of sort of lead, but basically we have a weekly call where we just get in, talk about HPC and all the fun things that we like doing on Ubuntu. And so one thing is, about working in HPC these days is that there's kind of a lot of criticisms that the industry is facing. And so the big thing is that obviously with the pace of innovation in AI, a lot of people are kind of starting to wonder, is high performance computing still relevant? Obviously finding that Moore's law is starting to become very non-economical in the sense that you can't just keep throwing money at supercomputers. Obviously you can buy bigger and better CPUs, but after a certain point, the cost just becomes so high that you start to really wonder, is it worth it? Another thing is also that Kubernetes has kind of taken over the world a bit here, where a lot of folks are starting to look at the traditional HPC batch scheduling systems and basically saying like, oh wow, that's boomerware. Nobody uses that anymore. Why do we need that? I want my auto scaling. I want my pods. I want my pod stacks and all that. So obviously a lot of frustration, where it's like, hey, I'm really into HPC. I love, working on those technical challenges, and then kind of having people come in and be like, oh, well, that's a dying industry. Kubernetes and AI is where it's at now. So why is HPC still relevant? And honestly, my response to that is negative feedback. Kind of sucks. It's obviously very important to be able to take negative criticism and kind of hear from folks about like, you know what, I don't think, your industry is really at the top of the game anymore, or it's, kind of such a big relevant player in the pace of hardware innovation. And so, these GIFs here kind of capture my reaction, when I kind of hear like, oh, wow, why do you care about batch scheduling when Kubernetes is where it's at? It's like, no, it's still important, it's still something that's really useful. But, obviously, if you're fully ingrained in Kubernetes world, you might not see it that way. But perhaps the detractors are telling the truth. So for example, one thing that you have to talk about and kind of have to point out about what's really happening in the market right now is a lot of following the money. So, up here, I kind of have a lot of recent news articles that are kind of really highlighting, kind of the massive investments that are being made into AI infrastructure right now. Whether or not, it's going to pan out in the end, that might be up for debate, whether it's going to kind of pop like crypto or if it's actually going to be revolutionary, we shall see. But not changing the fact that there still is a lot of money going into it right now. So for example, the Stargate project, building all those data centers, AI infrastructure companies are kind of really starting to pop off with investments and all that. Fluid Stack is becoming huge. A lot of companies are also building, giant clusters now. So for example, Tesla, built their, I think Colossus cluster, that might have been the name, but, very focused on AI. And then also the fact is that AI is just kind of having a very powerful effect on the HPC industry right now, where it's basically come in and basically told, hey, you're not going to get all these money to build these big traditional clusters anymore. And also starting to really think about, cluster architecture, where, you need to start supporting these more heterogeneous resources, where instead of having the biggest and best CPUs, you need to start thinking about also including like GPUs and MPUs and TPUs and all that. And so the other thing is too, is that Kubernetes is pretty easy to consume. I find that if I ask most people probably in this room to actually go ahead and set up a Kubernetes, most people would probably say, yes, I've used Kubernetes, and here's the tool that I've used. So I find with HPC, if I looked at Ken there and told him to deploy an HPC cluster, he might know what to do because he has a background in HPC or had a little bit of a background in HPC, but it's definitely been a while. And so what I'm kind of sharing up here is that, Kubernetes is a very healthy and active ecosystem where there's a lot of, new deployment tools coming out. So for example, you can kind of think of some of the really popular implementations like OpenShift or, Canonical Kubernetes, ways of basically making Kubernetes much easier for folks to use. Kubernetes is kind of hard to deploy by itself, but there's a lot of tools that just make it simpler. It's also a very healthy ecosystem of what's being provided by public cloud. So for example, you have AKS, you have EKS, you have Google's Kubernetes implementation, and then you also have a lot of like local solutions as well for actually playing and learning Kubernetes. So you have like K0s, K9s, K3s, microclasts, all of those. And so it's extremely easy to use Kubernetes, maybe a bit difficult to set up, but not hard to actually get started and start experimenting with Kubernetes. And however, when I think of Kubernetes, I think there's actually quite a bit of overlap between that ecosystem and the HPC ecosystem where, Kubernetes kind of has certain requirements, or folks that are looking to do AI on Kubernetes have a lot of the same requirements that you'll often find that folks who are using HPC systems are going to have. So for example, one big thing is always, resource allocation and scheduling. You might have Kubernetes, scheduling pods and spinning up new applications kind of based on demand. And then you also have like HPC systems that'll kind of allocate resources based on how they're requested. You need to have some kind of task management where if, multiple people are submitting multiple workloads, HPC is going to kind of have the same setup. And then you kind of then have some of the, basic bare bones things that any kind of distributed system is going to need to have, like identity and access management. You don't just want somebody showing up and having root access to your data. You're going to have service orchestration. Obviously, you want somebody to actually manage setting up your services, doing different things. You're going to need distributed storage. If my pod gets put over here, the data still needs to be available there if I'm still over here. You're also going to need kind of observability. Obviously, you're going to want to know the health of whether your job is running, you're going to want to know if your job is healthy, or if you're going to have kind of some kind of AI type workload, you're still going to want to be able to collect those metrics and actually analyze them. And then the other thing is too, is that, if you're moving around a massive amount of data, you're also going to want to have high bandwidth networking. Unfortunately, 1 gigabit of Ethernet is not going to successfully exchange a multi-terabyte model, nor is it going to successfully exchange a multi-terabyte database or data set. And so now, the really important question to ask is, can we make HPC systems as easily consumable as Kubernetes? So, if I can go out here and I can say, oh, okay, basically sudo snap install k8s, and, within 3 commands, you have a fully functional Kubernetes cluster. Can we kind of do the same thing with HPC systems? Can we make HPC, the experience of actually setting up and using an HPC system, just as easy? And I think, well, yes, we can. And that's where it kind of comes back to the title here, where I think we can possibly achieve that using Charmed HPC and OpenStack. I think we can still kind of get a little bit closer to where, okay, maybe we won't have the 3-command install or setup right now, but we can still make it really easy to actually go ahead and start setting up an HPC system. So you might be wondering, actually, okay, this guy has said Charmed HPC, what actually is it? And in years prior, or presentations prior, I would throw a very, I guess, complex chart up here. And I would go through and spend 20 minutes kind of outlining every different piece of it and be like, well, if you follow the orange line to the storage, it goes ahead and does this on this thing right here. And then I'll say like, oh, but if you take the workload manager, it's going to interact with this bit right here. But obviously, I found it's kind of a bit technically dense and hard to follow, especially if somebody who isn't necessarily fully aware of like how an HPC system actually goes together. Or, also it's just kind of like, all right, this is like a really crazy chart that I'm just trying to understand, yet this guy is like speaking at like the speed of sound, trying to tell me how this actually works. And so I think a great way of saying it is I kind of look like Charlie Day from It's Always Sunny, trying to go through that, where it's like you have all these different interconnecting lines and you're just trying to actually explain how it goes together and how it works, which, I don't think is a very helpful way. So instead, I'm going to try a little bit different way of actually breaking down what Charmed HPC is. And so first, I'm going to introduce you to my good friend, Beowulf. And so while, this here is the, I think, 2012 animated movie, retelling the epic of Beowulf, the Old English poem, Beowulf was also the name of the, first HPC cluster that really popularized the, Beowulf architecture, which kind of looked at having 4 core components. And so the first part there was the workload management aspect, where, okay, you have a distributed system of, commodity hardware that you need to make available to a group of users, but obviously you don't just want all those users hitting the cluster at the same time and beating it up. Instead, you want to kind of have some level of management there to actually control those resources. The next thing you're going to kind of want to have there is the identity and access management bits, where effectively, you want users to basically be able to say like, oh, I'm Johnny, I'm Ken, I'm Rajan, all that, and basically make sure that, okay, they can't overlap or touch data they're not supposed to have access to. You're also going to kind of have the distributed storage bit, or shared storage or parallel storage, depending on the implementation you're using. But the idea is that, okay, if you have all these distributed pieces of commodity hardware, obviously your data is going to need to be available on each individual set of those nodes. And so that's where the distributed storage comes in and actually making sure that's delivered. And the last thing, which is, I guess you could say kind of optional, but still highly recommended, is to have a high bandwidth network where you can quickly exchange large amount of data very fast. And so now, I guess you could say, we'll go into a little bit more of a in-depth view of what like an common HPC cluster architecture is, where effectively, okay, you have workstations where people are going to be logging into the system. Then you're going to have head nodes, which are basically kind of the jump hosts that folks use to actually go ahead and access those compute resources. Then the compute nodes are actually the hardware that's responsible for running the workloads. And then you're going to have the storage bits that are just kind of responsible for keeping the data there. So for example, you could say like, okay, you're going to have like the application data, so that's going to be user applications. And then you're going to kind of have this scratch base where users can write a lot of data very quickly, but then eventually it'll get cleaned out to free up more space for other people. And then the next thing you'll kind of look at is that you can kind of then start to bolt on some additional auxiliary services to basically improve your experience. So that's typically where identity management gets put, but I still think identity management is very important. And then you also get like things like observability and monitoring, where you're actually going to be able to get insights into the health of your cluster. And then the next thing here is then the network, where, okay, the public net might be a little slower, but then where those kind of high-speed interconnects come in is more of the internal network that the nodes can use to communicate back and forth with each other. And so now, to kind of outline the overall how Charmed HPC comes together, we'll go ahead and kind of put together in steps here. So typically the way I like to think of it is that the workload manager is the core of the HPC system. So basically, it won't be able to function unless it actually has that workload manager there, kind of being able to take in user resource requests and actually kind of efficiently schedule those requests on the variety of nodes that you have available. And so the workload scheduler implementation we use within Charmed HPC is Slurm. And so if you're kind of wondering what Slurm is, it's basically an acronym, or it started out as an acronym for Simple Linux Utility Resource Manager, which, if I can tell you anything about Slurm, is that it is not a simple Linux utility resource manager. It is actually quite complex. It has over 250 configuration options, and yeah, it just turtles all the way down from there. So still, though, Slurm is also a very popular workload scheduler implementation. It's about on like 60% of the top 500 supercomputers. So a lot of people like using it. It's pretty much available on any major distribution, and so a lot of folks are going to go ahead and use it. And so here, we'll kind of go ahead, we'll actually start with Slurm as kind of the core of our Charmed HPC cluster. And then the next thing that we'll kind of then do is add a little bit of pizzazz to it, as indicated by the magic wand and sparkle. But basically what that is doing is actually adding kind of the auxiliary services that make Slurm even better. So kind of starting right here, you'll see MySQL. What MySQL is for is kind of storing that accounting data. So if you're basically interested to say like, hey, how much resources of the system are my users using, that information will actually get logged in MySQL, and then you can kind of build integrations against that to create like a billing system and all that to see who's using what. Then you can have like InfluxDB, which is a time series database for actually kind of tracking job performance. So if you're kind of finding like, hey, my jobs aren't performing so well, or are users potentially scheduling jobs that aren't as optimal as possible, you can use something like InfluxDB to actually get that data. And then the next thing is that you actually have the specialized hardware resources. So typically those will go ahead and live on the compute nodes that are managed as part of Slurm. But I use the NVIDIA logo here, but you can also use like AMD stuff and all that. But the idea is that like, you can actually set up the GPU drivers as well. So for example, if you want to schedule like an AI job on Charmed HPC, it'll go ahead and set up those drivers. The next thing is that you'll have InfiniBand, which is a popular high bandwidth networking implementation where you can get up to 800 gigabits per second. So a lot of data all at once, but very crucial for HPC setups. So yeah, you'll basically kind of have that pizzazz. So while in this slide, you'll kind of have the workload scheduler, without all this additional stuff, you can't quite get the best possible performance out of your cluster. Then the next bit here is actually going ahead and adding the distributed storage. So for that, that'll basically provide the storage for the user workloads. So for example, Slurm, using like distributed compute nodes, you want to make sure that your data is available everywhere where you need it to be. And so you can use possibly, say, a storage implementation like NFS or SafeFS to actually get that data there. So that's kind of the two current implementations that we support. There's also lots of popular HPC file systems out there like Lustre and GPFS and all that. But, they're a little bit more fun to try and set up, so we're adding them currently. But those are options that you have available for those highly parallel workloads. Yes? So typically when I say NFS, I mean like normal NFS. I know that we do want to support PNFS, but I found that like at least for testing, NFS is a really good first choice. And then SafeFS, we have a lot of resources that we can leverage there because like I know a lot of Ceph developers, and so it just makes it a lot easier. But yeah, the idea is that as you kind of said with PNFS, the storage implementation can actually be modular. So as we kind of get requests to add support for like PNFS or Lustre and all that, it is modular in the sense that we can just basically write the code that actually makes it work, and then we can just plug it in. So we could take like SafeFS out and then replace it with something else. Yeah. Thank you for the question. So yeah, so we'll have the distributed storage here. And the next thing that we'll want is the identity management. So effectively what will happen is that this will live on a control plane. So basically going over that, the way we kind of architect Charmed HPC clusters is that we have both the compute plane, so that's typically machines so that we can get the best possible bare metal performance, and then we have the control plane, which is much more suited for running indefinite services, which Kubernetes is actually quite good for, kind of separate from those machine resources. And so with the identity and access management, usually HPC systems traditionally use LDAP. You can also use like Entra ID or Active Directory. But here we're using a newer LDAP implementation or LDAP server implementation called GLAuth, which is quite the nice thing about it is that it can be SQL backed. So if you don't like writing LDAP interchange files, which I don't, you can instead write SQL queries to actually create and manage users. And so we use those two services to basically actually manage and provide our users. And then the next thing here, which is very important, is to actually add the observability integration here. So obviously, you want to be able to assess like what's the overall health of Slurm, what's the health of MySQL, what's the health of my identity stack. So we'll actually go ahead and we'll add that observability implementation here. And what you're going to kind of see is that, okay, we already have like Loki, Prometheus, and Grafana, which is kind of the standard observability stack that you'll get with Kubernetes. But then you might be asking, how do we actually collect those metrics and then forward it back to Grafana? And so for that cute little robot guy there is effectively Grafana agent, and that's just basically a daemon that's running on our Slurm control node that's just basically gathering metrics from Slurm and actually pumping it back into Grafana, so then you can actually get alerts and you can visualize your metrics. So then after that, when you actually start to kind of look at user workloads, that's a little bit more, I wouldn't say the Wild West, but you can be a lot more flexible there with how you actually want to manage that. So in HPC, there is the popular package manager, SPAC. There's also Easy Build. And then you can also have like containerization runtimes like Aptainer, Singularity, Enroot, Saris to actually provide like user workload support there. So basically, TLDR of that, a lot of different ways to run user software. Basically, all you have to do is actually just make sure those tools are installed in the compute nodes. And so the last thing that you kind of need to like really actually kind of take into consideration here is like, how do the planes communicate back and forth? So for example, you have the control plane here, so that's in Kubernetes, and then you have the machines, and basically they have their own kind of isolated DNS. So in the sense that they can't really talk back and forth because they're kind of two separate clouds. And so basically what we have to do is go ahead and expose the control plane services to the machines so that they're actually able to communicate back and forth. And typically with that, we use this cute little gopher guy up here, traffic, and effectively what it'll do is it functions as a reverse proxy that'll go ahead and actually expose services like our LDAP server or our Grafana server to our machine cloud, and then at that point then, things like SSD can actually then bind against the LDAP server, and then Grafana agent can then actually forward metrics up to Grafana and actually reach it. So now the fun question is, does it actually all work? So if the internet favors me, which I hope it does, we'll try and play this video here. So what you're going to see here is we're just going to show you like a really small HPC cluster that's running on Azure here. So we have two partitions deployed, one with high bandwidth networking, and then another that actually has those GPU resources available. And then what we'll go here is we'll just kind of upload some really simple job scripts to our head node, which is basically our jump host for actually accessing the cluster. So go ahead, type out SCP, very rudimentary, groundbreaking UX for actually interfacing with the cluster. But we'll go ahead, we'll actually upload that, and then we'll SSH into the jump host there. And the next thing that we'll do is we'll actually then go change into our basically home directory that exists on the distributed storage. And then here, what we'll show is a job script that's going to go ahead and request two nodes of the high bandwidth network, and then run a simple MPI benchmark, which is message passing interface, on that partition to effectively test or benchmark and measure the performance of the InfiniBand cards that we have. So we'll go ahead and run that. Once again, very groundbreaking CLI there, or UX. We'll actually go ahead and we'll read the file, and then there, what we can kind of take away from this video is that we were able to achieve the advertised performance of those InfiniBand cards, which was about 200 gigabits per second. And so then the next thing that's going to happen here is we're actually going to go run a job that requests and uses the GPU partition that we have. So here it'll show basically our very simple request, basically say, hey, Slurm, go out and go get me a node that has a GPU. So we'll go ahead and we'll go submit that. Basically, what we're going to do is go run some very simple arithmetic operations on that GPU. So, maybe taking $1 million resource and, doing 1 + 1. But hey, we're going to prove it works. And then we'll go here and, you can kind of see it, the text is very small because, I wasn't expecting it to be this small. But the idea is that, hey, we were actually able to get the device info and then run those operations on the GPU. So yeah, now that I've kind of, run through what Charmed HPC is, you might be now sitting here and wondering, okay, so he said Charmed HPC on OpenStack Sunbeam. So what does OpenStack Sunbeam have to do anything with Charmed HPC? Well, I'll tell you why. That 2-minute video cost us $20 to make. HPC resources in the public clouds are very, very expensive. So here, looking at the 2 instance types that we actually requested on Azure, the first one that we requested, actually we requested 2 of them, the high bandwidth networking nodes, those each cost about $2,600 a month just for 1 instance. So you can imagine, $2,600 over a month, that's about, say $4 an hour almost just to use one of those nodes. And even to really actually benefit from high bandwidth networking, you need at least more than 1, so you actually have to pay for 2. And then actually then for the GPU instances, luckily they're a little bit cheaper since the public clouds want to sell GPUs to people. That was about $1,500 just to request one of those nodes. So you can kind of see like, okay, what we showed you in that video was like a really small cluster just to prove out the functionality, but to actually build something that's useful where you're actually training like LLMs, you can kind of see how that's going to get very expensive very quickly. And so the benefits that we kind of try to see with Charmed HPC is the ability to have portable HPC infrastructure, on public cloud. So for example, if you're, say, on Azure and you decide, oh, well, I don't want to pay for Azure's resources anymore, it should be really easy for you to just get quickly spun up on GCP. And kind of the same way for like AWS and Oracle. You should be able to kind of take your infrastructure where you want to go without necessarily being locked into a particular vendor. And we should also show that same love to private cloud implementations where, okay, sure, you might have a longer, cluster bring up time, but, you're also kind of having a little bit more predictable costs with your data center. So a couple of popular implementations, we have OpenStack, that's kind of more for like the enterprise deployments, the big clusters. We have Moz for if you want to be closer to the metal. And then we kind of have more of the training stuff like Canonical LXD, where, instead of like, hey, you're deploying a huge production cluster, instead you're kind of having something more of a learning environment where you can just kind of play around with the HPC system. So then you'll sit here and you'll say, okay, so why do you want to use OpenStack Sunbeam? Well, it's an extremely straightforward setup, at least for a single node. So you can kind of think like, okay, we're going to use the public cloud or this huge expensive data center, to run, jobs like weather modeling, CFD simulations. But, if you're just training somebody, you don't need to give them access to those $1 million resources. If you just want to teach them, okay, this is how you request a job, this is kind of how you're able to ping pong back and forth between 2 nodes, you can give them a much less expensive and virtualized environment. And so for that, you can use something like OpenStack Sunbeam, which is kind of a very easy way of actually like deploying, a full OpenStack system. So you'll kind of see here, basically to actually get a full cloud, on a single node working, all you have to do is run these 4 commands. So first, all you really just have to do is like a sudo snap install OpenStack, specify your channel. After that, you'll just have to prepare your machine for actually running OpenStack. After that, then you'll just do like a cluster bootstrap. If you don't need anything fancy, you can just accept the default options. And then after about 30 minutes of actually setting up all the different services that bring together OpenStack, then all you have to do is configure it to actually get your OpenRC file, which just basically contains your credentials for actually accessing those the cloud you just set up. And so you might be wondering here, okay, so you just showed us these 4 commands. What does it actually set up? Well, it sets up this very complicated thing for you. So basically, what is exactly like Sunbeam? It's a cloud-native OpenStack that's managed by Kubernetes. So effectively what you can do is that you can take OpenStack, you can kind of split it into 2 planes. The first part is you have kind of the cloud control, so that hosts the OpenStack services that are kind of responsible for actually controlling OpenStack. So for example, you could say you have like Keystone, which is responsible for authentication within the cloud. You'll have Glance, which is kind of responsible for actually like serving up the different images that you'll request. And then you have like Neutron, which is for configuring the network of your OpenStack cluster. You'll have like the Nova controller, which actually, kind of manages the virtual machines that you'll provision. And then you'll have like RabbitMQ for actually exchanging messages between the services. And then you'll get kind of more to the machine plane, which is the cloud data plane, which then kind of has the more on-the-metal services. So for example, you'll have the Nova compute instances. So those will be the virtual machines that you'll actually like run workloads in. And then you'll also have like Oven Chassis or Open vSwitch, which manages the networking for those virtual machines. And then you'll need kind of the storage for those virtual machines, which is provided by Microsoft. And then here, for the cloud management and governance, that's just basically how you actually interact with and drive the cloud. So you'll have OpenStack CLI command for actually like interfacing with it, and then you'll have Juju for actually managing the different services. And so now you'll kind of wonder, like, how do Charmed HPC and OpenStack's Sunbeam go together? So I've kind of presented Charmed HPC as its own thing, and then kind of OpenStack as its own thing. So now how do you actually bridge the two together? And so the way that I look at it is that Sunbeam is kind of basically a substrate for Charmed HPC. So you'll basically have Sunbeam underneath Charmed HPC, and then what Sunbeam provides to Charmed HPC is kind of the compute instances, the networking, and the storage capabilities. And then effectively then, it doesn't really show up on the contrast of the projector, so I'll use a darker gray in the future. But what should be symbolized here is a little very faintly gray-white line, or a gray line, that shows kind of the degree of separation between Sunbeam and Charmed HPC. So you'll probably be wondering, like, okay, how do we actually, manage, Charmed HPC? How do we actually get it onto Sunbeam? And so this kind of goes back into Alistair's talk, if you were here earlier, but open source applications, so obviously you have like, things like Slurm, Grafana, all that stuff that comes together, but where's the code that actually like operates those services? What actually brings them together and actually makes it such that they can work? And so for that, we have Juju. And the great thing about Juju is that it can basically work with any application. It can scale that application however it needs to be. It can put that application whatever platform it needs to be on, and it can basically put it on whatever cloud you need it to be on as well. And so if you're kind of wondering, like, okay, obviously that's a lot of promises that it's going ahead and making here. How does it actually go ahead and do that? Well, it uses charms. And so I might not try to make it sound as black magic as usual, because that's what Juju means in South African language. But the idea is that effectively what a charm is that it's operations as code. So you can look at it here like, okay, so you have your application. So for example, you could look at it and say like, oh, this is what, Slurm, or you could say this is Grafana, or this is NFS, this is SAFFS, and effectively like you have all these different things that you need to be able to do with it. So like, okay, you need secrets management, you need to be able to kind of control access to that SAFFS share, or you might be exchanging like the, say like, authentication token that the Slurm daemons use to basically trust each other. You'll also have kind of the observability bits, like how do we actually set up the metrics collection? You'll think of patching, like, okay, how do we actually apply updates? And then, also for like upgrades and logging and auditing, just kind of general software lifecycle stuff that while, you might not think of when you're actually deploying and setting up the system, these are very real things that you need to consider as you're, trying to sustain a system for the long term. And so the great thing about charms that we can make for our HPC system is that they are very flexible. So basically you can have very composable architecture. So while you could look at how I actually set up, say like Charmed HPC or OpenStack Sunbeam, the nice thing is that you're not necessarily stuck to that way of thinking. It's like charms, as long as they have the proper integrations, can kind of be composed in different ways. And so for example, you could say like, oh, on AWS, I want to set up Kubernetes. I want to have, on that Kubernetes, a Postgres, basically integrated with like Apache Kafka with Prometheus, or you can also then say like, oh, I want more of a bare metal implementation where on top of that bare metal, I'm deploying OpenStack, and then on top of that OpenStack, I then have Kubernetes as well. Or you can then also say like, okay, I want to use a different cloud like Microsoft Azure, or I just want to have straightforward Kubernetes. And so then you might be wondering like, okay, so we obviously have this flexibility and composability. How do we actually go about putting them together? And so typically for that, what we'll go ahead is that you can use either Terraform or OpenTofu, open source. So, Tofu's my guy. But effectively, what you can use is, just declare your HPC infrastructure as code, and basically you can create these plans that basically say like, okay, how do you actually wire together Slurm and all its daemons? How do you wire Slurm with like MySQL? How do you wire it up with InfluxDB and all that? And so effectively, what these dotted lines represent here is kind of the integrations that exist between all the different services and how they're actually able to exchange data back and forth to go ahead and configure themselves. And so with that, if you found what we talked about today interesting, I do have this QR code here. What it'll do is it'll actually go take you to our documentation for Charmed HPC. So we are still a relatively new project within Canonical. And so, one thing that we've been really trying to focus on is actually building out our documentation so that more folks are actually able to use this stuff, because while I can come and give presentations and stand in front of you and wave my hands and say, oh, this is how everything goes together, oh, it's so great, really what we're interested in is also actually gathering that feedback where it's like, hey, I'm not really an HPC user, but I want to learn how to use HPC. I went through your how-tos and I found this to be challenging. That's the kind of feedback that we want to hear, because that's how we're able to actually make our product better and all of that. So. Also, if you're scanning QR codes isn't necessarily your thing, I'll be at the booth throughout the weekend, so if you want to come up and talk or maybe even get like a live demo, be more than happy to do that. So yeah, no, that's pretty good. And then the other thing is that if you are interested in kind of what we're doing in the high-performance computing space on Ubuntu, we actually do have a pretty active community. We meet once a week on Wednesdays, and we also do actually maintain a public presence on Matrix as well. So if you ever have an HPC question related to Ubuntu, we'll talk about other distros as well if we really need to. Be sure to jump in. And then, yeah, that's pretty much it. Thank you for coming to my talk. And yeah, any questions? And if you're interested in keeping the conversation going, feel free to scan the QR code. And thank you for coming.
Thank you, Jason. Do we have questions? All that high performance computing you've been doing at home. No, come on. Okay.
Yeah, not exactly something you do in your garage, but we might be able to change that one day.
Well, I'm tempted. When I see your demo, I'm like, I'm going to put some computers together just to have some fun. But yeah. The suggestion is he's going to make a question happen.
Yeah.
All right, here we go.
Is the ARM processor supported?
Yeah. So we will be supporting ARM. That is something we're looking at. So obviously it's kind of fun because, when I develop, this is actually my work computer right here. So when I build the HPC systems and actually test it, and yes, you can have the hat. We build for x86 currently, but we do kind of have the policy of like, okay, ARM and RISC-V are realities, like we can't just ignore it. I mean, it's like you look at what's going on in China right now where there's a lot of interest being put into RISC-V, and a lot of folks are also interested in ARM since it allows, I guess you could say the public clouds to be a little bit more self-determined in how their architecture is actually put together, because they basically don't have to buy things from Intel. Instead, they can license ARM from ARM and then build their own chips. And so it is something we are going to support. I think, right now it's like what we've been focused on, and now we're moving on from is that we were, the table stakes, like, okay, how can we actually put the cluster together and make sure it works and provide a good experience? And so now what we're doing is actually looking at kind of these more expanded use cases where it's like, okay, people want to use ARM. How can we make sure that, you can take Charmed HPC, you can deploy it on x86, you can deploy it on ARM without needing much or any manual intervention from the user. It's like they could honestly have no idea. All they have to do is just pass a string that says, oh, I want to use ARM instead of x86.
Any other questions? Well, then, thank you. Thank you, Jason.
All right,
we'll take a little break, and we'll be back here at 4. We have 2 people. We have Ken and thank you.
Rajan, yeah.
All right, so we'll be back here at 4 o'clock. We still have coffee in the back. I'll see you then.
Thank you.
What were the prices that you were showing for the public cloud? They're the ones to compare.
With Lambda?
Yeah, exactly. I was just curious.
So, to be honest, we haven't looked fully at Lambda, but I know the one problem is like we look at Juju while, Juju is like, oh, it works with all the public clouds, it doesn't work with every cloud, you know what I mean? So I think it's like Lambda and like Vultr and all those stuff. So you guys are like way cheaper because of like the fact that you just don't, you're not basically using your cloud to support like every other vertical that you have.
Yeah, no, I just didn't catch the numbers. Like, when you had the slide on, I wasn't fast enough.
Oh, that's totally fine. Well, I'll tell you more.
Yeah, of course, yeah, you could build along the cloud.
Yeah, here. That's high. Yeah. So this one, this is about like 200 gigabits a second, and then the NT series, which has like yeah, so it's like Tesla, not an H100, it's like a generation before that. What's the price by hour?
Starts at 450.
That's a little bit less.
But you can do it 24/7 for a month.
Yeah. Yeah, so this one, the InfiniBand nodes, they're about $4. When I say $4, they're more like $4.80 for like an hour, and then obviously there's one for the high bandwidth. The GPU nodes are like way cheaper. Obviously, I guess like, video hard to run for InfiniBand cards versus their GPU. But yeah, usually I think, clouds like Vultr and Lambda are usually way more expensive.
Well, because there's far less functionality in that cloud.
Yeah.
You have just the hardware, that's it.
Yeah.
Not much more.
Yeah.
Hey, Mitchell.
Yeah.
I'm with Disney Branded Television.
Oh, yeah.
So I've been kind of tasked to implement an Unreal pipeline.
Yeah,
Along
yeah.
with other like VFX software. So interested in HPC.
Yeah.
Have you guys dived into VFX?
Yeah. So we're very into VFX. That's more like on the alliance side, because I think like right now it's like it's kind of basically saying like, hey, so like CentOS just like isn't a thing anymore. You should just try and use Ubuntu. When it comes to VFX, like it is something that we are interested in. I think where the challenge starts to be is that, at least when I find the VFX, y'all are a lot more interested in like high throughput computing, which is a little bit different than high performance computing. But like high throughput is basically like you just have a massive amount of data and you're trying to get it through. At that point, then it's like, okay, how can I get like the most possible data through in the shortest amount of time? While HPC is like, how can I get just like all these little jobs through really quickly?
From the interruption, I'm just letting you know, I'm going to be upstairs talking to facilities to see if we can raise the temperature of this room.
Okay.
It seems like it got cold very quickly. I'll see if I can-
But so usually in like VFX, I think, at least in DreamWorks, they really use like HT Condor, which is like a high throughput scheduling system. But we are interested in like VFX and the idea of just like being able to support like those big data workloads. It's like you just kind of need some level of scheduling there. Yeah. So.
Fair enough.
No, I think I think it's very interesting. I think, especially like in the day and age of AI, like I think it's great to be in HPC right now because I think a lot of people are starting to realize like, oh wow, this isn't just for like scientists and academics and all that. It's like actually has real world value. Or I wouldn't say academia is not real world, but it has like value outside of that industry. Or that ecosystem where it's like a lot of folks like, okay, we actually really need these high-powered resources, and like how do you actually like efficiently make it where it's like an entire team of VFX people can actually still like train their stuff and not just like backed up in a queue.
Yeah, we just dropped $1 million with HT on 2 crate systems.
Oh yeah.
And we are starting that process. But it's been a fun time. But no, I really enjoyed it, and I'm probably gonna have some questions. So that was your email, HPC engineer at Canonical.
So I have a business card I can give you actually.
Oh yeah, that's great.
Yeah. I find that my last name is very hard to spell, so I'm like, oh yeah, just look me up, man. Like, never happens. It's like, is it Nutroni, like macaroni? And I'm like, So here you go. That has my email.
Excellent, man.
But yeah, no, it'd be totally interesting to talk about like what you're interested in, because I know Crate's very interesting because it's like for like vector processing, but I know it's like the HPC community is like, oh well, Crate is basically becoming glorified x86, which I'm not sure that's how it's actually going down, but it's definitely I'd definitely be interested to see like what your use cases and what your challenges are.
Yeah, main thing is we're mostly
Thank you. And, good luck.
Yeah, thank you.
I go warm up a bit.
Yeah. We're going to go yell it down there, chasing people out of the room, being so cold. horrible temperatures in it, so it's been like wet and rainy there for like the last 3 months. 40 degrees.
We've had a bunch of snow in North Carolina.
Yeah, I know.
Very, very.
Y'all have been like getting beat up. Here. Floods in Nashville area.
Yeah, my daughter went to school up there.
Yeah, I remember you said that, and I was like, oh, geez, yeah, I hope everything's good. Yeah.
Scary. Is this reliable power? Plug in?
Yeah, it might be.
Yeah, it looks like it should be. It's 100 watts? I don't know if it's 100.
It's just for my framework, yeah. So you can try it if you need it.
All right. I'm too old to need that. My eyesight's not there anymore.
What, you can't like 40?
I'm kind of walking right into that whole graveyard stereotype.
I just have progressive lenses where I'm like now having to get used to reading like this.
I need them. I just refuse.
It does suck. I hate wearing them.
At least you can see.
60 watts. Okay, I'm not going to gamble with this. I don't know what's going to happen. I think
We got that cool, expensive framework there, or not framework, Alienware. Get myself some coffee. Warm up here a bit. All right. Well, thank you for being here, folks. Now, everyone, once the exhibit hall opens up, it's always interesting, you know. People are giving out backpacks, and it's like, I had to bring a backpack on the airplane, so how am I supposed to get 2 backpacks back now? It was one time that I had to they just gave me a backpack that I didn't ask for, and it's like, well, I feel bad if I throw it out, you know, so I just had to crumple it up and then basically put the backpack inside the backpack, and it's like, at this point now when I go to tech conferences, I just steer clear of everything. I do the no stuff thing. I'll get stickers, but it's a lot. It adds up after a bit. But yeah, while we get set up here, our final technical talk for the day, ID and Google IAM on Ubuntu Desktop and server. Yeah. All right. Do y'all want the over-the-ear hook, or you just want the microphone?
Yeah,
I would wear that. I find it a lot easier. The presenter's view, or that presentation there. Yeah, if you just do, okay, so you got a function key, so if you just do function F11, that should make it full screen. Okay, just hit F11, see what happens. There you go. All right. Thank you for being here. It is a little chilly in here. I don't understand why they want it to be an ice cube. So if you do need to warm up, we have plenty of coffee. So feel free to help yourself. We also have hot water and decaf as well. And yeah, we'll go ahead and get started here with our talk from Rajan and Ken about authd.
Thanks for the intro, Jason. All right, you guys are in for a treat because originally we were talking about just authd. On March 6th, Massimiliano Gori published a blog post on ubuntu.com/blog saying you can also do Google. So the excitement for today is going to be configuring your Ubuntu server or desktop to log in with your Google account. It could be a Google Workspaces account, or it could be your personal Google account, or logging into your Ubuntu desktop or server with an Azure Entra ID account. So if you've got a custom SSO at your company and you want to use that custom SSO to log into an Ubuntu machine, we're going to go through the steps of how to set up this software on Ubuntu, how to configure it, and then also how to do it at scale with Landscape. So let's go ahead and jump right in. The agenda, which I sort of just covered, authd for OIDC, for authentication on Ubuntu. Then we're going to do the deployment, the initial deployment with Cloud Init. Cloud Init is like a infrastructure as code best practices way of general availability. Point number 3 is applying the configurations at scale with Landscape. And then lastly, taking the whole thing to production. So there'll be some examples for how you can spin up something on public cloud and then get it set up. So authd is brand new. It's new to the Linux world. It's unique to Ubuntu. So if you were to get another flavor of Linux, you're not necessarily going to be able to use OIDC to authenticate using some external provider with that Linux system. So that's a nice, solid value proposition for Ubuntu here. There's a slightly different approach, or rather a different configuration for desktop versus server. On server, you're typically only worried about SSH connections. On desktop, you may be interested in SSH connections, but you also need the GNOME, the GDM login configuration as well. So we'll cover both of those. So the original slides, as per the agenda, were just for the Microsoft Entra ID. We're also going to cover Google IAM. We burned the midnight oil and we got the additional info in there. So, the authd architecture at a high level. If you start at the very top left, you'll see that you can log in with libc, SSHD, I don't know what the login box means, or GDM. And then it goes through, if you follow the arrows, through various modules within the authd application. And authd reaches out to the identity brokers. So you can have a custom OIDC broker, an Entra ID broker, and then the Google OIDC broker. It's worth noting that Massimiliano Gori, originally, before joining Canonical, he worked at Okta. So it's anybody's guess as to which provider is going to be next on the list. And then ultimately it goes to the host system and out to the identity providers. So if you were using Azure, you would log into your Azure cloud account. You would have to create an application inside your MS Entra ID section. So that's sort of what this screenshot is directing you towards, is go to that app registration menu item in the left-hand side nav, and then you're going to click New Registration on the App Registrations window. Once you've created the application, in this case they've called it Azure OIDC POC, you're going to get an application ID, and they've put the word client in parentheses here. You're going to get a tenant ID. So I want you to keep these IDs in mind. We're going to copy those to our clipboard and use them shortly. If you were doing this in Google, the Google ecosystem, you would log into Google Workspaces, and then you would create an application in Google IAM, and you'd effectively do the same comparable thing. You're going to create an OAuth client ID, and you're also going to get credentials for this OAuth client ID. Interestingly enough, you would have to specify that you're using a TV or limited input device when configuring this application on the Google IAM website for it to work correctly. The nuances as to why is in the documentation, so I'll leave that for there, because there's about 80 slides that I'm going to be blasting through here, and I don't want to get hung up on little details. So at the end of the day, you've got the OAuth client ID created in the Google environment. And then next, let's assume that we're working with the server. That's a simpler use case. So the install and configuration steps for the server entail adding the authd deb to the machine. You'd have to install it from a PPA. So you would have to add that PPA to your machine, and then apt install the authd package. And then you have to install the brokers, the authd MS Entra ID snap, or the authd Google snap, depending on which provider you're going to be using. Remember that client ID that I was telling you guys to copy to your mental clipboard earlier, so that's step 3. And then step 4 is configuring the SSH service. You have to set up a config file and then specify PAM and then this other interactive authentication parameter in there. Restart your SSH service, and then you're ready to rock and roll. Seems pretty easy. Now if you're doing the desktop, I've actually, I don't know if you can see it, but I've faded out step number 4. If you don't care about SSH authentication on your desktops, don't worry about step number 4. Oh, and step number 1, we've added a couple of additional packages here. It's not just authd. you need to add GNOME shell and then this Yaru theme GNOME shell deb. So you can get a QR code when you're logging in. So you're not typing in your username and password. You've got a QR code experience instead. There's a screenshot of it later in the presentation. So the high-level steps for performing this installation on server, 3 commands: add the PPA, update the whole system just so that it knows where to get the authd package from when you run the apt install authd command. And then for desktop, the same thing, but with the couple of additional packages that we need to get, the GNOME shell and the Yaru theme GNOME shell package. If you're doing the MS Entra ID, you want to get the authd MS Entra ID broker. You're going to make a directory in the etc directory to configure authd, and you have to copy the config file from the snap directory into your Ubuntu system directory. I wish the snap package did this out of the box, but snaps being confined as they are unable to do that. So
limitation by design.
Yes. So that's a thing that you're going to have to manually do. But there are ways to simplify this, and that's through Cloud Init and Landscape. We'll cover that in a little bit. If you're doing the Google IAM broker, same steps. You're creating that brokers directory and you're copying the configuration file from inside the snap into the system's etc directory. Next, we're going to configure that file that we just copied. Or I'm sorry, not the file that we copied. We're going to configure a file inside the snaps directory, the broker configuration file inside the snap. If you're using MS Entra ID, you have to specify the login.microsoftonline.com issuer, and then the client ID that we had copied to the clipboard from earlier.
It's important to note it's not actually inside the snap, it's inside the snap's writable space. Because snaps are read-only, you can't edit them or alter them in any way. But there is writable space, and the snap writes these files out into that writable space. And then you can edit them.
Excellent, thanks for that clarification. So yeah, the Google Snap is the same thing. In the authd Google broker snap package, in that package's writable space, you've got this broker configuration file, so you're going to add the appropriate issuer and the client ID. And with Google, you have the secret as well. With Microsoft, we didn't have that. With Google, we do. So just be mindful, depending on which one you're using, configure it appropriately. Now, there's a user section inside the brokers.conf file. This is the explanation as to what the allowed users are going to be. Long story short, if you have set it to owner, then the first person to log in is going to be the owner of the machine. If you want it to be done differently, if there's a guy whose responsibility it is to provision the machines and then hand them out to people, you will have a different value there. Continuation of that previous long explanation. This is the authd configuration file for the SSH service. Use PAM yes, and then that KBD interactive authentication also set to yes. Now if you've got people using SSH to log into your machines, you want to specify the home directory for that user when they log in, and what suffixes do you want to allow to SSH into the machine. Maybe the company has multiple domain names. So I've got example.com and another example.com listed here, but you could keep things simple and just have one. Maybe it's just at canonical.com or wherever it needs to be. Restart the SSH server, so that's pretty straightforward. Sudo systemctl restart SSH, and restart the authd and MS Entra ID brokers. Same type of commands. Restarting the snap, sudo snap restart authd MS Entra ID. Or if you're using Google, replace it with the appropriate broker. Yeah, so when you're at the login screen for Ubuntu Desktop, this is an example just for Microsoft Entra ID. You don't have to start typing in your username. You actually have to click on Microsoft Entra ID, and then you're going to be presented with a QR code, and then I guess you use your phone at that point. So with Entra ID authentication, you're going to have to specify a code that gets texted to you, or maybe you open up the two-factor authentication application on your phone. On Google, it's the Google Authenticator. Microsoft has their own thing as well. So depending on what you're using, you're going to have to punch in however many digits to log in. Once you've done this, the very first time you log in, it's going to create a username, and it's going to create a local password. This is a one-time thing. So you create a local password for this, and then you won't have to type that password again in the future. I guess unless you're really good about memorizing passwords, make sure you don't forget that one. And then automation with Cloud Init. This is where it gets juicy. This is the fun stuff. I like to organize my Cloud Init YAML files with Jinja. So I put all of my configurable variables in the very top as Jinja variables. And here I'm just setting the client ID, issuer ID, all the stuff that I collected from earlier into a Jinja variable. I'm also storing the broker here. So authd MS Entra ID. You could replace that with authd Google. In fact, this is the example with authd Google. 2 lines to update the machine when it's initially booted up. Package update true, so that's going to update all of the repositories, and then package upgrade true. Now, from the last time that that image was made and today, have there been any security updates? I want to make sure I catch those. That's why I've got this here. So that's the very first thing that's going to happen when the machine boots up. Cloud Init takes care of the ordering of all of these things on its own. The second thing I've got here is configuring the apt sources. So I'm adding the PPA for authd. That's how you would add a custom PPA using Cloud Init. And then I'm issuing the command to install whichever broker I had defined in my Jinja variables from earlier. The variable was named broker. So to use that, just a couple of curly braces and then the word broker. And then the packages is just what deb packages do I want to install. I've already added the PPA, so it's effectively doing the equivalent of apt install authd. So instead of typing out all these commands, it's all defined in the Cloud Init YAML file. And in the case of Ubuntu Desktop, I'm adding the couple of additional packages that I'd called out earlier. Now, I wanted to configure those configuration files, and that's where this gets a little bit ugly looking. So I've got this sed command that is going to open up the configuration file and then add the client ID. It's going to add the issuer ID, and it's going to write that into the broker.conf file. Hopefully that doesn't look too intimidating, but it's just pretend you were at a terminal. That's effectively what's happening there. I'm changing the login timeout to be a little bit more friendly to my speeds. The default is not 60 seconds, but I prefer 60 seconds. I need a little bit extra time. So that's what that line is all about. It's optional. You don't have to do that. You don't have to update etc login.defs, but you could if you wanted to be nice to people that need extra time to whip out their phone and find their codes. The next line is make that directory and then copy a file from the, how did you phrase it? The snaps.
Snaps writable space.
The snaps writable space to the system's etc file.
Well, in this case, it's actually from the read-only space of the snap.
Ah, okay.
Yeah, the other place was where the writable space is, but you were copying content out.
Yes, okay. There
Basically like a template file is what you're doing here.
Perfect. And then for rebooting the machine, we could have added just the reboot command in the run command section, but that's the wrong way of doing it. If Cloud Init gives you a module for performing an action, you want to use that module. You don't want to script your way through an entire Cloud Init file by leveraging only the run command section. So that's why I've got power state mode reboot. That means when everything is completed in Cloud Init, it's going to reboot the machine, and it's going to print out that message that all the Cloud Init modules have completed. It's rebooting the machine. The Google IAM configuration's exactly the same almost, with the exception of adding a line up here at the top for adding the client secret. But otherwise, it's the same, and then that CP command is fetching the google.conf file as opposed to the MS Entra ID conf file. I'm going to hand it over to Ken. We're going to review doing these things at scale with Landscape.
Yeah, so Rajan was just talking about, provisioning this during provisioning, doing that configuration via clouding it. But maybe you have a fleet of machines that you manage, 10,000 desktops in your organization or whatnot. You don't want to go and maybe re-provision them, or have to physically touch those machines and edit all those comp files, right? So Landscape is our management tool, I guess you would call it, for managing fleets of machines at scale, right? It's really an outstanding tool. It's been around for a very long time. I mean, I think it was a Canonical product before I joined 16 years ago. It's been around for a long time. It is very mature. It's got tons of features. It's now starting to look modern. Thank you, Rajan. So we have a few different editions of Landscape. Self-hosted. This is single tenant where you host it yourself on your site. There's new releases of Landscape, basically in the same cadence as Ubuntu releases every 6 months. And you manage it yourself. There's our SaaS offering. This is landscape.canonical.com, is that right?
Yes, that's right.
Yes. Multi-tenant, so you basically get your own little space inside of Landscape where you can manage your own machines, but other customers and users are on the same Landscape instance, essentially. They're just segregated from you. And it's managed by Canonical, and it's got the most bleeding edge features. This is kind of where we roll things out first, most of the time. And then there's a managed Landscape, which I guess this is kind of in between, right? Where Canonical will manage it.
Yeah, so it's single tenant, and you're going to get all of the features from the stable version of Landscape, meaning that everything's been battle tested at scale in Landscape SaaS. We know that you can throw a large volume of computers at Landscape and it's not going to go sideways. So managed Landscape has an SLA. Landscape SaaS does not have an SLA by virtue of the fact that it is multi-tenant and it always has the newest features coming right out of beta. So.
All right, so first thing you want to do is Pro attach your device because Landscape comes with your Pro subscription. Pro enable Landscape, so the feature to access Landscape isn't enabled by default. You need to enable the Landscape feature. And then we have a couple lines. We need to tweak the Landscape client configuration file to allow a few things. So in order to deploy these changes to many machines, we're going to use script execution. So basically, Landscape has the ability to run a shell script on your entire fleet. So we're going to echo this line here to effectively add to the client.conf file to allow script execution. And what users are allowed to run scripts. So these are the system accounts that are on the machine that's capable of running scripts. And then if you want to take a glance at this is what the end result looks like. It would look something like this in the configuration file. And then you restart the Landscape client service. This will enroll the machine in Landscape. So as long as your machines are enrolled in Landscape, then they can be managed from one single console. You don't have to be on the physical devices anymore. There's a little recap of all the commands. So there's many features of Landscape. Today we're really just going to talk about the features related to how you would deploy these auth-D configurations. But there's lots of things we could do with Landscape. So we start off, we have no scripts defined. We have to define a script, and the script is going to enable auth-D. So the first thing we're going to do is we're going to figure out the syntax for our script. This is very similar to the steps that Rajan already took you through. So we're going to write a script that sets these environment variables, the client ID, the issuer ID in this case. Then the lines here to add the app repository in order to get the auth-D package that we need, as well as the versions of GNOME Shell and the Yaru theme that we need in order to do the login in GDM. And snap install auth-D MS Entra ID or Google, and if you want to use Google. Then we're going to sed a couple lines here in a configuration file and change the login time. So exactly the same steps that he took you through. We're just going to put this into a shell script. And same things, copying those files over and add reboot. Okay, so now we've created a shell script. And we can drop that into this web form here, name the shell script, specify what user is going to run it. So we need root to run it. And add the script to landscape. So once it's added to landscape, then it shows up as available to use. Then we can specify the machine that we want to send this to, or groups of machines. Maybe you want to send it to your entire fleet. So you can, select your instances and run script. And it'll tell you when it's queued it. Landscape doesn't do things necessarily immediately. The clients, as they check in, will look for jobs that need to be accomplished and execute them. So they may trickle in. There may be a machine that's not turned on yet. When it gets turned on, it'll check in with landscape and see that it needs to run the script, and landscape will do its thing. I thought I had reordered these slides. All right. Yeah. I'll jump around. Okay. So the next thing we need to do is, one thing we want to make sure that the packages that we've installed on these machines stay on the machines, right? Because if the user is on the machine and maybe they do have root access and they uninstall authd, that's a problem, right? Because now they can't log into their system again because they're relying on these sort of brokers. So we want to enforce keeping these packages installed and from the correct place, the location. So we're going to add a repository profile and a package profile. The repository profile requires the GPG public keys from the app repository. So we're going to go to import a key. In order to find the key, we need to go to the PPA that we've added in our script. And if you click on technical details there in Launchpad, you will see the signing key, which you can click on, and it'll take you to another page, and when you click on it there, it'll give you the entire contents of the public key. So there you can grab that and stick it into this form here to import that GPG key. And once you import it, then Landscape knows about that key that we need for that repository. Then we'll go to app sources and we'll set up the repository, which is pretty intuitive. You grab the app line from Launchpad and dropped it in there. And essentially what this does is it's just like the syntax for the sources list file. And we add that. Then we create the repository profile. And we specify, we check the authd one that we just created and add that repository profile. Then we create a new package profile, and we specify that and associate to all instances. And essentially what this does is it enforces that that package profile stays on that system, right? So the system has to always abide by that, right? Am I right?
That's right. So when you have a package profile, you can say that this package has to be at this version, and it can't deviate from that. And if the user removes the package or upgrades it to a version that it's not supposed to be at, Landscape is going to flag that and then mark that machine as out of compliance. And then from that one central place, you can go in there and make the machine compliant again.
Okay. And you can install snaps remotely from Landscape. So here we can go in and install that authd MS Entra ID or the authd Google IAM snap and send it to all the machines as well. All right, so that's the Landscape, the piece of this. Oh, go ahead.
Oh, no.
I thought you were going to.
No.
You're getting ready. Okay, sorry. That's the Landscape piece. This is how we would deploy this to a large fleet of machines, right, that you need to manage. But of course, another essential thing in managing all of these machines is Ubuntu Pro, right? Like you want the stability, the reliability, the security fixes, access to things like Landscape, which comes as part of Pro, along with that. So you want to jump in and talk here?
Yeah, so it's just funny because somebody on Reddit was asking, hey, this free PBX software, which is like some voice over IP software, uses asterisk under the hood. They wanted to use Azure Entra ID to log into free PBX. Interestingly enough, now that we have this Azure Entra ID integration baked into Ubuntu. Some other motivated person created an Azure Entra ID plugin for FreePBX. So Ubuntu is the only place where this person can get full end-to-end Azure Entra ID integration into FreePBX. If they install that person's plugin for FreePBX and then added the Ubuntu Azure Entra ID auth-D implementation onto their Ubuntu virtual machine. Just on March 4th, I published an article explaining how to install FreePBX and Asterisk on Ubuntu. And on March 6th, Masi published instructions on how to add the Google auth-D broker. So you guys are getting stuff hot off the press. Probably the first people to get this presentation.
All right, so a little bit more about Pro. A very important feature that we provide with our Ubuntu Pro subscriptions is expanded security maintenance. As you know, with an LTS of Ubuntu, you get 5 years of support for free. However, that 5 years of support, security fixes and things like that, is packages that's in the main repository. Okay, these are the things that are installed essentially by default in Ubuntu or some version of Ubuntu that are in main. There's a tremendous number of packages in Universe, like for example the free PBX related packages, things like that, that we don't just automatically security fix necessarily. We will do that under ESM. So if you are you subscribe to Ubuntu Pro, you will get security fixes for all of this stuff in Universe. Not only for the 5 years, but you'll get it for 10, which is a great value. And if you're managing a fleet of thousands of machines, this could be something that could be very important to you, especially since you're most likely going to be using some stuff in Universe.
Yeah, if I could just say that in a slightly different way. If you get Ubuntu LTS on day one, we release it in April. You download Ubuntu LTS on day one, and then you install a package from Universe. Let's say, hypothetically, you install the Asterisk package from Universe. Trivia question, is it going to get security updates without the Ubuntu Pro token? It is day one of that LTS release. Okay. The answer is, it does not get security patches, right? You have to attach the Ubuntu Pro token, and then it's going to add the ESM repositories to that Ubuntu LTS machine, and then you will get security patches for that package in Universe on day one. A lot of people mistakenly think that, oh, I've got 5 years of security patching coverage on this Ubuntu LTS, I don't need Ubuntu Pro until 5 years are up. And that's not true. If you're installing any third-party open source software and you want Canonical to provide the security patches for it, you need to get the Ubuntu Pro subscription.
The good news is everybody gets 5 Ubuntu Pro tokens for free. And if you become an Ubuntu member, you get 50. So, we are very generous at giving these things out, but the idea is if you're managing very large numbers of Ubuntu machines, it's probably worth it for you to pay for the subscription, right? But it is quite easy to get these subscriptions yourself. And I think I've probably already covered those things. Another example besides the free PPX stuff is like, say you're doing data science stuff and you need PyTorch or TensorFlow or any of these. Those are all things that are in Universe. So they all apply, the same thing applies to them. Yeah, security maintenance for all open source. I think we've covered all that. Yeah, a bunch of examples of things in there that would be covered if you had a Pro. And you can take over here.
So earlier we mentioned Cloud Init as a nice way of configuring all of your Ubuntu instances before you've deployed them. These are 3 examples of places that you can feed Cloud Init YAML configuration files. If you're deploying something in Landscape, in Maz, or in Juju, I think Cloud Init YAML is relevant in all 3 of these places if I'm not mistaken. So that's all I really wanted to highlight with this slide, is that if you are not familiar with Cloud Init, go to cloud-init.io, get savvy with the documentation. It's really straightforward. And then when you start configuring your Ubuntu machines with these YAML configuration files, you're going to wind up with much more consistent environments. It'll be easier for people when they're rotating through an organization to be working with these Cloud Init YAML files as opposed to some predecessors' shell scripts to configure a machine.
Automation, automation, automation. Reproducibility. All right. Questions? Oh, get the mic.
All right. So this is super interesting to me, and I'm definitely going to go talk to our security team to see if we can integrate it. Well, first is, what if you're offline? So I imagine that for a server, the SSO is just another way to log in. You can still use whatever you have as SSH keys or passwords. What about desktops? Like, let's say, your corporate laptop. Are you then, like, what happens if you're offline? Because obviously that's going to happen.
Yes, if you're offline, you're out of luck. So
completely?
I don't think so. I think you did specify that that password.
Yeah, I didn't quite get that part. Is that like a fallback password?
I suspect that it is. If you can't access the issuer location, which was either that microsoftonline.com or the google.com address, I think that that's a fallback, but I would have to defer that question to Masi.
Okay.
I'm going off of intuitively what I think that password is for.
I would expect that's the case. I do know in our implementation that we've had for several years now for Active Directory login, that's how it worked.
Okay.
So I would expect that this is similar.
Okay, okay. All right, second thing, presumably this works on other desktop environments as well, not just GNOME, or?
I would say it's just GNOME for right now,
Okay.
because you have to install our patched GNOME shell, essentially. So that's, because in order to get that QR code in GDM, that's actually running inside a GNOME shell.
Got it.
GDM uses GNOME shell. And other distributions or SD, what's it, SDDM or whatever, those other display managers don't have that yet.
Okay, okay. Well, works for me. I use GNOME, but there may be colleagues using KDE or something. Then are you also thinking of doing something regarding full disk encryption?
We already have that.
Well, there's the TPM automation, right? Yeah, okay. But that's, how does that work in a, sorry, I don't quite remember how that integration works for modern Ubuntu. So let's say I want to have like all the new bells and whistles, and I want to have Google integration with SSO and the full disk encryption through the TPM. What is the workflow in that case when I just boot the computer?
Well, your disk is unlocked from the TPM.
Okay.
So that's disconnected from the authentication to get into your desktop.
Okay.
So the disk is unlocked from the TPM. There's work happening in landscape for key escrow. You probably want to talk about that.
Yeah, it's not a feature that has landed yet, but ultimately, I think what work remains is creating an API from within the Ubuntu desktop world to feed that key in a secure way to the landscape client. And then landscape client will have a secure data store where that key can be stored. So the secure vault exists inside landscape. There's people that poke inside landscape and ask, hey, what's this doing here? Like, why is that there? It's not in use right now, but that's the reason that we've put it there.
So the feature exists already in Ubuntu desktop, but to manage that at scale, you're going to want the, something like the landscape, integration, right? So you can manage your environment.
Maybe I'm going a bit off topic, but if you have it, let's say you have the feature landed and you have your key in escrow in landscape. If it's the TPM that then unlocks the drive, how do you then revoke that key remotely? Can you?
That, I think, is going to be part of the API integration that's going to happen. The purpose of storing the key centrally in landscape is so that users can self-service the recovery of that key if they forget.
Okay.
But we do have a built-in mechanism for revoking those keys on the device. There's going to be some kind of way to orchestrate that as well.
Yeah.
So.
Okay. And just last thing, how production ready is this? Are you already using it for corporate laptops or customer devices when you have to log in remotely?
That's a fair question. So if you look at the documentation, like in the blog post that Massey had published very recently, the official product documentation clearly states that this is in the latest branch, and they have not promoted it to the stable branch. So if you're using the Google IAM connector, know that this is pretty bleeding edge stuff. But the MS Entra ID connector has been out for a while, and
Well,
that's production ready.
For us, we will probably have to wait for Okta. So anyway.
Okay.
We'll
But
wait.
I'm sure it's going to happen.
Yeah.
We've also, we've had Active Directory authentication for years now. I know that's being used heavily in very large organizations. The MS Entra ID stuff is being used by customers. The Google one is brand new. But honestly, one of the motivations to get the Google one out right now is we're going to start using it at Canonical. So we need that for our own corporate laptops at Canonical, and we use Google.
I'm done.
Yeah.
So as far as landscape, what ecosystem can you manage with landscape besides Ubuntu, right?
So there's the in theory answer, and then there's in practice. So in theory, you could enroll any Linux into landscape, and if you're motivated enough, it is possible. The landscape client exists as a snap package, and you can install snaps anywhere where snaps can be installed. So there are certain features missing because that landscape client snap package is intended for Ubuntu core devices. Ubuntu core devices don't have traditional deb packages in there. Some of the user management is done a bit differently. So there are some features that are not present in that snap. Now, hypothetically, what if you took landscape client and installed it on Debian? I published a blog post explaining how to do this maybe a year or two ago. While it is possible to do, it's not recommended, because when you start looking at the security, or rather the software updates available in Debian inside landscape, there's no separation, no distinguishing between security updates and standard bug fix updates. And the other thing is, you're paying for Ubuntu Pro. Why would you want to pay for all of this Ubuntu Pro stuff and then only use this one sliver landscape for a different operating system, and then you're not getting the security patching, you're not getting the kernel live patch, all the other things that you would get if you had just enrolled an Ubuntu machine into landscape. So,
well, you could have a hybrid environment where you do have some other distros in your environment, and maybe it's okay to have some control over those from landscape as opposed to nothing.
let's say hypothetically, if you put the machine into landscape, you're not going to have a good experience with managing it because it has no awareness of RPM packages. If you're putting in a Debian-like machine, it's not distinguishing between different types of security updates. That's one, yeah. And this is all theoretical stuff that I'm saying, but if you called Canonical support and said, hey, I've got these SUSE machines inside landscape, I've got this Debian machine in landscape, and I need help with X, Y, and Z, they're going to scratch their heads and say, we don't know how to support you on this. It's not covered.
Realistically, though, you could probably do things like script execution, like you could run scripts that you know work on the SUSE machines, and as long as the machines are registered, I mean, landscape should go out and run those scripts. But some of the built-in stuff, like, you know, in landscape, you can see all the packages that are installed in your entire estate and which ones have CVEs, that kind of thing. None of that would be surfaced because we're not aware of how to query there. You know, not something we've tried to support.
Yeah, and we're not internally testing that stuff.
Yeah.
So you'd be out there.
Does this replace SSSD?
Yes.
Okay. And what is the minimum I need to try this? Can I do this with my personal Google account? What do I need?
I think it does work with personal Google accounts, yeah.
Okay, thanks.
Any other questions?
5, unless you're an Ubuntu member, then you get 50. Yeah. You didn't know this?
I did not know that.
You've been eligible for a long time. Yes, we'll give you 50 if you're an Ubuntu member. Yeah. Yeah.
So you mentioned adding users as like owners, but you mentioned doing it kind of manually. Is there a way to grab groups from Entra or Google and do it that way?
I know that there are some improvements in this area, but I haven't read the docs. So I'm going to have to defer that question to later. We can review the docs after the session is over and get the answer.
All right. Well, ubuntu.com/blog, it was just posted yesterday, so it should be like maybe the latest one on the blog. If you want to read more about it, check that out. The Google IAM one is there at least, and I think it links to the Entra ID one from the summer or something, right? So lots of information there. Feel free to catch us anytime, ask us questions. Happy to talk. I try to, but I'm not here after today. I'm leaving tomorrow morning, so sorry.
We're going to miss you. Okay. Well, thank you guys very much. That was awesome. Hang out. We got coffee. And I'm going to open the door. I figured out what's happening with the temperature. The thermostat is out there.
Ah.
So I'm going to equalize the temperature and raise this temperature, and then we'll come back and we have some Q&A. So think about the searing, controversial questions you have about Ubuntu, and Nathan will invent answers for that. realize you have booth duty or something. Okay. Wow, it's, okay.
Yeah. I was just saying, can we move to a Q&A?
Can we? You're
Testing. Okay.
We are victims of excellent swag.
We are indeed. The expo hall is really nice.
This is what happens when the swag is good. But every one of you has brought 5 questions each, so we have a rousing session awaiting us.
Oh, are you serious?
Haven't you? Did you not bring your 5 questions?
No. I didn't do my homework. I failed the class.
No, there is something I wanted to ask you.
Okay.
Many people may not know what Ubuntu Studio is. Would you mind?
Sure,
giving a little
I can
chat
talk about that. Ubuntu Studio is primarily for content creation, multimedia, and basically doing anything you can imagine in a studio, whether that be audio production, photography, desktop, I already said desktop publishing, graphic design, music production, you name it, you can do it in Ubuntu Studio. And we have ways that people can install it on their favorite desktop environment on a supported Ubuntu flavor. And yeah, that's pretty much what it is. It's content creation and whatnot.
So you've chosen specific apps and bundled that with...
Yes, we try to choose the best of the best as far as myself and the team have come up with in terms of what works best, what it integrates best with the desktop environment, what is proven to be the most featureful and get the job done the best. So like, for instance, you got KDN Live for video production. We actually have 2 apps for graphic production. It's Krita and GIMP, because there's still this mentality that both of them do the same thing, and then there's also a mentality that both of them do different things. So we figure, why not keep both?
They are different. They're like Painter and Photoshop.
Yeah, but you can do both in each.
So
yeah, so neither here nor there.
And do you have Inkscape?
But yeah, we have Inkscape.
Excellent.
And we also support Scribus, which is one of our, in our desktop publishing meta package. And we also just do things like that, Darktable for photography, Rapid Photo Downloader also for photography to get those pictures off of your SD card. And there's also, like Ardor for audio production reasons, along with over 100 plugins. So you could have tons of audio plugins, whatever you need to do with vocals, instruments, what have you. We even have guitar amp simulators. So you have with Rack-A-Rack is what it's called. Awesome. And guitar, actually not Rack-A-Rack anymore, but because it had a failure to build a while back, so we got rid of it. What is it called? Guitarix, that's what it's called. And it is basically a plugin host that hosts all of its specific plugins, but those plugins could also be used in like Ardor or something, and it does guitar amp simulation. So you plug in your guitar to an audio interface, you run it through this, you can make it sound like it's going through a tube amp.
That is awesome. Okay, now you got my attention.
Okay.
So can you tell us, when did this start? It's been around a long time, as long as I've been in the Ubuntu world.
It's
you've been
the
working hard.
4th.
And how did you begin this, and has it changed significantly as you've gone along?
Yeah, I'll go ahead and answer all 3 of those. It's been around since version 7.10, so we're at 18 years this fall. It's been, at first we started on the GNOME desktop, and then when the GNOME 2 desktop was sunset and everything went to Unity, the Ubuntu Studio team at the time decided to go to XFCE. So starting in 12.04, which was their first actual live CD release, before that it was a alternate install, it became XFCE. And that stayed as XFCE clear up until 20.10. And we decided at that time, it was in 2018 when I got involved with the team and asked the team, we're not tied to our desktop environment. They all kind of had the mentality at the time that XFCE is everything. And I was like, is that really the thing we need to be focusing on? We need to be focusing on our apps and our audio plugins and everything, and our user experience. But do we need to be tied to our desktop environment? They're like, you make a good point. I'm like, check out all the other flavors, and let's get together in a couple weeks and figure out if we want to stay with XFCE forever. And at that time, it was like, yeah, let's stay with XFCE, but let's start a KDE Plasma version. And I was just like, that sounds great. How do we get the seed going for that? And it ended up being, after I talked to people on the technical board, it was like, that's going to have to be a whole new Ubuntu flavor. It's probably not a good idea. So during the 2004 cycle, where I was like, okay, I found out that my lead developer was using KDE Plasma. I found out my lead designer was using KDE Plasma. I really liked KDE Plasma. I was like, maybe we should make that switch. So they're like, okay, you do all the work in the seed. I'm like, okay, fine. So I did all of the work on that in May of 2020. You know, we were in the middle of a pandemic. I had nothing better to do, but I did spend an entire month just grinding at that seed, making sure that the ISO built and everything. And eventually it came out, and people still call that one of the better versions of Ubuntu Studio that we released. And then our first LTS under KDE Plasma was 2204. And we've been with that ever since. So there has been a lot of change then. Also, the shift from jack and pulse audio to Pipewire that happened more recently with 2404. Well, actually 23.04 is where we started that journey.
I don't do as much with audio production.
Yeah,
So I know
okay.
that there was a change.
Yeah.
But I know nothing about the underpinnings, but I'm sure you do. What challenges did you find in that change away from Pulse?
That change away from Pulse was that, but we have still found, because with 2404 coming out and Pipewire being the default, a lot of people have come to us and say, you broke my workflow. I'm like, well, your workflow is still there. You just have to switch back to the old thing, which you can still do with 2404. We can't support it though. Or you have to adapt your workflow and think, I don't need that pulse audio to jack bridge anymore. It's all one thing. So, yeah.
So you're happy as a person who does creative work. You like the new
behind Pipewire. I also work with Robin Garris and Paul Davis of Ardour quite a bit. And they give me a lot of advice on how to help with stuff and change some of things. And I even check the documentation on Pipewire to make sure that what we're doing is the correct way to do something. And as a result, I've got a GUI tool that I wrote myself that helps people change the latency and the sample rate for their various for Pipewire. And then, of course, you throw your audio card into Pro mode, and suddenly it has direct access, no sample rate changes beyond what the computer has been configured for, to be able to use that audio interface.
I'm very appreciative of your time, but I also don't want to hog the mic. I have more questions.
I have a question.
Okay.
So, as the flavor lead for Ubuntu Studio, you must hear from users who are using it all over the world.
Yes.
In all kinds of varied and interesting ways. What is your favorite weird, unexpected way that you learned thing that someone's doing with Ubuntu Studio?
So the first person that came to us a few years ago, he runs an audio book recording studio. And he switched everything at the time over to Ubuntu Studio. He was doing something else, I want to say Arch before, but that became unstable and broke for him several times. He just got tired of it. Went to Ubuntu Studio. He was actually involved with us for a little while and then decided he wanted to do the upstream Debian thing. I don't know why, but he is on Debian now, which is still a win as far as I'm concerned. And then there are 2 radio stations I'm aware of that use Ubuntu Studio. And one recently, I think in South America, just recently within the past couple weeks, did the full-on switch from Windows to Ubuntu Studio as their primary driver for their radio station. So it's it's been things like that, and there's also one gentleman that I know of that uses it for some machine learning stuff, and that tripped me up because I was just like, machine learning, he teaches in a school in Mexico, and I'm like, machine learning, how does that work with our custom tools in Ubuntu Studio? And he explained it to me, and it was way over my head, even as somebody who worked with machine learning stuff as part of the Ubuntu Focus project. And it didn't make much sense to me, but I'm like, okay, you do you, man.
And encourage him to make a YouTube video out of that. I want to see that.
Oh yeah, I think he should too, but he and his students speak mostly Spanish, so it might not translate as well to us. He was actually the guy who inspired Ubuntu to go to the Raspberry Pi. And so that's why we now have a Raspberry Pi architecture install image. And so yeah, I say we because my wife runs that one. She's the flavor lead on that. I'm just her tech person. And this gentleman, his name is Christian, he asked, when can we get this on Raspberry Pi? I'm like, I don't know. And then during the 2404 cycle, I was like, we're working on it. He's like, yes. So we finally got that out. He's been happy. The only problem is he's running older Raspberry Pis, and I have told him you probably need to start getting everything upgraded to the 5. So
yeah, the 5 it's such a leap ahead of everything.
And it costs the same.
That's kind of amazing when you think about it. Yeah. Am I hogging? Do you guys have questions? Okay, we have another question. I'll go ahead and take a break, so just for you.
I have a burning question, probably off topic. But is anybody familiar with Windows subsystem for Linux? Any comments on it?
I can answer a little bit. He can answer a lot because he answered some of mine. Very faint.
It's on.
Is there a volume?
Check battery.
Interesting. Thank you. So the good news is that this is probably one of the better places and rooms that you could have asked that question in, because we have a lot of experts here. So, well, let's hear the question first, and then I can.
Do you have a question about WSL, or you just want thoughts on it? Okay.
Okay.
I figure it's a severe compromise on validation.
Oh, it's not a compromise at all.
So to repeat, he says he assumes it's a severe compromise and wanted validation, and I can say that WSL running Ubuntu, or Debian, or SUSE, or Fedora, or anything else, you're really running, say, Ubuntu. You're really running Ubuntu. You're really running it from the repositories. So it's not identical, but it's very close for a lot of things.
Yeah, and our team, the desktop team at Canonical, builds those images and works very closely with Microsoft. We have a fantastic relationship with that team at Microsoft. They are super supportive. We've worked together with them for many years on this. They've done a phenomenal job of integration, and it is wildly popular. Many millions of people use WSL every day. It's great, and it's the back end for a lot of other tools. So you may install something on your machine to do, say, AI development. And under the covers, it's actually using Ubuntu and WSL, like Microsoft AI Studio, for example, things like that. It can offload those sorts of workloads to a more familiar environment for those types of tools. Some workloads just, better suited. It's really a great developer story, is what it is, which is why Microsoft invested in it. They needed a better developer story.
Yeah, and so as difficult as it might be, or surprising as it might be to believe, they were very sincere about that, making it really first class for developers because they want developers to keep using Windows on the desktop. And so, yeah, if you install WSL and Visual Studio Code, it'll detect, you launch code, it detects WSL, it suggests, you can say yes or no, the extension, and then suddenly you can see your file tree, you hit compile, it runs in WSL on Linux, and it's exactly or very close to exactly how you develop on Windows. It's just seamless.
And if you install a graphical app, the icon shows up in your start menu in Windows with a little penguin in the corner of it, a little penguin emblem. So you could snap install GNOME Calculator, and you get the GNOME Calculator on Windows, and it runs in WSL. But you can't even tell. You click on the icon, it just looks like any other app. Great.
And people were angry, what, around 1704, 1710, when Canonical snapped GNOME Calculator.
I know, right? Now you can run it on Windows.
Yeah, I recently got a laptop, and on a laptop, the only thing I need with Linux is to shell into servers. Otherwise, it's just, I need a browser, I need some graphics tools, that's about it. I usually use Linux because that's what I do. I am now unclean because it came with Windows, and I did need a Windows system for testing for a project I'm working on. But while I'm there, I heard about how great WSL is these days. So here's a very recent user experience testimony. I've got this Windows machine, and I was going to wipe it and put Linux on like I normally do, but I have a project that needs me to keep it there longer, but I need to get my servers access. So I opened up Terminal, and I turn on WSL, and I just type bash. And I'm in the bash environment I've always known. And you can even set the parameters for the bash window, so it looks just like Ubuntu with that deep burgundy and a slight translucence. And I forget I'm in Windows because I'm on my Linux server talking with the bash I love using my app. It's the same environment.
Yeah, the only main difference maybe is, unfortunately, it's bring your own font. So you have to go to, I think, font.ubuntu.com.
Oh, actually, that was one of the outcomes from having the last Ubuntu Summit at The Hague. It is now a crime against humanity to use any computing system without having installed the Ubuntu font.
Yes. So maybe someone should talk to Microsoft about Ubuntu font. But it's just, it feels like home in that little window, or maximized window. So,
are there people, show of hands, does anybody run any computer of any brand without having installed the Ubuntu font? Because it's a really good design. Like, yeah, who would do that?
I only run Ubuntu, so.
Yeah, good, bad, but of course. But like, I have it on my Mac, I have it on my Windows. I don't know how how do you run a computer without putting the Ubuntu font on it first?
Yeah,
That's just silly.
I talked my way to the beta test for Ubuntu Mono and was immediately, or maybe the Ubuntu font altogether. I don't remember, Mono was different, like 2007. Well, okay, so yeah, Ubuntu Mono immediately became my favorite monospace font because it's monospace, it's clear and legible, no 1 LI, all that stuff. You can tell the difference. It still looks like the Ubuntu font, and it looks like a proportional font while still being a monospace font. It's not weird, blocky. It's like, oh, this looks really good. So, yeah, I can't bring myself to change the Windows console to Ubuntu font and run a Windows command prompt, command shell. But yeah, it's my favorite monospace font. It's just really great.
It's among the few fonts where the difference between period and comma is visible at distances of greater than 2 feet.
Do we have any other questions? Not at the moment, or? So the nice thing about this is a very, very small group gathering, but the good news with that, we decided to go ahead anyway, we can guarantee that we will get to everyone's questions.
I have another question, though.
Okay.
But it's more Ubuntu Studio stuff. Do you guys mind? Because the thing is, a lot of my friends are creatives, right? So I have graphic artists, and I have a lot of musician friends. I do have a subset of friends who are both musicians and graphic artists, but very few.
Huh.
So have you heard feedback from anyone saying, why not just graphics or just music, or is it extra work for you to do both, or why the decision for all of that? Because it's a pretty broad spectrum of tools you have.
That is several releases pre-Eric. And I don't know why that decision was made. I also led Fedora Jam for a little while, which is specifically music and audio production. And yeah, that question does come up. It's like, why not focus on just one? And talking to the people who were involved at the time, who are still on the team today, they are like, it's because it's studio. It is not just audio. It is graphics is anything, okay, let's take the desktop analogy, you know, how you have your folders and your pencils and whatnot for an actual desktop, when you want to get work done on an actual desktop, the desktop metaphor. This is the studio metaphor, where anything you could do in a physical studio, we want to be able to bring to the desktop. So whether that is a drawing studio, or, I mean, it's in the repositories for, like CAD would be in that architecture studio, paint studio, photography studio, things like that. Oh, really? 5 minutes? You're giving me that? Okay. So I was just embellishing, but I can go ahead and stop. Yes.
I have no idea. Are you familiar with DaVinci Resolve?
Yes, very familiar with it. Actually, at one of the places I used to work for, we had experimented with it. And I often get the question, and it's mostly posted to our X/Twitter account, why can't you guys pre-install DaVinci Resolve? Or can you do that? Can I make one request? Can you install that? And the reason is it's not open source software. It has to be open source software in order for us to package it and pre-install it and have it in the repositories, or even as a pre-installed snap. If they wanted to create their own snap, they're more than welcome to, but we still can't pre-install it.
I have like 30 minutes of questions about Ubuntu too. Okay.
We can do one.
We're going to have you come back. Do you mind?
I don't mind at all.
Okay.
Yeah. And I might bring my wife, who is the Ubuntu lead.
This is my first time meeting him, see, and because I have so many creatives in my life, I've been looking forward to this moment. That's why these are my pent-up questions. Thank you for being so kind about addressing them.
Yeah.
Do we want a group photo? There's us, but we are the people here at the end of the day. We have done this before. Yeah? Oh, that's right, because we have everyone coming in. Let's do that tomorrow, because then we got all the people who are still in transit. That's a smart move. Okay, you get the last 2 minutes, Nathan. I have a question for you. What are you going to do for 2 minutes?
So I'd like to entertain you all to my interpretive dance of snaps versus flatpaks. Yeah, that was. I glanced at my watch and I knew those cards were there, and that was. I'm very tired because I've been traveling, and that was like the brightest moment of the last half hour. So, what I really love about UbuCon is that, well, one, it's a really great idea. And so I was really, really happy when Amber Grainer told me it was a great idea and to go and do it. And we didn't have much time, and maybe a month or two, and SCaLE said, sure. And I put out to the community, hey, do we have any talks? Anyone local? Anyone coming to SCaLE? And people were like, yes. And we had more talks than we had room for. And then the room filled, and it was a new concept. So we had two-thirds, 75% of the room filled up. And so, well, the speaker was speaking, I ran to SCaLE and got more chairs, and they filled more chairs, and then those immediately filled up. And then by, not much longer, it was standing room only. So we got to do it again and again. And so I get to, people like it, enjoy it, but I get to meet the most amazing people working on Ubuntu, working in Canonical, working in the community with Ubuntu. And that's really one of the nicest things. So Ubuntu Summit, we did it first, in some ways. So that's been really, really, really great. And at the Ubuntu booth as well, we get to meet so many different people from so many different places. I'm not ever going to talk to microcloud people on the internet because I'm too dumb for that. I'm too smart in other things, and I'm not a developer. But they're at the booth. I'm learning all about this. And we had Ubuntu Focus come and provide a laptop for the speakers here today. And they have two systems, a laptop and a Nook device, a super powerful one, at the booth. And they volunteered to come here, and they got to show off on, well, they're selling them and making them, but they believe in Ubuntu. And that's a product that runs with Ubuntu based on that. And we can see They're great guys too, but you get to see that cool thing, and I get to talk to them, and that wasn't really on my radar. I'd heard of it, and System 76 is across the way, and we could talk with them, and Carl Rochelle's great. And
our featured workshop last time, Nextcloud, is here this year at SCaLE.
Oh, that's right. Yeah, Nextcloud's here. They're great. Everyone in that booth, Debian, Fedora, SUSE, they're all fantastic. So I think it's OpenSUSE. So we get to, so you can turn the music off. I'm almost done, promise. So this has been a really great opportunity to not only get to know all these great people, Canonical and the Ubuntu community, but also showcase the work others have done and really answer people's questions where they just are working with Ubuntu and they're just not really sure they want to do this or they don't know how this, or is there a feature, or what are we working on, or what's next, or how do I get answers? And I get to do that all weekend long alongside other people who are just as dedicated, actually more dedicated than I am because they have paychecks, but it's been fantastic. And of course I get to see my friend Richard once again, which I was
and we get another year with, because I'm old, and in the olden days of the UbuCon, we used to have different community managements. And then there were many changes over the many years. But today, the company has changed, and it's in a good place. And Aaron is the community team. I mean, Aaron has a community team. Aaron is the lead for that. And, anybody in the home office watching, the man does his job really well. Our meetings are productive, focused. It takes a lot of little steps to do our little one-day thing here. So many parts, and the booths, and all of that. Thank you for all your good work.
Yes,
I appreciate it.
thank you for making this a huge success this year, and last year, and the year before, and the Canonical's continued support is fantastic. So,
and that's the gratitude for just the ecosystem, both the community and the company, with good mutual respect and coordination is something that some Twitter drama open source projects could learn from and be inspired by it and rise above to meet.
Yep. So I think that wraps it up. Thanks everyone.
For tomorrow's group shot at the booth.